will be a Starfreelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Hello dear students, in this lesson we'll learn basics of unit testing. We're going to learn today what unit testing is. You'll understand basic principles of unit testing. And after that we're going to review libraries for unit testing in Java. We'll focus our attention on one of the most popular libraries for unit testing in Java, JUnit. I will explain you basic structure of this library and will teach you how to add external libraries to your project in Eclipse. By the end of the lesson, you'll write your first unit test. During the lesson, I will share with you tips and best practices of writing unit tests. So, be prepared for interesting lecture and learn a lot of new things. Let's start! At the beginning of the lesson, we will talk about theory of unit testing to make sure that by the moment we start write our first unit test, you understand what we are going to do. In the middle of our lesson, we'll learn how to use JUnit library for unit testing in Java. And at the end of the lesson, we'll dive deeper in the specifics of writing unit tests. From the previous lesson, you remember that unit testing helps us to test each specific unit of compilation. That is our classes. With unit tests, we have possibility and tool to verify that each unit behaves in the way it expects to behave. Does it mean that your program works 100% correct? Not necessarily. Why? Because each specific unit can work as expected. But together few classes don't work as expected. Either some invalid input or one module works with a specific range of data that is invalid relatively to another class, or we missed some specific test case and the only reason our unit test passed successfully is that because it's simply absent. A unit test is a piece of code written by a developer that executes a specific functionality in the code to be tested and asserts a certain behavior or state. Each test contains specific assert that will verify specific state. The percentage of code which is tested by unit test is typically called test coverage. We'll learn tools that help us to verify test code coverage in other lessons. Unit tests are not suitable for testing complex user interfaces or component interactions. For this, you should develop integration tests. But unit tests can detect issues as early as possible. They form the base of our test pyramid. Now, let's review basic principles of unit testing. There are simple rules that we need to follow to make sure our unit tests are efficient. They are: the first rule, one assertion per test, or single concept by test. That means, in case we test discount calculation, we don't have to create one test that tests calculation of discount for virtual card with one product with total price of $100 and in the same test verify amount of discount in case of the card with total price $1,000. In other words, one test shouldn't verify different test cases in scope of the same test. There are some exceptions when there is single concept by test. In this case, we test money transferring from one account to another, and we have test case that should verify money transaction. In this case, we have to check that on one account amount of money was decreased, because we sent them to another account, and on the another account amount of money should be increased. That's called single concept by test. And we have two verifications in scope of the same test. We need to separate tests by scenarios to be able to catch error faster and to understand what specific scenario didn't pass. The second rule of unit testing is that we have to test one single object at a time. In case we test some service, for example order management service, we shouldn't test order storing service at the same time. Unit testing is about testing one single unit in isolation and without testing simultaneously different units. We have to test each unit separately and independently to make sure that the root cause of the error is in this specific unit, and that the test case failure is not caused by another class. That's why during the unit testing you wanna isolate units from each other and test only one object at a time. And the third rule, one of the most important ones, choose meaningful test method names. Why it is so important? Because, as you remember, one of the functions of testing is to serve as a documentation. That's why it is critically important to give meaningful names to each test. Tests should be readable. Well, all code should be readable, but this is critical especially for tests. That's why it is okay to have extremely long method names in unit tests that clearly describes test case. It is also important to give clear names to all constants. There is also an anti-pattern that is called magic numbers. Magic numbers are numbers that is not clear where do they come from. Whether this is maximum valid value or minimum value, or this is just a random value, what does it mean? That's why each number should be assigned to a specific constant with the relevant name, especially in tests. Now you know main rules that can be applied to each your unit test. Let's proceed. Now I'd like to discuss with you a few more testing principles. There are a set of principles called FIRST. That is acronym composed from the first letters of the principle's name. In a minute you will believe me that this is not just a fancy word, but indeed set of useful principles. Let's start from the first one. F stands for fast. A developer should not hesitate to run unit tests because they are very slow and he needs to grab a cup of coffee to wait till all verifications will be done. Nobody should be scared of running your unit tests because of the time they take. Setup of each precondition, test and teardown should execute really fast. I mean, it is a matter of milliseconds, because there are thousands of unit tests in one project. The next letter is I. I stands for independent or isolated. Each test should be isolated from external environment. Each test should be independent of anything else like another test, environment variables, specific user input and so on. In case you expect from user input, simulate it for each specific test, because it may be different. Show that your code can work with the range of values and the result will be different. We'll talk a little bit later how to make sure that we wrote enough tests to avoid the case when you write hundreds of tests that test actually the same thing. There was a case in my life when a colleague of mine from United Kingdom wrote a test that passed successfully only in his time zone. In time zone of team members from other countries, it failed. Remember, if you use time in assertion of your test, make sure it doesn't depend from the time zone. JDK contains a lot of classes and tools to work with time and to imitate specific time zone, so make sure your tests are independent. Let's go forward. R stands for repeatable. That means that multiple execution of tests should provide us with the same result in case nothing was changed in the source code. For example, you wrote tests that checks registration process. After user sign-up, information about user should be inserted in database. And after you pasted user info in a database and run test one more time, it failed because user with such ID or email already exists in database. Can you understand this example? That means, even if you perform any data manipulations with database in our example, you have to clean up everything after each test is finished. And I believe that you understood that database is just one of examples. The main idea is the following. In case your test, in some way, change the environment, you have to clean up everything after test is finished. Result of each test should be deterministic. Developer should take control of everything what is going on in the test to reproduce different live cases. Each test should set up its own data and should not depend on any external factors to run its test. The next letter is S. S stands for self-validating. No manual inspection whether test is passed or not is required. The same, no manual configuration is required to execute test. To run test, make sure that database is clear. Or to run this test, make sure that resource folder is clean. You shouldn't declare any conditions like this. And the last letter is T. In different sources of literature, it is explained in a bit different way. Somebody tells that T stands for thoroughly, and somebody tells that T stands for timely. I would say that both of these statements are important. Thorough means the next. Should cover all the happy paths. Try covering all the edge cases where the author would feel the function would fail. Test for illegal arguments and variables. Test for security and other issues. Test for large values. What would a large input do to their program? Should try to cover every use case scenario and not just aim for 100% test code coverage. And timely means that tests should be written right on time. That means together with the code creation and even better before code creation. I'm talking about so-called test-driven development. We'll talk about this in a separate lesson, so don't be bothered about it right now. Just remember that the best practice is to write tests even before you created code. On this slide, I'd like to talk with you about each test case structure. I'm talking about so-called build, operate, check pattern. Somebody also called this 3A pattern. Also, it is similar to given when then approach described in BAD technique. What all these patterns are about? These patterns are about basic test structure. Let's review first build, operate, check pattern. We build up test data first. That is so-called precondition. For each test, we have to reproduce specific state of the system at a specific moment of time to verify how system behaves. For example, we set amount of products in our virtual cart and we associate this cart with a specific user. And after that, we operate on that data. We perform some action. In this part, we call some specific method to change the state of our test object. And in the last part, it is called check. We perform validation. Specific assertion should be performed in this part of the test. We verify that actual state of our test object is equal to our expected state to make sure the test passed successfully. The next pattern is called 3A. It is about the same. 3A stands for arrange, act, and assert. In arrange part, we prepare data. In act part, we modify that data by calling some methods, and in assert part, we perform assertion. A bit later in this course, we are going to learn BDD. But already now you can understand that to describe expected behavior, we can use given when then pattern. Given part describes what we have at the beginning, what original state of our system is. When part describes the specific action. When something has happened, then it turns out that we have such result. So in then part, we have assertion to verify our behavior. Now you know basic structure of each test case. Let's get closer to the technical part now. There are different libraries exist to write and run unit tests in Java. When I say library, I mean code that was already written, compiled, and packed into the archive. Today we also are going to learn how to add these archives to our project to use code that was already written. But first, let's review some of the libraries. JUnit, probably the most popular library for unit testing in Java. And another popular library for unit testing is testng. NG stands for new generation. These two libraries are both similar and provide the same list of features. You can make similar configurations, but in a bit different way in each of these libraries. With the exception that testng offers some more features that JUnit doesn't have. But in most cases, JUnit is more popular for unit testing in my opinion. We'll learn some basic principles and we are going to learn JUnit first, and after that it will be easier for you to apply this knowledge with other frameworks like testng. In this course we are going to learn the latest based on today's version of JUnit. I am talking about JUnit version 5. It is also called Jupyter. In case you use JUnit 4 in your project, or probably new version of JUnit will be released in the nearest future, I would say that updates are not critical. Moreover, core principles are the same in every framework for unit testing. There might be specifics in implementation of one or another method in newer version, and probably some new annotations or methods. But again, it is not critical for understanding of the whole picture. So, don't worry, and proceed with learning JUnit on the example of JUnit version 5. JUnit 5 consists of different modules. They are JUnit Platform, JUnit Jupyter, JUnit Vintage. The JUnit platform serves as a foundation for launching testing frameworks on the Java virtual machine. It also defines the test engine API for developing a testing framework that runs on the platform. Also, the platform provides a console launcher to launch the platform from the command line. JUnit Jupyter is a combination of the new programming model and extension model for writing tests and extensions in JUnit 5. The Jupyter sub-project provides a test engine for running Jupyter-based tests on the platform. JUnit Vintage provides a test engine for running JUnit 3 and JUnit 4 based tests on the platform. There are a bit different API in different versions of JUnit, and this module enables the compatibility between different APIs. In this course, we are going to learn features of this powerful library on the real examples. For this course, I am going to use official documentation and real-life examples. I will share with you experience from my projects to help you learn best practices of writing unit tests. Now, I suggest to jump directly to examples to help you understand technical part of unit testing. Let's create first simple class that we are going to test. I created all classes before the lesson, but I will walk you through all of them. Here is simple class calculator. It contains one single method that performs addition. As you can see, nothing special here. Our main goal in this lesson to learn technical side of unit test creation. Usually for all tests, separate source folder is created. Why do we need separate source folder? Because at the end of the day, you have to compile all your source code, pack it in one archive and deploy it on the web server or run it separately on the desktop. And you don't need tests to make your code run. Unit tests usually needed during the development, but not in production. That's why we would love to group all tests in the separate source folder to keep and track them separately. When we learn build tools and build scripts, you will see that it will be easy to separate source code of our program from the source code of our tests, and we will not include tests in our final program archive. It will help us to save some space and memory. That's why the first thing you have to do on your computer is to create another source folder. How to do this? Mouse right-click on your project, then select New and select Folder. Write Test here and create this folder by pressing Finish button. I wouldn't create this folder because I already created it. The next thing I have to do is to tell Eclipse that I want it to treat my new folder as a source folder. A source folder is marked by Eclipse as containing Java sources. Then, when you compile your project, Eclipse will look for your source code into all your source folders. You can make any folder become a source folder, adding it to the Java build path. Thus, next time you compile your project, Eclipse will also look for Java classes in that folder. How to do this? Press mouse right-click on your test folder. Hover over build path and select Use as a source folder. And you can see that now test folder is marked as a source folder and all Java sources inside will be compiled. I already have here a lot of tests that test your homework. I will not focus on them today. Instead, we are going to create new tests with you for our calculator. I press mouse right-click on this folder and select New, and here I click on JUnit test case. The first thing that we have to understand that each test is a separate method within the test class. So, creating test case, we created a class where we'll describe methods. Usually, test classes are placed in the same package as class that we wanna test. In our particular case, it is a package where we created calculator class. As you can see on the screen, it is the following package: com, ltbools, learnit, java core, JUnit 5. Let's write the package name in the relevant field in our wizard. Now we have to give our class a name. It is not a critical thing what name we are going to give, but it should be clear what class we are going to test. That's why let's call our new class calculator test. Do not forget to select JUnit Jupyter test radio button on the top here. Press Finish button. And now you can see another pop-up. Eclipse is smart enough to understand that we don't have JUnit Jupyter libraries in our class path, and it will be impossible to run tests without these libraries. You can add all necessary dependencies related to JUnit 5. Just keep selected the last radio button from this list and press OK button. And here's our test tab is created. So, what was changed? Let me show you. Mouse right-click on any file in the project and select Build Path, Configure Build Path. Go to Libraries tab, and here under Class Path you can see all libraries that are added to your project right now. You can see that I also added manually JUnit 4 with Hamcrest libraries. I will explain you in other lessons what do we need it for. And there you can see that JUnit 5 was added. You can see that each file has jar extension. Jar stands for Java Archive. That is typical extension for the group of combined classes. In case you would need to add your custom library to a project, you always can do it by pressing on Class Path first, and after that press Add External Jars. And here you will be able to specify the path to the jars that you wanna add. That is simple. Now, let me close all these widgets. Here is our test. By default, there are few imports here. They are static methods from assertions class. In previous version of JUnit, in JUnit version 4, there was an assert class with static methods that perform assertions. And our second import is a test annotation. This annotation is used to mark each test that should be performed separately as a single test. Specific class that runs our tests, it is called runner class. It verifies all methods that have annotation test to run all tests independently. We'll learn different runners and how they work in the following lessons. After this annotation method is described. In JUnit documentation you can see that each time they provide code example, they use default access modifier for methods. Each test should have void return type. In this particular case, stub method was generated and it calls method from assertions class that fails our test by default. Let's create our test to verify that addition works as expected. Let's create instance of our calculator type. That is our build part of the test. After that, let's call add method and pass two ints there. That is our operate part in the terms of build operate check pattern. We'll assign the value that is returned from this method to actual int variable. And now, the final part of our test, it is check part. During the course we are going to learn different assertions that will help you to perform verifications. Majority of them from assertions class that we imported on the top of our file. I call assert equals method to compare expected and actual values. I pass expected value first, and after that I pass actual value. In case they will be equal, test will pass. In case they won't be equal, test will fail. Let's run our test. I press Ctrl and F11 together to run the test. And here you can find specific JUnit view to check result of our tests. I can see that my test successfully passed. In case expected value won't be equal to actual, the test would fail. Just for the sake of the demo, let me change 5 to 6 here as expected result. I run test again, and you can see assertion failed error. Expected 6, but was 5. That's how you can customize data input to test different cases. Congratulations, we have just written your first unit test. We still have a lot of things to learn, but we already wrote our first test. We learned a lot for today, so I suggest to recap what we have learned in this lesson and proceed with more information in the next lessons. Today we learned what unit testing is. You learned unit test rules. Also in this lesson I explained to you what first principles are. Now you know the basic structure of unit tests. We reviewed such patterns as build operate check, 3A and given when then. I hold an overview of two the most popular libraries for unit testing in Java. After that, we dived into the details of JUnit. You learned how to enable JUnit support in Eclipse and we wrote your first JUnit test. That's all for this lesson. Thanks a lot for your attention. See you in the next lesson. Hello dear students, in this lesson we are going to dive into specifics of JUnit library and learn JUnit API. By this lesson you already know what unit testing is. You also know basic principles of unit testing. So in this lesson we'll focus our attention on tools and API that is provided by JUnit to help us create reliable suite of tests. We'll learn specifics of JUnit 5 and compare it with JUnit 4, because even nowadays JUnit 4 is very popular, and JUnit 5 has module that helps us to run tests that are written with JUnit 4. That's why knowing specifics of both libraries is important in my opinion. In this lesson, we are going to learn how to declare methods in JUnit that will help us to set up environment before execution of each test case and clean up environment after each test case execution. During this lesson, I will show you code examples and we will cover specific code with tests. You will learn how to use test annotation. Also, we will learn equivalence class partitioning technique. On real examples, you will see how it can help us to save time and write tests that really helps us to test all possible test cases. And at the end of the lesson, I will show you how to test exceptions with JUnit. We have a lot of things to learn. In this lesson, we are going to have a lot of coding examples and live demo. So, let's start. First of all, I want to highlight you source of information to learn JUnit. Always rely only on official documentation. Information in books may be not relevant. Information in some tutorials may not contain all the details and specifics. So, knowing where official documentation is located is always useful. I will leave this link in attachments to the video, but let me also make a brief overview. Here you can see a list of all modules. As we keep learning JUnit, you will gradually learn all of these. We can explore each module by clicking on it. If you remember, in previous lesson we wrote our first unit test, and we used assert equals method from assertions class. Let's find this class and learn what other methods are located there. To find assertions class, just click on org JUnit Jupyter API module. After choose org JUnit Jupyter API package. And here you can find list of interfaces and list of classes from this package. Here is our assertions class. Let's open it. And here is full list of methods. You can click on any method that is interesting for you to learn documentation. Hope this example helps you understand how you can find documentation by using module name, package name, and class name. So, in case something will remain unclear even after today's lesson, you can always open documentation to read it. Let's proceed. I open Eclipse. I suggest to learn first two classes that we are going to cover with tests today. We have class with name money transaction service. It has one method, transfer money. This method takes two accounts as arguments. They are account from, that is from where money should be sent, and account to, this is where money should be sent, and amount of money to send. Let me show you the source code of account class. Account is a separate class that is located in the same package with current example. For the sake of the demo, it contains only one field, default constructor, and constructor with one argument. Additionally, we have getters and setters here. That's it. Let's get back now to money transaction service. Here in transfer money method you can see few checks. It is important to understand the logic of the method to be able to write a test for it. In case account from or account to is null, we throw illegal argument exception with this message. In case money amount is less or equal to 0, we throw illegal argument exception but with different error message. In case account from doesn't have enough money for this transaction, we throw our custom exception, not enough money exception. And only after all these checks, we can perform a transaction. We decrease amount of money for account from, and we increase amount of money for account to. And we return true in case transaction is successful. The simple example that is really close to real life case. And today we are going to cover this unit with unit tests. Let's start. From previous lesson you already know that it is recommended to create test in the separate source folder. I already created this test before the lesson to save time during the video. I called this test class money transaction service test. I will walk you through each line one by one. First of all, I declare a field in my test class. This field has type of unit that we are going to test, money transaction service. I call variable test instance. I have to initialize it. Don't pay attention to these constants right now, you will understand a little bit later in this lesson why do we need them. Usually we create special methods that will be executed before each test method. Why it is important? You remember first principles. Each test should be isolated from another. That's why it is important that during each test I create new instance of money transaction service because potentially this object may have some states that will be adjusted by one test and that will impact on the execution of another test. This special method has annotation before each. Annotations are meta information for JUnit, namely for the class that is going to execute our tests, the group of classes that executes tests called runners. The runner will verify what method in class has before each annotation. It will memorize it and will run this method before each test method. In JUnit 4 there was a similar annotation, before. As you can see, there is no so big difference between JUnit 4 and JUnit 5 so far. In this method I initialize my test instance. Usually, common configuration that is important for each test is placed in this method. But we have only one line. Pay attention that this method has void return type. You can name this method as you wish, but I usually name it setup. In JUnit we also can configure methods that will be executed after each test. This method has annotation after each in JUnit 5 and after in JUnit 4. In our particular case, there are no need to perform any actions after each test, but you can clean up something what was done by your test to stay aligned with repeatable and isolated principles. There are also two specific annotations that allows us to execute specific code before all test methods and after all test methods. We can create method and mark it with before all annotation. This method will be executed before all test methods. Pay attention that this method has static modifier. In case you use JUnit 4, you can use before class annotation. Similar to this annotation, we have another one. Mark your static method with after all annotation, and this method will be executed after all test methods. In JUnit 4, you can use after class annotation instead. To be honest, these cases are very specific. Why? Because you wanna isolate each test case from another. That's why performing some specific action before running all test cases and running some method only after all test cases means that all test cases have something in common. While this could be the case sometimes, this is very rare based on my experience. So, remember these annotations and use them when you need. But most likely, before each and after each will be enough for you in most cases. Let's move on. Now, let's write test. Each test is a separate method that is marked with annotation test. Each test method has void return type. In JUnit 5, it is important that test method has any access modifier that is not private. In JUnit 4, it is important that test method should have public access modifier. That is minor change, but still, this is worth to mention in my opinion. As you remember, it is important to give meaningful names to our tests to make sure that everyone understands what this method is about. Some tutors and tutorials that teach you to test methods also teach you how to name methods. In case we test transfer money method, we have to write transfer money test. In other words, just add test suffix at the end of the method. But, in my opinion, it is more important to not just make sure that you have test for some specific method. I would rather prefer to make sure that method behaves in the way I expect it behaves, and I wanna reflect this in method name. That's why I recommend you to make sure that method names are named after expected behavior. Always remember that your tests are documentation. Just tell in this documentation what your test unit should be able to do and how it should behave. In case our unit should be able to transfer money, let's call this method in this way. Should transfer money from one account to another. That's why one of the ways to name your methods is to start name it from should word and describe what your unit should be able to do. This makes things clearer, don't you think so? Now let's explore the test itself. I write tests according given when then pattern. We have two accounts. Pay attention that I don't have any magic numbers in my code. Instead, I declare constants that clearly describe what this value for. For example, in my test I have to have some random value for amount of money. That's why I called this constant in the same way, random money amount. In case this is 0, I call it 0 money amount. Here is one note. Some tools for static code analysis doesn't treat 0 and 1 values as magic numbers, because usually it is clear when you use 0 and 1. It is not so confusing as using another numbers. For example, In case you used 0, it is clear that you used 0 to set 0 money amount for account. But in case you use 3, it is not clear why you use 3 but not 5 and not 10. Can you understand now what are magic numbers? But still, in tests, I prefer to give a name even to 0 and 1 values. That's my style, but you can decide and choose yours. Next part of the method is my when part. I wanna execute method. I pass 2 accounts there and money amount. I know that this money amount is valid money amount because I created first account with such money amount. So I know that money transaction should be successful and my test should pass. Now I have final part of my test, that is assertion part. And this is the case when I can perform 2 assertions in one test, because 2 assertions are connected with a single concept. I have to verify that amount of money is decreased to 0 on the first account and amount of money is increased on the second account. That's why I have these 2 assertions in one test case. I use assert equals method and pass expected and actual value to it. You already know this assertion from previous lesson, so nothing special here. Now let me run this test. One more tip. In case you work in Eclipse and you want to execute only one single test, but not all tests from the class, make sure that your cursor is near the test method name. For example, here is my cursor. Can you see it? You can run test by pressing mouse right click and choosing run as unit test. But I love to use shortcuts. And now I press Ctrl and F11. And here in test results, you can see that only one method was executed and it passed. In case I have cursor placed in any other place and I press Ctrl and F11, then all tests are executed. And in test results, now you can see more than one test. Is that clear? So, my test passed as I expected. But in this specific case, I still won't be happy. My experience tells me that I shouldn't believe to the test that I have never seen red, or in other words, failed. Why? Because there are some cases when you run the test and it is green and you are happy, but when some defect is popped up, you are wondering why unit test wasn't failed, and you learn that your test is never red, even when you specify wrong expected value. Not diving into the details right now, but it could be that you wrote your test that is always passed because you missed some minor detail. That's why writing test first is good, because you are always sure that you saw this test failing and you saw this test passed. My advice is, in case you write your test after you already wrote the code, just spend 2 more seconds to test it with some invalid expected value. For example, here in expected value I would specify some random value and will run the test one more time. Now I see that test is failed and I can be calm and sleep well. My test is useful and it will tell me in case something will go wrong during the transaction. I will return the valid expected value and will proceed with the next test. I wanna ask you an interesting question that I always ask during the interview when I wanna verify whether a person can write tests efficiently. The question is, how you can be sure that you wrote enough tests? For example, we test money transaction with some random value. This random value is equal to the amount of money on the account before money transaction. How many more tests would you write? Would you write now a test with transferring money with another random value? Or you would set twice as much money on the account and you would transfer only half of the money? Will this test have sense? And do you need to write it or no? Press pause and take a minute to think about this question. How would you answer? I expect to hear that you know what equivalence class partitioning is. What is this? This is a software testing technique that divides the input data of a software unit into partitions of equivalent data from which test cases can be derived. In principle, test cases are designed to cover each partition at least once. This technique tries to define test cases that uncover classes of errors, thereby reducing the total number of test cases that must be developed. An advantage of this approach is reduction in the time required for testing software due to less number of test cases. How to apply this knowledge while writing unit tests? Before writing any suite of tests, sit down and think about all possible inputs to your method. Group these inputs and write test for only one example of data input from each group. How to apply this knowledge in our example? Let me show you. For example, do you need to write test to test money transaction of another positive money amount? No, because 100, that is our random value, the same as 50, the same as 20, are all in the same equivalence class. These are all numbers that are greater than or equal to amount of money that are currently on the account number 1. By the way, let me switch to the implementation class. Can you see this if clause? I check whether money amount to transfer is no more than current amount of money on the account. That means we defined our first equivalence class. Is it clear? And that is how this technique can help us to save time by writing less number of tests, but at the same time be sure that we have set of tests that will secure us. Let's now proceed with defining our next set of data for testing. Based on our source code, we also know that there are different conditions when exception is thrown. Our next test method sounds like this. Should throw exception if account from is null. I create first account variable that is referencing to null. I create the second account. And now I call another method from assertions class. The method is called assert_throws. This method verifies that you have exceptions of specific type after invocation of some method. The test will pass only in case error of this type, in our case this is illegal argument exception, is thrown. In case there were no exception or was exception of another type, the test will be failed. Assert_throws takes two arguments. The first argument is a class of expected exception, and the second argument is a function that will execute any method you need. Usually we describe this with the help of lambda expression. As you can see, I call transfer money method from lambda function. Does it make sense? One more interesting thing to note here. Let me open the source code of our class that we are testing. If you remember, in our method we throw illegal argument exception in three cases. When account from is null, when account to is null, and when money amount to transfer is less than or equal to 0. How to understand when I get exception because of invalid account argument or because of invalid money amount argument? Especially for this, I used messages in exceptions. Let's get back to our test. Assert_throws method returns the reference to exception object. I can capture it and assign it to a variable. The next thing that I will do, I will check that message of exception exactly the message that I expect to have. Now I can be sure that in case this assertion will pass, that would mean that I received exactly the illegal argument exception that I expected. Does it make sense? In JUnit 4, you had an opportunity to specify type of expected exception near test annotation just like this. You write expected word in parentheses and specify class of exception that you expect. You can see that in this case I use annotation from another package, that is JUnit 4 package. I showed it just for the sake of the example how to test similar case in JUnit 4. The next test case is similar to the current one. We just test the same in case account to is null. What other cases we have? We also throw not enough money exception in case we wanna transfer more money than we actually have. We have test to verify exception in case we try to send negative money amount. And the same error in case we wanna transfer 0. Now, it looks like we tested all possible cases. We learned a lot for today. Let's recap what we have learned today. In this lesson, we learned where to find JUnit documentation and how to use it. We learned annotations that will help us to set up environment before each test and clean up environment after each test execution. During the lesson, we compared how to do the same things with JUnit 5 and JUnit 4. We learned test annotation and you understood how to create test case. You learned what equivalence test partitioning and how to use this technique. And at the end of the lesson, we learned how to test exceptions in JUnit. Hope this lesson was interesting for you. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students. In this lesson we are going to proceed learning JUnit API. We will learn new annotations that we will use to configure our test suite. I will show you on examples how display name annotation helps us to make our test reports more readable. Also, we'll learn how to use display name generation annotation to help us improve our test report automatically. During the lesson, we'll talk about APIs that will help us to group assertions together. Besides that, you'll learn how to create dependent assertions. There are some cases in real life that in case requirements for test preconditions are not met, there is no sense to verify other things. And we'll learn how to configure this flow. Also, I will show you today powerful mechanism of assumptions and how it works. After that, we'll dive deeper and we'll learn how to create parameterized tests. And at the end of the lesson, I will explain you how we can measure test code coverage and what plugin we'll use for that. Sounds like we have a lot of things to do. Let's start. I really believe that it is better to learn this topic on examples. So let me open Eclipse. This is our test from the previous lesson. In case you missed the previous lesson, please get back and watch it. Meanwhile, we'll keep improving our tests here. Another thing for visibility and for documentation your tests properly, we can use display name annotation. Let me show you this. You can apply this annotation to the class and specify a clear name. Also, we can apply this annotation for each specific test method. You can use any characters and even emoji if you wish. There are also display name generators. You can use generators on the class level. For example, I use generator that substitutes underscores with spaces. As you can see, I use new annotation, display name generation. Inside this annotation, I use inner class of display name generator that is called replace underscores. This auto display name generator can be helpful because on some projects specific way of naming test methods can be used. Namely, sometimes in tests we name methods with underscore to increase visibility. Let me run tests to show you the result. Here you can see that display name of our test class is changed. And inside you can see that display method of first test is different and underscores are removed for the second test. Can you see now that readability is increased in comparison with other methods listed here? Instead of the display name generator, you can use other generators that are available here. Here is a list of other generators that you can use. Hope this is clear. Let's move on. Let's talk about assertions in JUnit. You already saw how we wrote these tests in previous lesson, and you know that we have a lot of assertion methods located in assertions class. All methods are static, and usually we do static import of assertions class. Let's look at assertions that we didn't talk about yet. I put all new examples at the bottom of this file. I will share with you link to the source code after the lesson so you could find these examples and investigate them separately. For example, you can group your assertions. Sometimes that is logical and more visible. I believe you remember our first test when we verified transaction. Here is a similar test, but in the last part, I use assert all method to group my two assertions. This method takes heading that you will see in case one of the assertions will fail, and you pass variable length argument of type executable. Usually, object of this type is described with the help of lambda expression, and you can see that in lambda function I execute my own assertions. In case one of these will be failed, in report you will see that group of assertions with this header is failed. Hope this is clearer with this example. In the next example, I am going to show you how you can write dependent assertions. Everything is easy here. We can use nested assertions. Here is the example. We test the same money transaction. I write assert all and inside I have assert true. This assertion will check that transfer money returned true. That would mean that transaction was successful. And only after that I will check that amount of money is changed for account 1 and account 2. An inner assert all method will be executed only in case first assertion, that is our assert true method, will pass. Does it make sense? Great, let's continue. The next assertion will help us to be sure that time spent on execution of our method doesn't exceed specified by us amount of time. This is needed in case we want to be sure that, for example, some complex method with a lot of logic inside, that it doesn't take more than 1 second to execute. In our particular case, I want to test transfer money method doesn't take more than 1 second to execute. I use assert_timeout method and pass 2 arguments to it. The first argument is a duration object. In a separate lesson we'll learn with you tools for time management in JDK. Right now you can just use duration class. Don't forget to make an import from Java time package. In case you use Eclipse, it will help you with auto-suggestion and will import this class instead of you. You can use static methods, for example of seconds, to get duration in seconds, of millis to get duration in milliseconds, and so on. I used of seconds method, and the second argument, similar to our previous examples. I pass lambda function and execute my method inside it. Test will pass in case this method execution took less than 1 second, and it will fail in case method execution took longer. Talking about timeout tests, it is also worth to mention that assert_timeout method returns result. For example, in this case, assert_timeout will return the result of my transfer money method. That means that I am able to test timeout of method execution and the actual result. I test that transaction was successful in assert_true method. Also, there is another way to check timeout. We can use annotation timeout right above the test method. By default, time unit inside the annotation is seconds. But it is configurable, and you can see in this commented line how you can configure time unit for this annotation. Just use second argument as time unit. Does it make sense? Great! You already learned a lot of tools that will help you in daily activities while writing unit tests. Now, I want to tell you about very interesting tool in JUnit. I'm talking about mechanism of assumptions. Imagine that you wrote a unit test, but you want to vividly specify what is the valid input for this test. In case input to this method was invalid, we skip this test. Don't worry, I will show you an example now and everything will become clear. Imagine that I wrote a test that should be run only on local development environment, and another test that should be run on quality assurance environment. These environments use different configurations. While this is not a good practice, it is very common thing. And you want that one specific test would run only on local computers and another test would be run on QA server. How to do that? We can assume some statement before running test. For example, this test will be executed only on my laptop. I write assume true at the beginning and pass statement that should return true or false. In case true will be returned, JUnit will proceed with the test execution. In case statement will be false, JUnit will just skip this test and will print the string message in a report. I set environment variable on my computer that is called is_Petaha laptop. It has true value. In case I would change this statement a bit, I will get false and this test will be skipped. Let me run now all tests to show you how this look like. And here in test report you can see how much tests were run and the number of skipped tests in parentheses. Let's expand the report and check which test was skipped. And here you can see that test on Petaha workstation is skipped because assumption is failed. So, what is the difference between assertion and assumption? JUnit assert is used to write testing scenarios for our test methods, whereas assume is used to validate favorable conditions for our tests. Here is how you can configure whether tests should be executed or skipped. Now I want to show you another cool feature of JUnit. I am talking about parameterized tests. Imagine that you have one test and you want to run it multiple times with different values. You don't have to write different tests. You can just specify that this test will have different inputs. How to do this? Let me show you. First of all, we have to write parameterized test annotation instead of our regular test annotation. The second thing we have to do is to write value source annotation. In parentheses next to this annotation we can specify arrays of different types, namely booleans, bytes, chars, classes, doubles, floats, ints, longs, shorts, and strings. Even in case you would forget this, just use auto-suggestion tool like I do. You can press Ctrl and space simultaneously to see hints. In my particular example, I need ints. and next to int I specify array of ints in curly braces. The third thing we have to do is to declare a method parameter in our test. This type should be compatible with the one we specified in the value source annotation. I declare a parameter of type int. And now this test will be executed 4 times. Why 4? Because I have 4 inputs. To be specific, in this case test will be executed 4 times, but the 4th attempt will be skipped, because I have assumption here that money amount should be strictly more than 0. Let me run this test and show you JUnit report. And here you may see that our parameterized test was executed 4 times with different arguments. And you also can see that first execution of test with -10 value was skipped because of assumption failed. Is that clear? To parameterize your tests, you can use such annotations as null source, empty source, null and empty source. You can use these annotations with parameterized tests. I believe that all these annotations are self-describing. Null source will just add null value to array of input values. Empty source will pass empty argument for parameters of the following types like string, list, set, map, primitive arrays like int array, char array, etc., object arrays and integer arrays, whatever. Null and empty source is a combination of first 2 annotations. In case you would run this test, you would see that it will be executed 2 times with null and empty string argument. Another cool annotation for test parameterization is a method source annotation. You can mark any static method with this annotation. This is so-called factory method that generates stream of arguments that will be submitted to the parameterized method. Let me show you this on the example. I have parameterized test that is marked with method source annotation and name of the method that should be used to generate test inputs. And here is my static method that is used to generate inputs. It returns stream type, but actually it can return any type that can be converted to a stream. For example, collection, iterator, iterable, in-stream, double stream, and long stream. And when I run test method source, it is executed 3 times because I generated stream with 3 values. Does it make sense? There is also a possibility to specify multiple data inputs by using a CSV source annotation. We use comma-separated values to pass all arguments. It is pretty intuitive if you would look at this example. To be honest, I don't use parameterized test. Why? Do you remember that in previous lesson I explained you what equivalence class is? That is the answer. I don't need parameterized test because I write test for only one value from specific equivalence class. That also works just fine. But you can use parameterized test if you wish. At least you should be aware about this feature. Now, imagine that you found some defect and this test is failing. And taking into account that usually development is performed in teams, this test also failing on other computers. To not block anyone else, you just disable some unit test until it will be fixed. Hope you can easily imagine this case. Now, how to disable test in JUnit? In JUnit 4 we used ignore annotation. In JUnit 5 we use disabled annotation. You can just keep this annotation if you wish, or you can add description why exactly this test is disabled. And when you run all tests, this one just won't be executed. Great! We have one more quick topic to cover. That is test code coverage. What is this? This is a metric, some specific value that shows in percentage how much lines of your code was covered with tests. This is important for us because of a few reasons. We want to be sure that all code that we wrote is covered with tests. In case we have code that is not covered with tests, that means we don't need this code at all. Sometimes we want to provide a matrix for reporting purposes that our job was done with expected quality level, and sometimes you might be asked to keep the percentage of test code coverage on the specific level. How test code coverage works? Test code coverage shows how much lines and blocks were invoked from your test. In other words, specific plugin measure how much lines of code were executed when your test is running. That's why test code coverage not necessarily means that your test really verifies things and logic. You can just invoke some method from your test or simulate any other conditions to execute other parts of if-else statement, And that's it. Such metric as test code coverage will be increased. To help you understand how test code coverage works, let me show you this on example. From the code editor area, mouse right-click, coverage as, JUnit test. In case you don't have such option, make sure that you have Eclemma plugin installed. Eclipse for Java EE developers is distributed with this plugin installed by default. But in case your Eclipse version doesn't have such plugin, you can install it manually. Just click Help, then select Eclipse Marketplace. After Eclipse Marketplace is loaded, use search bar to find Eclemma. Eclemma is a plugin that can calculate test code coverage inside Eclipse. It is shown that it is already installed for me. I click Cancel. And now I want to execute my test and check test code coverage. After test is executed, I can find test code coverage report. It says that this test covers only such specific part of all lines in my project. Let me expand folders from this report. You can sort all items here by coverage rate. As you can see, my unit test covered on 100% my money transaction service and account class. That is awesome. You can open each specific class now to see lines in green that are covered with your test. Let me open money transaction service. And you can see that all lines and blocks are covered with test. How to reset this? Just find this cross sign in coverage report to reset all reports and color selection in your source code. What other statuses could be? You'll find your lines in red in case they were not covered by your test. And you will find yellow lines in case not all branches of execution are covered with test. To demo you these cases, I created separate class. It is called test code coverage demo, and it is placed in JUnit folder. It is really simple class created only for the sake of the example. The method takes string argument. It has if-else block. First if statement contains expression that includes OR operator. Let me show you the test now. I have one single test. I invoke test code coverage method and pass null value there. Now let me check test code coverage and run my test. When tests are executed, let me open the source code of our class. You can see that if statement is yellow. Why? Because not all branches of execution are covered with tests. We have two possible options here. In case my string argument is null, I will print this text to console. And the second branch of execution is in case the string argument is not null, but it is empty string object. So that means I have to write one more test where string argument won't be null. Here is red line in else block. That is because it is not covered with test. So you can see that my unit is covered with test on 62.5%. But notice, I even didn't test anything. There is no assertion at all in my unit test, but I already increased test code coverage metric. That is the trick that you should know about test code coverage calculation, to never use it. We learned a lot today. Let's recap what we have learned today. Today we learned new annotations. You also learned how to group assertions and how to build dependency between assertions. On real examples you saw how to create unit tests that can be failed because of timeout. We learned how to use assumptions in JUnit. I explained you different ways to parameterize your test methods to repeat tests with different inputs. And at the end of the lesson, we learned how to check test code coverage. Hope you enjoyed the lesson. Thanks a lot for your attention. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello team, in this lesson we keep learning JUnit API and advanced features. We'll start our lesson from learning what test suite is and how to create our own test suite. After that I will explain you what tagging is and how to tag your tests. During the lesson I will show you a lot of examples that will help you to understand this topic better. You will learn how to configure order of test execution. Besides that, I am going to show you a really cool feature. It is conditional test execution. You are going to learn how to set specific conditions, to enable or disable your test programmatically. Also, I will explain you how to create repeated tests that will be executed specified number of times. I will explain you how temporary directory extension works and why we might need it. I believe you already know how to use JUnit assertions, but today I will also show you how to use Humcrest library to increase readability of your tests. And at the end of the lesson, we are going to review the most common and typical mistakes. Hopefully, reviewing mistakes will help you to not repeat those. I believe that the best way to learn this topic is to learn API with examples. So let me open Eclipse. Imagine the case that you wrote specific suite of unit tests that are related to specific feature. For example, all unit tests are related to registration feature. And while working on this feature, you don't want to run all possible unit tests. You want to run only those unit tests that are related to registration feature. There are so-called test suites to help you to run group of tests with one click. Let me show you how to create test suite. The first thing you have to do is to use specific runner class. What is a runner? This is a class that is responsible for running unit tests. There is a default JUnit runner when we don't specify any specific runner class. In this particular case, we have to specify another runner class that is called JUnit platform. This class will check all configurations related with running group of tests, our test suites. The next thing we have to do is to add one of annotations that will help us to run group of tests. It could be select packages annotation. From its name, I believe that is clear what we have to pass to this annotation. Here I specify a package with unit tests that I want to run. Be careful, this annotation by default runs only tests that are either begin with test or ended up with test or tests. That's why in case you have some custom name for JUnit class, it will be not included into test suite. A little bit later I will show you how to add any specific class by name. You can specify multiple packages if you wish. Just pass array of strings to the annotation. From the syntax standpoint, just wrap your strings in curly braces like I did here. By default, this annotation tells to run tests in this package and all of its subpackages. But what if I don't want to run all tests and I want to exclude tests from specific package? For example, I can specify here that I want to run all tests that exist in my project, excluding tests from JUnit package. To do this, I have to use exclude packages annotation. In case you want to include specific package, you can use include packages annotation. Hope that these annotations are self-describing and you can understand these easily. Also, during the development of unit tests, you can mark specific tests with tags. A little bit later in this lesson I will show you how to do this. But imagine that there are some specifics in environment configurations of each server, and special set of tests should be run on development environment, and special set of tests should be executed on production environment. While these cases are relatively rare, it is still good to know that such level of configuration exists in JUnit. In case you want to run a specific class, you can use select classes annotation and pass class to it. Similar to previous example, we can pass array of classes in case we want to execute multiple classes in scope of this test suite. It looks like that's it regarding creation of test suites. Let's move on and see what else do we have. You already saw how to include tests that are tagged with a specific tag. Let's learn now how we can tag our tests. We can use tag annotation with classes and methods. There are specific rules for tag names, but all of them are pretty intuitive. And in case you don't use any extraordinary name that is started with ampersand or exclamation point, then you are good. The next thing that I want to discuss with you today is a testing order. By default, testing order is undetermined. And that is fine. I believe you remember first principles, and namely isolated principle. Each test should be isolated from each other. That's why it is not a big deal for us what the order of test execution is. But JUnit provides us with opportunity to specify order of test execution. In my opinion, this is extremely rare cases when you have to use this feature, but still, you have to know about it. To specify order of tests, we have to do few things. First thing we have to do is to add test method order annotation to the class and specify order implementation that we want to use. There are different implementations that are available for us. They are display name, to sort execution by display name, method name, to sort test execution by test method names, order annotation, to sort by order specified in annotation, random, orders test method pseudo-randomly and supports configuration of a custom seed. In my opinion, using order annotation is very convenient, so let me show you how it works. I specify order annotation class in my test method order annotation. After this, the only thing that I have to do is to add order annotation to each test method and specify numeric order of each. So the test with order 1 will be executed first. Test with order 2 will be executed next, and so on. That is how simply we can configure order of execution for our tests. But remember, usually unit tests should not rely on the test order execution. The next thing I wanted to discuss with you is a conditional test execution. JUnit allows us to disable or enable tests based on the specific conditions. We are going to learn annotations that will help us to configure specific conditions. Basically, we can group all these annotations in the following groups: operating system conditions, Java runtime environment conditions, system property conditions, environment variable conditions, custom conditions. Let's review all examples one by one. Operating system conditions allows you to enable or disable tests based on the operating system of environment where code is executed. Here you can see examples with enabling tests on the operating system, on array of operating systems, and similar example with disabling tests based on operating system. Pay attention that there are predefined constants for major operating systems in OS class. I will share the link to the source code of this test so that you could check all import statements that I did to use these classes and annotations. But just in case, Eclipse auto-suggestion tool should help you with this. The next group of conditions will help you to enable or disable specific unit tests based on the particular version of GRE. There are specific annotations for enabling tests for the specific GRE, enabling tests for the arrays of GRE versions, enable for GRE range, enabling for range by specifying either just minimum or just maximum GRE version. You can do the similar things for disabling tests, and here you can find examples. Hope this is clear. Now let me show you annotations that will help you make conditions based on the system properties. You can use enabled or disabled if system property annotations to check if specific properties are equal to the value we pass here. The value supplied via matches attribute will be interpreted as a regular expression. Actually, there is nothing more to add here. Also, we can enable or disable tests based on the environment variables. Here you can see examples of these two annotations. Similar to previous example, value in matches attribute will be treated as a regular expression. And the most interesting in my opinion, it is a custom condition. Let me explain you how it works. We can use either enable if or disable if annotations and pass to it name of the method that we are going to use to define the condition. The method should return either true or false, and based on this, test will be either enabled or disabled. This option gives you a lot of flexibility in definition of your own condition. Does it make sense? Now you know all possible ways how to configure conditions to enable or disable your tests. Let's move on to the next topic. JUnit allows us to create repeated tests that will be repeated specified number of times. To create such test, just use repeated test annotation and specify number of times to repeat it. Inside the annotation, besides the number, we also can specify the name of the test. While defining name, we can use placeholders to display current repetition and total repetitions. That's it. This annotation is useful when you want to make sure that even after multiple execution, test returns the same result. The next example I want to show you is about temporary directory. In JUnit 4 there was so-called temporary folder rule that helped us to perform operations with file only in scope of our unit test. In JUnit 5 we have similar feature but implemented in more intuitive way. Imagine that your application stores some data to your file system. Imagine that you want to store e-receipt of all purchases in your online store, and you want to test the content of this file. Instead of finding the workarounds how to create files first and after all tests passed, remove these files, and also be bothered about other questions like how to separate test and non-test files and so on, to avoid answering these questions, there is a temporary folder extension. Let me show you how you can use it. Basically, in any test method, we can pass such argument as pass with annotation temp dir. After that, inside the test, we can resolve the pass and do with this pass everything we need. For example, in this particular case, I wrote some text to a file and after that verified that text in file is the same as I expect. After test execution, this file will be removed. So, there is no impact on your local file system. That's how easily you can use temporary directory extension. Is it clear? Awesome! Also, today we are going to cover one more important topic. I believe you already noticed that a lot of things in our tests and JUnit library is developed for the one main thing: increase readability of our tests. I mean all these annotations like display name, extra long method names, naming methods with underscore and lots more. And there is also a popular library that Java developers use often. It is called Hamcrest. Even if you won't use it on daily basis, you should be at least aware about it because it is very popular. So in short, Hamcrest is a library that allows us to achieve high readability of our code by using custom assertion methods and matchers. As we learn examples, you will understand what I am talking about. And to start working with Hamcrest, the first thing we have to do is to add Hamcrest library to our class path. How to do that? I already showed you in previous lesson how to add external jars to our project, but in this lesson we will do everything from the beginning. So the first question, where to get Hamcrest library? In the internet. There are really a lot of open repositories. One of the biggest repository is Maven repository. We can type our Google search like this: Hamcrest Maven repo. Now let's open the first link from the list. These are all libraries from Hamcrest, but today we need only one: Hamcrest all. Here it is, right on the top. The library contains all modules that are needed to work efficiently with Hamcrest. On this page we can choose version of our Hamcrest library. I select the latest one. On this page we can find instructions how to set up dependency on this library in projects with automated build tools. But we have simple Java project. Don't worry, we'll learn automated build tools later, but not in this lesson. Right now we need to find how to download archive with Hamcrest classes. And here I can download jar file of Hamcrest library. Download file and get back to Eclipse. Here in Eclipse we have to add jar to a class path. Mouse right click on our project, build path, configure build path. Here make sure you are navigated to libraries tab. Press on class path. Now click on add external jars. And here you can find Hamcrest library that we have just downloaded. I already have this library added to my class path, so I will just close this window. When you added Hamcrest library to a class path, we can proceed with our examples. Especially for this lesson, I created separate file with Hamcrest examples. I will leave link to the source code attached to the lesson. Let's write our first test with Hamcrest. We have simple test here. Imagine we have two strings. No matter how we received them. In this example, I wanna put all your focus on the syntax of Hamcrest. Instead of regular assertions that you're already used to in JUnit 5, we use special method from matcher assert class that is called assert_z. This is overloaded method and one version of it takes string as the first argument. This string is used as an error message to be displayed in case test was failed. Personally, I more often use another version of this method that takes actual value as a first argument and matcher as a second argument. Hamcrest matcher is a special type that can help you to identify the match according to the requirements of the test. Usually we use static methods that can return matcher object. In this particular case, I used =to method from matcher's class. This static method returns matcher that will help us to check equality with the first argument. And I believe you can notice that we received stylized sentence that is easy to read and to understand. Let's look at another example. Imagine that you have list with values and during the test you modified the state of the list. Just imagine that. And in assertion part of your test, we have to verify that list contains one of the expected values. Here is the line written with hamcrest. Assert that list has item any of equal to A, equal to B, equal to C. Do you like it? It is almost like a complete sentence, and you can see that you can use matchers as an input argument to another matcher. And right below we can see the same assertion but written with JUnit. Tell me, what do you think? What is more readable in your opinion? Some of my students tell me that they still prefer JUnit assertions over hamcrest, and that is completely fine. It is only matter of coding style and nothing more. I just want you to know about this library since it is popular. Essentially, that's it. So the only thing that would be different from test to test is the matcher that you will choose to perform the validation. There are different group of matchers. I gathered all of them on one slide. Let me show it to you. There are such groups of matchers: core, logical, object, beans, collections, number, text. And on this slide you can find description for each of these matcher. I believe that by name of each matcher you can understand what does it do. That's why I believe there is no need to go over each of these. In case that after reading of description for each matcher you still have questions, do not hesitate to ask these questions in Q&A section. And the last but not the least thing for today, I would love to review with you typical mistakes that usually junior developers do based on my experience. The first typical mistake is testing of Java API. This mistake can have multiple and various forms, but the idea that stands behind this example is simple. You don't have to test how Java works. The second common mistake is to write tests that will never fail. On this slide, you can see very simple example to get the point. In real life, the source code can be a bit more complicated, but at the end of the day, specific scenario will always return true. If you remember, in previous lesson, I gave you one advice. Spend 2 more seconds to make sure that you, at least once in your life, saw each specific test in red status. That would help you to avoid this mistake. Huge test. That is our next mistake. Don't try to test everything in one test. Remember, one assert per test or single concept for a test. And also remember, do not hardcode any values in code and avoid of using magic numbers. We kind of discussed this topic and this advice already, but I wanna make sure that you remember this. It is better to use constants that are defined in your test class and that have clear name, rather than guessing what does this value mean. That was all main mistakes that I wanted to put your attention to. Now let's recap what we have learned today. We started our lesson with learning what test suite is and how to define custom test suite. After that, we learned a little bit more about tagging. In this lesson, I explained you how to configure order of test execution to make sure that tests are running in predefined sequence. You saw in examples how to create different kinds of conditional statements that will allow you to enable or disable tests upon specific condition. Besides that, I also showed you a small example that explains how to create repeated tests. Now you know how to use temporary folder extension while testing input and output streams. Also, I showed you how to use hamcrest in your unit tests. And at the end of the lesson, we learned typical and most common mistakes. That's it for today. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello team! Today we start important section in this course. We start learning how to perform integration testing of our app. We'll start from understanding what integration testing is. To help you understand it better, we'll compare integration and unit testing. I will explain what test doubles are and how they help us in testing. We'll understand advantages of using test doubles in testing process. After that, I will share with you information about different types of integration testing. And at the end of the lesson, we will learn what frameworks are used for integration testing in Java. Let's start. At the beginning, we have to understand what is integration tests. In simple words, integration testing is a process where individual units are tested together to check whether all the units interact with each other as expected. So, in case of unit testing, we test only one specific unit in isolation. In integration testing, we want to make sure that different units work together as expected. For example, you want to be sure that when you use mail server to send an email, then methods of template engine that prepares content of our email are invoked. Or, for example, we want to be sure that in case there was an error in template engine, we didn't invoke send method of our mail server to send invalid message, and so on. Does it make sense? During integration testing, all our focus is put into verification of behavior that is happening not inside the one single object, but between different objects. The focus of the integration testing level is to expose defects at the time of interaction between integrated components or units. To make sure that we are all here on the same page and that we clearly understand the difference between unit testing and integration testing, let's look at the next table. Here you can see the table where we separated attributes of unit and integration testing. Let's go over each row one by one, and I will give my comments as we go. In unit testing, test verifies only implementation of the code of one single unit, whereas in integration testing, test puts main attention on their interconnection behavior when they are used together. The next thing we have to know is that a unit test uses only unit test frameworks like JUnit or TestNG and a mocking framework. Today we will talk about what mock and mocking framework is. In short, during the unit testing, sometimes you need to use test doubles to replace real collaborations of your unit with other units, or even simply to satisfy requirements of compiler. Don't worry, we will also talk about test doubles a little bit later today. But when we talk about integration tests, we still can use mocking frameworks and test doubles for the waste areas of the system. For example, as I already mentioned, we need to test interaction and behavior between elements, like an example when mail server invokes methods of template engine. Also, in integration testing, we can use real containers and real databases and use real components for integration testing. For example, on one My project, we had separate environment where automated acceptance testing was executed. We had suite of integration tests that test our API but still used mocked fake components. After running tests on AAT environment, we executed our tests on so-called SID environment, system integration testing. Tests on that environment used real components like real database, real payment services, but just with the test data. So, as you can see, level of using fake objects and test doubles during the integration testing can be different and will depend on your application and level of complexity of your system in general. The next thing that is different in unit testing and integration testing is that failure in unit test is always issue with the source code, but failure in integration testing, besides the issue with the source code, also can mean changes in the environment and in other components. Unit testing is the first layer of tests in our testing pyramid. If you don't miss any lessons before, I believe you remember what testing pyramid is. And this is important to understand that before starting implementation of integration tests, we have to be sure that all units work properly in isolation. And once all the components or modules are working independently, then we need to check the data flow between the dependent modules. That is known as integration testing. So, I believe that it's clear that integration testing is the second level of the software testing process that comes after unit testing. Now, I'd like to talk about test doubles. During the unit testing and integration testing, sometimes we depend on the parts of our system that we either don't need at the moment, or they are not ready to be tested now, or it is impossible to reproduce the state of some part of the system on this particular environment. And to write tests, we have to use counterparts of those elements that would behave like release-ready elements. For example, you don't have available third-party API that performs fraud verification of your user during the purchase. But you have official documentation and you know how to imitate this API. And now you can build something what behaves like real API, but actually this isn't an actual API. Such kind of units are called test doubles. Besides that, test doubles simplify testing process and provide us with possibility to reduce the complexity and facilitate testing. Test double is a generic term that is used to describe objects or procedures that will help us during the testing with the case I described. Test double has to implement the same interface as real-life object and meets the same requirements. There are different types of test doubles. Let's look at them. The first in our list is a dummy object. What is a dummy object? This is fake argument that is not really used and has no effect on the test. Imagine that you have multiple parameters in the method and you just need to pass at least something as an argument to execute this method, even in case you don't care about this argument at all. The next type of test double is a test stub. Stub is an object with hard-coded values to be returned. It has no logic inside and it is state-oriented. Stubs are used to provide our test with input to imitate different live cases. A fake object has implementation with shortcuts, so it is just a simplified version of the production code. It is usually used in integration testing, for example, to access an in-memory version of the production database. Mock. A mock test double is a behavior-oriented object used to assert interactions. It allows to use methods to verify interactions. For example, I can test that some specific method was invoked with a specific list of parameters. Also, I can calculate number of times method was invoked. We can also set expectations about mock behavior before test code is executed. And finally, spy. A spy is similar to a mock. It is also a behavior-oriented object used to assert interactions, but it is different from the mock as it delegates and monitors calls to real objects. So, you use real object with real methods, and all interactions with spy are substituted with calls to real object unless some method was stopped. So, I want you to understand that mocks are something totally different. Until now, all our tests made assertions on a state. Mocks are test doubles that make assertions on behavior. To understand the analogy, imagine that mocks say something like this. I expect that method 1 will be invoked with this string argument, and if it is not there, I will throw an error. So mock verifies behavior. That's the main goal of creating this kind of test double. Let's now sum it up to understand why we have to use test doubles during the testing and what advantages we get from using them. With the help of test doubles, we isolate code that is under test. We can be sure that we control all integrations and isolate specific parts of our system from each other. Substituting real integrations with test doubles, we can speed up test execution. Because integration tests that uses real components for all kinds of integrations can take hours to complete. That's why very often a lot of parts in our integration test is substituted with test doubles. Using test doubles, we can stop specific behavior of our components and make execution of our test deterministic. At the end of the day, we want to have control over execution of our test from the start to the end. Test doubles helps us to reproduce special conditions and reproduce different states of our system to test different use cases. Does it make sense? Before we move further, I want to explain you different types of integration testing. Integration testing may be classified into two major groups. They are incremental integration testing and non-incremental integration testing. In the incremental approach, modules are added in the ascending order one by one or according to need. The selected modules must be logically related. Generally, 2 or more than 2 modules are added and tested to determine the correctness of functions. The process continues until the successful testing of all the modules. There are top-down and bottom-up approaches. The top-down testing strategy deals with the process in which high-level modules are tested with low-level modules until the successful completion of testing of all the modules. Major design flaws can be detected and fixed early because critical modules tested first. In this type of testing, we'll add the modules incrementally or one by one and check the data flow in the same order. The bottom-up testing strategy deals with the processes in which lower-level modules are tested with higher-level modules until the successful completion of testing of all the modules. Top-level critical modules are tested at last, so it may cause a defect. Or we can say that we will be adding the modules from bottom to the top and check the data flow in the same order. Let me explain you more about non-incremental integration testing. We will go for this method when the data flow is very complex and when it is difficult to find who is a parent and who is a child. And in such case, we'll create the data in any module and we will test interactions with different modules without any specific logic. That's why this method is also known as Big Bang method. Now, when you know the theory of integration testing, let's learn what frameworks are used for integration testing. Probably the first framework that is used for integration testing is a JUnit. Even despite developers use JUnit primarily for unit testing, we still can use this library for integration testing. Also, probably one of the most popular libraries that we use during integration testing is Makita and EasyMock. These libraries help us to create mock and spy objects. DBUnit, library that helps us to create tests for integration with database. Mock FTP server library provides us with different FTP implementations, fake and stub. It is just a few libraries. In fact, there are much more of them that will be used for different specific cases. But the principle of working with these libraries are the same. That means in case you would learn at least few libraries for integration testing, it will be like piece of cake to learn other libraries by just reading documentation. In this course we are going to learn the most popular libraries for integration testing that you will use most often. Especially for all my students, I prepared examples for each topic and I walk you through all examples as we go. I believe that we learned a lot for today and you already can understand and imagine what integration testing is. The only thing that we still need to do is to learn how to use frameworks that I listed in the lesson. But we will do this in the next lessons. Right now, let's recap what we have learned today. In this lesson we learned what integration testing is. We made a comparison of unit and integration testing to understand the difference better. After that, we learned the concept of test doubles and what types of test doubles exist. We also learned why and when we need to use test doubles and we learned advantages of working with them. I explained you different types of integration testing and we discussed different approaches during integration testing. And at the end of the lesson, we reviewed frameworks for Java that will help us to write integration tests. That's it! Hope you liked the lesson. Thanks a lot for your attention and see you in the next lesson. Hello team, glad to see you on this lesson, and today we are going to dive deeper into the details and learn framework for integration testing. Today we will learn Makita. We'll start from understanding what Makita library is. After that, we are going to have a lot of real-life examples that will help you to understand how to work with Makita API. But to make sure that you can write and run Makita tests, we'll set up your environment first, and we'll add Java libraries to a class path of your project. I will show you how to use Makita extension for JUnit to be able to work with Makita in your JUnit tests. We'll create mocks and on real-life examples we'll verify behavior on our mocks. You will learn how mock injection works. In this lesson I will show you how you can use argument matchers and what are specifics of using them in Makita tests. For specific cases, I will show you how to stop exception when it will be needed. And at the end of the lesson we will learn how to work with argument capture. Let's start. Makita is a library that is used during unit and integration testing in Java applications. Makita is used to create mocks based on the interfaces. With the help of this library we can stop some methods, create spies, and test behavior during integration of different components. Makita has really nice API that helps us to write nice and readable tests. And today on real examples I am going to show you how to work with Makita. Let's jump to Eclipse and learn Makita on examples. I prepared real-life example to help you understand the API. Before learning Makita API, I will give you a context of our classes that we are going to test. Imagine that we have Messenger class. This class aggregates template engine and mail server. Template engine is a type that can prepare content for your email message based on the template and the client. We will take information from client object and paste it in the template and return ready to send message. You know this kind of emails that contains personalized information, like your first and last name, for example. I didn't implement all logic here because for the sake of our Makita examples that wouldn't mean a lot. So I want you to understand at least high-level logic. Client is a regular object that can be created only with the email and can return its email when needed. The next field in messenger type is a mail server. Object of this type has only one goal: be able to send the message from specific person to the specific addressee with a personalized message content. Send method takes object of type email to send a message. Email object in our particular case has a message content and addressee. We have getters and setters here for mail server and template engine. And here is our key method in messenger server that is called sendMessage. This method takes client object and template object. At the beginning we create message content. After that we create email object and set content and addressee to email. And after that we call send method with email object. Hope you understand the context. And now let me ask you a few questions. How would you test that when you call sendMessage method on Messenger, then send method of mail server is invoked, to be sure that integration between Messenger and mail server works? How would you test that mail server is invoked with the email object that contains email that we get from the client object, and to be sure that this is not just a random email object? Would you like to check when you call sendMessage, then prepare message of template engine object is invoked? Can you take a minute and think of different cases that you would like to test? We have to test interconnection behavior and how components behave in different cases based on different output of connected objects. Now, when we have the context about our system, let's write tests with the help of Makita library. And the first thing we have to do is to add external library to our project. If you saw lesson about Humcrest, I already showed how to download library from Maven repository and add it as external library to the project. Now you have to do the same, but just download other libraries. Find Makita core and download library. You can download from Maven repository. I will leave link to this library in the lesson attachment, so don't worry. You just have to download jar of the latest version and add it as external library to our project. Pay attention that this library has dependencies. Click on the compatible version and make sure you downloaded also these libraries and added them to a class path. In this particular lesson, we are not using built-in tools that would significantly help us with managing dependencies, but we'll learn these build tools a little bit later in our course. Also, besides these libraries, please download Makita JUnit Jupyter library. All links you will find in lesson attachments, so don't worry about that. I have added all these jars to the class path of my project, and now we can proceed with the examples. Here is our test. You already can see a lot of different annotations, but don't worry, we will learn all of them gradually as we go. Let's create our first test. We want to test that mail server will actually send email when I will call sendMessage method on my messenger object. Let's write this test. For the first test, I have to create constants for some text message and some random email. In my preconditioned part of the test, I create client object with the random email. Also, I create some template object to use it during the testing. After that, I want to create a stub. For this specific test, I want to imitate the next scenario. When prepare message will be called on template engine object with a specific template and with my client, then I will return some random message. Important thing here is to understand that after this line, no matter how much times I will call prepare message with these objects, I will get this random message. For all other arguments, template engine will return null, or in other words, default value for type that is returned from this method. For all reference types, this value is null. Here I left a commented line. When you will get the source code, you can uncomment this line to make sure what is returned after this method invocation with new parameters. But let's stop on this line before moving further. Let me explain you what is happening here. When is a static method from Makita class to stub methods on a mock. Pay attention that on the top of my file I did a static import of everything what is inside Makita class. That's why I can call when method without specifying Makita class name. The next thing I have here is a method invocation on a mock object. Based on this, we need to have a mock. From the previous lesson you already know that mock allows us to test behavior during the interaction with other components, for example. We will do this in the next slides, but at this very moment we need to stop specific behavior. Why I need to stop behavior and why I just can't use real object? Well, there are different reasons why we might wanna do like this. The first reason is the simplest one. By the moment you write this test, you don't have any implementation of template engine at all. The only thing what you have is interface of type template engine. And implementation of this interface is in progress by other developer from your team, for example. The second reason to stop method on the mock is that you are going to perform a lot of different tests and you want to reproduce different cases to understand how program behaves based on the different state of other components that it interacting with. It is a good way to test edge values and all classes of equivalent. Probably you have the one question in your head. How to create mock? There are different ways to create mock in JUnit 4 and JUnit 5. I wrote and commented all possible ways to create mock so you can use this file as a cheat sheet in the future. The first way to create mock is to call mock method from Makita class and pass there either interface or a specific class, just like this. The second option is to use mock annotation above the field that you wanna mock. In this particular case, I have to put mock annotation right above my field. And now I have to call initMocks method from Makita annotations class and pass the reference to object of this test class. If you would use this method, you would find that it works just perfect, but developers of Makita library consider this method as deprecated. I will not dive into the details why exactly they marked it as deprecated, because probably it wouldn't mean a lot for us right now. What they recommend to use instead? It is recommended to use openMocks method. It returns autoclosable. I store this reference in a variable and after each method I close it. You can use this option if you wish. And last but most convenient option in my opinion is to use Makita extension for JUnit 5. We have to place extend with annotation above our class and pass the class of Makita extension. Make sure that you imported all libraries to your class path properly with all necessary dependencies. In case you use this extension, you shouldn't use any static methods that I've just shared with you. This is pretty convenient in my opinion. In JUnit 4, you would use special runner that is called Makita JUnit runner, or you would use Makita rule. All the options works fine. It is only a matter of your coding style and specifics of your test, how exactly you would like to initialize mocks. But now you know all possible ways to create mocks, that is for sure. Also, one more thing, it is a rule of thumb to specify that some specific object is a mock by adding mock suffix to a variable name like this. So now, when you know how to create mocks in test with the help of Makita, let's get back to the place where we stopped. Here, in when method, I call prepare message on my mock and pass specific client and specific template. And after that, I call then return method and I pass the value that has compatible type with returned value of prepare message method. This is the value that I expect to be returned by my mock when I will call prepare message with this client and this template. Let's perform some action. We call sendMessage method on our messenger object. I pass the same client and template that I used during stubbing. Now it is time to perform verifications. The first thing that I wanted to test is that after I call sendMessage, then prepare message method of template engine is called with exactly same client and template that I used during send message invocation. How to do that? I call static method verify from Makita class and I pass mock of template engine there. You already saw how I initialized mock of template engine. The most interesting part is how to test integration between messenger and template engine. It sounds like a good idea to inject template engine into the messenger object to make sure that it uses exactly this mock. This will help me to come up with right conclusion about integration between these two modules. How to do that with Makita? We declare a field of type messenger. That would be our test instance, and I put inject mock annotation right above this field. What does it mean? First of all, object of this type will be created and all mocks that are declared in this test class and that are at the same time compatible with the fields declared in messenger type will be injected there. Let me show you. My messenger class has two fields. One field is of type template engine and the second field is of type mail server. Okay, let's get back to our test class. In our test class, I have mocks of template engine and mail server. This means that these two mocks will be injected in this object. Makita is smart enough to understand this. And it takes care about this. Makita tries to perform injection with the help of the setters. But even in case there are no setters, Makita will try to inject it with a constructor. And even there are no constructor with all necessary fields, Makita will use mechanism of reflection and inject these mocks. A bit later in this course we'll learn reflection mechanism so that you would also be able to create your own Makita. I believe you understand that these two mocks will be injected in our test instance, and I wanna verify that prepare method was invoked on template engine object. Mocks allow me to verify the behavior, so in my test, after passing mock to verify method, I invoke prepare method with the specific arguments that I expect to be there. For example, in case I would pass here new object of client, not the one I used during the send message invocation, the test will fail. And this is super cool. Can you see how I test interconnection between two classes? I check that after passing arguments to one class, then method of another class with exactly same arguments is invoked. What I can also test here, I can test that send method was invoked on my mail server mock. The same syntax. The only difference here is that I don't know what email object will be here because email object is created inside the method. For the sake of this particular test, I don't care what email object is sent there. What I am interested in is to verify that method send was invoked with actually any email. The new thing that you can see here is that I called any method. What is it? This is so-called argument matcher. This is static method that returns Makita argument matcher. Let me explain you how this works. There may be cases when in our test we have to respond to a wider range of values or beforehand unknown values. Let's review the same test method but with argument matchers. The first thing you can see that I use any method with other classes. I can do this with any references types when I don't care about actual value that is passed to the method. There are also different matchers that you can use, some of them. Any string, any int, any double, any char, any boolean, any list, any set, any map, and so on. You can just start typing any and look at the auto-suggestion. The important thing you have to remember here is that it is impossible to use argument matchers for only few arguments. If you use argument matcher for one argument, then you have to use it for all arguments. For example, in case you want to stop method invocation with specifying real client object and argument matcher for template, Makita will throw an exception. You can check. But what to do in case you want to use specific first argument and any argument of compatible type for the second argument? In this case, you have to use equal argument matcher. In case you will execute this statement, it will work as expected. Just pass object that you want to use for equality verification. And that's it. That was easy. Agree? Also, Makita provides other matchers like isA that takes some class as an argument, isNull, isNotNull, matches that takes regular expression as an argument. Is that clear? A lot of matches are self-describing. Makita developers did a great job by providing us with library that can help us to create readable tests. Other important things to remember is that you can't use argument matchers as a return values. An exact value is required here. And also, you can't use argument matchers outside of verification or stubbing. That is the rule. Do we have to use argument matchers very often? It depends. My personal opinion is that in case you use argument matcher in your test, that means you don't care about arguments for this specific test case. My personal opinion again, this is ridiculous. In case you don't care about arguments in your test case, then why you should care about this test at all? Just remove it, it doesn't matter. While using matchers is so popular across developers, I can't hide my misunderstanding of using them. Because in the test, I want to make sure that I control my test flow from the beginning to the end, including all arguments that might impact on behavior of my unit or on interaction between my units. So it is up to you whether to use argument matchers in Makita tests and how often to use them, but you know my opinion. Okay, probably this is time to move to our next test. Now I want to test that in case for some reason template engine will throw illegal argument exception, sendMessage method won't be executed till the end. How to verify this? I already have template engine mock injected into my messenger object. So the only thing I have to do now is to stop prepare message and make sure that it will throw an illegal argument exception when I invoke prepare message. My assertion will test that illegal argument exception is thrown when I call prepare message. This test shows us that in case error happens in template engine, then messenger wouldn't work too, and we can successfully verify this interaction. Now, one of the most interesting tests. Let's now test an email that was created in sendMessage method. I want to be sure that client's email address is set to email object and addressees is correct, but not just a random one. But how I would test this if email object is created inside the send message? How to get access to it? Makita provides us with an amazing tool that is called argument capturing. This tool allows us to capture argument that was passed during the method invocation and after that be able to verify its state. Let me show you how to do this. The first thing we have to do is to declare a field of special type in our test. This type is called argument capture. It is parameterized by the type that we want to capture in the argument. Another important thing here is to use special annotation to tell Makita that this is object that will capture arguments. And you can see I have capture annotation here. Now we are good to proceed. The first part of this test we have already discussed. Let's focus on the assertion part. I also verified that prepare message was invoked, and after that I verified that send method of mail server object was called, and instead of passing argument matches there, I pass object of my capture and call capture method so that it could capture argument that was passed to this method during the runtime. After I captured argument, I can extract the value from my capture by calling getValue method, and that's it. Now I have reference to a mail object that was created inside the method, and I can get addressee from this object and compare it with expected value. An expected value would be client's email. How do you feel? Do you like Makita? I'm glad that we started this topic with you. We still have a lot of things to learn, including advanced Makita features, but I suggest to call it a day and proceed in the next lesson. Right now, let's recap what we have learned today. In this lesson we learned what Makita library is and why we need it and in which cases. We configured our development environment to be able to use Makita. You learned all necessary libraries you have to add to your project to use Makita features. Now you know how to use Makita extension for JUnit. I showed you how to create mocks in your test and verify their behavior with the help of Makita. On real-life examples, you saw how to inject mocks to our test instance. Also, you learned how to use different argument matchers. And at the end of the lesson, you saw how to use argument capture to capture arguments that are passed to our mocks during the runtime. That's it for today. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students. Today we proceed learning Makita library. I am going to show you advanced features of Makita in this lesson. We'll learn how to verify method invocation order. Also, I will show you how you can check number of method invocations on a mock. During the lesson, you will see how you can verify that there were no any unverified interactions with your mock and make this part of your verification logic. On real examples, I will show you how you can call a real method on mock object. We'll review different policies on mock answers. Taking into account that in previous lesson we already learned Makita matchers, I will show you additional matchers that you can use in your tests. Important thing that we are going to learn today is how to verify void methods and methods that don't have any returned value. How we can set behavior for these methods. we'll talk about Makita limitations and what Makita can't do. And at the end of the lesson I will show you how to work with Spy objects in Makita. And to learn new things, let's get back to Eclipse to our test. Here is the same test that we used in the part number 1. I will add additional verifications here to show you additional features of Makita. Imagine that you want to verify that after I call send message, then prepare message and send method will be invoked only once. Just to double check that I will not send email twice. How to test this? Inside the verify method we can pass second argument. The second argument will describe number of invocations that you expect to have on this mock. You can see example here. Just write times method. Inside times method specify how much times you expect this method to be invoked. Also, you have other methods to specify expected number of method invocations. You can use method at least once. Actually, this method is more for visibility purposes, because in case you would not use this method, your verification would pass only in case method was invoked at least once. So, it is up to you whether you want to use this method for increasing visibility. Also, you have method at least to specify minimum number of times the method was invoked. Also, you have method at most to specify maximum number of times method was invoked. There might be cases when in the test scenario you would like to verify that method wasn't invoked. To verify this, you can call never method. And this verification will pass only in case this method wasn't invoked during the test execution. That is not the case that we have here. That's why in this particular case, this verification will fail. But hope you got the point. Is it clear? Let's move on. Now, I'd like to show you how you can test that methods were invoked in exactly the sequence they should be invoked. Makita provides us with a specific object that can verify method invocation in the specific order. Using inOrder method, I can pass mocks that I want to verify. I can pass either one or multiple mocks. Now, when I told Makita to track these mocks, I can call verify method on this object. Here you can see an example. I write inOrder and after that call verify method. In case we would call verify method first on mail server mock, our test will fail, because the sequence of expected execution is not the sequence of actual test execution. To be honest, I really like this feature. Why? Because this test can be turned in red much easier. Why this is good? Because the goal of our tests is to be sure that code that is written exactly in this way produce exactly this result. In case if I send message first and after that prepare an email, the logic is not correct, and that is not what I expect my code doing. That's why I believe that order of invocation of my methods is part of the application logic. I think it is not enough just to verify that prepare message was invoked and after that email was sent. In my opinion, it is also useful to verify the sequence of methods invocation. While this example with preparing email template and sending email is clear and obvious, that would be not always the case. Okay, let's continue. Imagine that your mock invoked different methods, but for some reasons you missed that and you didn't verify all method invocations. For example, imagine that you didn't verify all method calls. In case we would uncomment this line and we will invoke the method on the mock that we will not verify. I created new method that is called evaluate template just for the sake of example. I invoked it here and after that we will call verify no more interactions method. We will get failure. So, this example shows us the main goal of the method, I mean verify no more interactions method. The goal is to check if any of given mocks has any unverified interaction. One more interesting thing to know about mocks. By default, all mocks return the default value of the returned type. For example, if method returns string, then method invocation on the mock will return null, because null is default value for all reference types. That is because mock object is a specific object that has compatible type with the real type. And imagine that you want to stop some methods, but not all of them. You would like that some methods would work as a real object. And here is an example. In the first case we will print null to console. And in the next case, I wanna say that when I will invoke method on the mock object, the real method of that object will be invoked. So in this example, when I will invoke prepare message, some template will be printed to console. That is because implementation of real object returns such string. I want you after the lesson would investigate the source code and run this code including the commented lines. Just uncomment them and execute the code. This will help you to get better understanding of the topic. As usual, I will leave links to the source code in the attachments to the lesson. So hope this approach would help you sometime in the future. Let me show you a few more tricks with Makita. To understand the next feature of Makita, let me explain you what improvements I did to our code to show you the next example. Imagine that in mail server we have new field of type validator. The goal of this type is to validate a mail before sending and throw a legal argument exception in case a mail is not valid. For example, doesn't contain all necessary fields. Sometimes you just need to pass the result of method invocation to another method, but in fact, you're not always bothering about all list of arguments. Probably in some specific test case, you verify only one scenario where other arguments are not critical, but you have to use arguments because compiler wants you to do so. What will happen in case I will get this field in my method stub and I will pass it, for example, to another method, and it will be used to invoke some methods on this object? Null pointer exception will be thrown in the line where I call validate method. I created object of my mock, but I didn't create object of my validator and didn't inject into mail server. How to avoid this null pointer exception? Well, the first option is to inject all possible mocks inside. But sometimes it might be extremely complicated because you might have multiple fields and those fields in turn also have inner fields and so on and so forth. This can make you declare hundreds of mocks or just dummy objects to make sure that test can be executed. But what to do in case we want to simplify things? Makita allows us to return deep stub. That means that all fields inside our mocks will be also stubbed with dummy objects and will return default values. But at least I will not get null pointer exception in the line with my validator. To make deep stub, you have to do the next things. Near the mock annotation, add answer key and make it equal to a constant from answers enum. I used deep stub. After this, I can call test method again and I will not get null pointer exception anymore, because every time I will call method on my mock, I will get dummy object in return. There are also other answers. They are calls real methods, returns defaults, returns mocks, returns self, returns smart nulls. I believe that other answers are self-describing. You can use different answers on your mock based on the specifics of your test. But again, instead of using auto-answering, I would prefer to set behavior to each specific mock manually. For example, if I want this object to return validator, I would rather stub this method and would create validator object here in test. Because I want to have control over everything what is happening inside the test, and I will not rely only on auto-generated answers. But still, programming, like everything else, is a question of trade-offs. You can evaluate complexity of setting behavior for all the chain of invocations and stubbing answers with default answers, and then decide what works better for your solution. Now, when we learned this, let's proceed. In previous lesson we learned core argument matchers, but there are also another group of matchers. Where are they located? They are located in class additional matchers. In our example, I made a static import from this class. Imagine that we have mock of list type, and you can see that I can create mocks based on the interfaces, and I want stub methods and set the behavior. In this case, in case I will call get method with index either equal to 1 or 2, then I will return more string. And in case I will invoke get method with any index that is greater than 2, then we will throw an exception. That's how easily you can use argument matchers to set a behavior for a range of values. In case we would print result to console, we are going to see more in the first 2 lines, and in the third line we will get runtime exception. Does it make sense? There are also a lot of other argument matchers. From their names, you'll easily understand what they verify. Not, less than or equal to, greater than or equal to, find, that takes regex as an argument. You already know equal matcher. In the additional matchers package, we have equal matcher for float and double, comparable equality, array equality, and AND matcher argument. Feel free to use these matchers whenever you need based on the logic of your test. Hope this is clear. Let me explain you the next thing. By this moment we set behavior for the methods that return at least some value. We substitute values that should be returned with the one we wanna be returned. But if we need to set behavior of the void method that returns nothing, what to do in this case? Let me show you how to work with void methods in Makita. You can pass method invocation on mock with when method. So this line won't be even compiled. You can't pass method invocation on mock with when method. So this line won't be even compiled. What to do instead? Instead we are going to use the next construction, do throw. Here we'll specify type of exception that we would like to throw. After that I call when method and pass mock there. But pay attention. This is different when method. This is when method of type stubber that is returned by doThrow method. The interesting thing is that I don't call method on mock here. Instead, I call method after this method invocation. So that is construction that we have. By default, void method in mocks will do nothing. But in case we would like to capture argument that was passed to the mock during the method invocation, we can use the next construction. Do nothing, when, pass mock here, and after that call method with capture. By the way, here you can see one more way of initialization of argument capture. Also, we can override method execution. We can use doAnswer method and pass the lambda expression. The argument will be our method invocation, and inside the function I can extract arguments by their indices. And inside the method you can perform any assertions you would like. In this particular case, I want to show you that when I invoke add method with index 3 and this string, I can extract them from the method invocation object. And knowing this, you can use the information as you wish, depending on the test logic. Is it clear? Hope it is. Anyway, you can look at the source code, and I'm always happy to answer your questions in case something is still unclear. Let's continue. There are a few limits with Makita. Let me share with you a few, but the most interesting limitations of Makita library. We can't mock final classes, and we can't set behavior to static methods. On this example you can see how I tried to mock string class. If you remember, string is a final class and can't be extended or overwritten. Also, you can't set a behavior for static methods. No matter how would you try, Makita library can't do that. Besides that, we can't mock equals and hashcode methods. These are the most important limitations of Makita in my opinion. Later in this course we are going to learn with your Power Mock library that will help us to deal with some Makita limitations. And the last thing for today that I would like to discuss with you is spy objects. How to create spy. Very similar to the way we can create mock. We can declare a field in our test class with spy annotation. And after that, we should either to use Makita extension or call initMocks method from Makita annotations class. Pay attention that spies are just wrappers above real objects. You can create spies only based on the concrete classes, but not abstract and interfaces. So I specify concrete class name here. Another way to create spy is to call spy method from Makita class and pass reference to the object. Here you can see that I create list object, and after that I call spy method and pass the reference to the list object. Now I want to define behavior of get method with 0 index. It looks fine to you at the first glance, but when I will execute this code, this line will throw out of bounds exception, because here I call method on real object, and our list is empty. That's why it can't extract value from 0 index. All method invocations on spy objects are delegated to real objects, unless you specify it in another way. But how we can set behavior to the spy then? There is another construction for that. I write do return and tell what I would like to be returned. After that, I call when method and pass the reference to my spy object, and after that, I call methods that I would call. This construction eliminates direct method invocation on the spy object, you see? And in this case, when I will call get method with 0 index, I will get the value that I expected. The same as with mocks, I can verify behavior on spy objects. I can verify method, and after that I can use all methods, matchers, captures like we used with mocks. How to choose when to use spy and when to use mocks? The answer is simple. In case you don't think you need spy, use mock. As usual, it is crystal clear when you need spy in your test. So create mocks by default, and in case you would need spy object, you will understand that during the testing. We would like to create spy object when we don't wanna mock all possible methods, and indeed, we need some methods to work as they implemented by default. That is some kind of fake object that behaves almost like a original one. And also you can verify behavior on spy object, but you can't do this on real object. That's it. That's all what I want to discuss with you in this lesson. Let's recap what we have learned today. In this lesson we learned how to verify invocation order. Also we learned advanced Makita features. For example, now you know how to check that method was invoked specific number of times or was never called at all, and how you can verify behavior of void methods and in case method returns nothing. We learned different answers policies, and I showed you how to create deep stubs on the mocks. On real example, I showed you how you can call real method on the mock in case you need to call specific method for the sake of the test. Also, today we learned additional matchers that you can use in method invocation during the testing. We talked through Makita limitations, and you know what Makita can't do. And at the end of the lesson, we learned how to work with spies and specifics of spy behavior configuration. That's all for today. Thanks a lot for your attention. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello dear students, in this lesson we will learn how to work with PowerMock library. We'll start from library overview. I will explain you when we need to use PowerMock. After that, I will share with you all necessary dependencies you have to add to your project to be able to work with PowerMock library. And once we will be ready to work with this library, we'll start from the setting up your test class. There are a few steps that you have to do on the class level before starting work with PowerMock. During the lesson, I am going to show you dozens of examples that I prepared for you. On real examples, I will show you how you can mock static methods. You will see how you can mock final class in case that will be needed. We'll talk how to deal with such Makita limitations as mocking of equals and hashcode methods. I will show you how PowerMock can help us with this. There will be other examples that will help you to understand how to mock native methods, constructors, final, and even private methods. Also, we are going to learn how to work with spy objects in PowerMock. That is our agenda for today. I believe we are ready to start. Let's start from understanding why we need PowerMock library. Testing with the help of mocking frameworks has been recognized as a useful practice for a long time, and Makita was the most popular library on the market over last years. While Makita can help us with almost everything, there are some things it can't do, like stubbing or testing private, final, or static methods. It needs much more power to write test cases for such methods, which usually causes developers to write cumbersome code for these methods. Here, PowerMakita comes to the rescue. PowerMakita is capable of testing private, final, or static methods, as it makes use of Java Reflection API. Let's talk a little bit more about the library itself. PowerMock uses a custom class loader and bytecode manipulation to enable mocking of static methods, constructors, final classes and methods, private methods and more. In case you are already familiar with any mocking framework, it will be like piece of cake for you to understand PowerMock. Developers familiar with the supported mock frameworks will find PowerMock easy to use, since the entire expectation API is the same, both for static methods and constructors. PowerMock aims to extend the existing APIs with a small number of methods and annotations to enable the extra features. Basically, the only things that still we have to do is to learn PowerMock API and understand how we can use it. So, let's jump to Eclipse and look at examples that I prepared specially for this lesson. But before that, let's start from adding necessary libraries to our project and downloading them from Maven repository. The important thing you have to know is that PowerMock doesn't work with JUnit 5 by the moment I create this lesson. PowerMock works just perfect for JUnit 4, but there is no support for JUnit 5 so far. I read that developers of PowerMock are going to create extension for JUnit 5 and hopefully it will be ready soon. I still recommend you to watch this lesson because I don't think that API will be changed significantly in the nearest future. That's why you have to be sure that you have all necessary libraries for JUnit 4. It will require from you downloading of different libraries. So, what do you need? You need JUnit version 4.12, Hamcrest core. JUnit of version 4 requires Hamcrest library, but I recommend you to download Hamcrest all library, because our next dependencies will require Hamcrest all, but not just Hamcrest core. PowerMock module for JUnit 4. It comes with dependencies, namely PowerMock module JUnit 4 common. This library in turn requires PowerMock reflect and PowerMock core. PowerMock core requires Java assist library and libraries that we used for Hamcrest. Just make sure you added them and didn't miss the lessons. Pay attention that this library requires Hamcrest all. PowerMock reflect requires bytebody libraries. Also, I recommend you to download PowerMock API Makita and together with that also download PowerMock Makita API support library. Finally, that's all dependencies that we need. Make sure you downloaded them and added to the project. Be careful because there are a lot of them and I want you pay as much attention as you can while downloading and adding libraries to your project ClassPath. As usual, I will leave link in attachments to this lesson with the library that you have to download. Now, when we have environment configured, let's proceed with our code examples. For the sake of our example, we will use final class string and class with static, private and final methods that I created in this Java file. To work with PowerMock, there are a few configuration things that we have to do in our test class before running tests. Taking into account JUnit 4 doesn't have extension like we have in JUnit 5, we have to use special runner to use PowerMock. Above the test class, put annotation run with and pass PowerMock runner class. The second thing we have to do is to prepare classes for mocking. We have to say to PowerMock what final and classes with static methods that we are going to mock. There are different options to set this. We have to put prepare for test annotation and we can pass array of classes there. Or we can specify package with classes that we wanna mock in this test. Both options are fine. You can use the one that works the best for you. Now we are done with configuration and we are ready to proceed with code examples. In the first example, I will show you how to mock static methods. I use this class name in the prepare for test annotation. In the test where you wanna create mock, you can use the following PowerMock API. First of all, call mock static method from PowerMakita class. Pay attention that here on top I did a static import. This method enables static mocking for all methods of a class. We have to pass a class to this method. After that, you can use API that you already used to. We call when method from PowerMakita class, call methods that we wanna mock and after that specify behavior that we wanted to set. API is very close to the Makita API that we learned in previous lessons. So, I will not stop on that. In our particular case, I made a mock and set behavior for getNumber method. Now, getNumber should return 10. In a session part of my test, I verify that I really get 10 now. And test is passed successfully. Taking into account we created mock, other static methods of this class returns default value. Here you can see that getRandomString method returns null, whereas in fact, this method returns some random string by default. So we can be sure that we really created mock object from this class. Also, I can verify not the result, but the behavior itself. In case we want to verify that some static method was invoked, we have to call verify static method and pass class that is under the test an expected number of invocations as an argument. And right after that, we have to invoke method that we expect to be executed. This is just API that we have to remember. The verify static method must be called right before any static method verification for Power Makita to know that the successive method invocation is what needs to be verified. Pretty simple, don't you think so? Let's continue. In case we wanna mock final class, you have to use mock method. If we would compare mock method and mock static method, the first difference is that mock method returns the reference to the mock object, while mock static method is void and returns nothing. Mock method creates a mock object that supports mocking of final and native methods. When we have the reference to mocked object, let's try to mock some method of string object. For example, let's set behavior for length method. I will get 20 in case I would call length method, and in assertion part I verify this. Also, as you remember, Makita can't mock equals and hashcode methods, but PowerMock can. The algorithm is similar, and here you can see examples me mocking equals and hashcode methods. Besides that, PowerMakita can mock native methods. I believe you remember that hashcode method from object class is a native method. Everything is the same from the API standpoint. I can mock native method and here proofs. In case we'll execute this test, all verifications will pass. Now let me show you how you can mock constructor. This is also one of limitations in Makita library, but PowerMock will help us to deal with this. I created object of my custom class and set the state to this object. And I want that when constructor of this type will be called, I will get this object by default. To configure this, I call when_new method and pass my class there. After that, I call with_no_arguments method just to tell that I wanna stop constructor without parameters, and after that I specify that I wanna get the reference to this object in return. To prove that I really get previously configured object, I verify this in my assertions by checking the state of new object, namely, that int value is equal to 2 and string is equal to the string I set before. To verify behavior and that constructor was invoked, you can use verify new method. As you can see, I can use times method from Makita library to specify expected number of constructor invocations. And similar to this example, I can mock constructor with arguments and verify that constructor with arguments was invoked. Here is an example. The only difference is that I call with_arguments method and pass argument matchers during the mocking and verification. That's all. I would say that API for mocking constructors is pretty intuitive. Similar to Makita library, I can partially mock my classes and make spy objects. In this example, you can see how I create spy. And the difference between Makita and PowerMock is that I pass class object instead of the instance of this class. And after that, you can see mocking that is already familiar to you. To prove you that this is spy but not mock, I call getRandomString method. Do you remember example at the beginning of our lesson? In that case, getRandomString method returned null, because that was mock. And this example proves that we have partial mocking here, because getRandomString method returns the string as it is implemented in the method. And now I'm going to show you one of the most amazing features of PowerMock. Now we'll look at examples that shows us how to mock final methods. To be able to mock final non-static methods, we have to create mock based on the class. Now we can mock our final method, and in the assertion we verify that we successfully mocked our final method. We can also verify that our final method was invoked with the help of Makita. And the last but not the least for today, mocking of private methods. Sometimes it might happen that you wanna imitate very specific cases, and to do this you have to mock private methods. But this might be complicated sometimes, and to be able to test such classes, sometimes developers change access modifier from private to package private, but actually this is not the best way if some specific method is for internal usage only. Why you have to make it accessible for all units in the package? Just to write test? Here's where PowerMock comes into play and helps us to mock private methods. The only difficulty is that to mock private method, we can't make method invocation because they are private. To mock private method, we have to create spy object based on the instance of our class. And pay attention, you won't be able to mock private method based on mock only. You have to create spy object for that. And the difficulty with mocking private methods is in the fact that we can't call private method outside of the original class. That seems to be logical. But what to do in this case? We still use when method, but we'll pass name of our private method, and using mechanism of reflection, PowerMock will mock our private method. To verify how private method works, we have to call another method. That is also logical because usually in real life you don't call private methods on the object. They are invoked somewhere inside your class. For the sake of the demo and to prove that we successfully mocked private method, I created separate method that is called callPrivateMethod. And inside this method I return value of my private method. In real life logic might be more complicated here, but my goal now is to demo that we managed to mock our private method. To verify that private method was really invoked, you have to call special method from PowerMock class that is called verifyPrivate. You have to pass spy object there and call invoke method with string that contains private method name. That's it. Now you know how to work with PowerMock. Let's recap what we have learned today. In this lesson we learned why do we need PowerMock. Now you know how to set up environment and add all necessary dependencies to be able to use PowerMock. You learned how to set up test class and what runner you have to use to be able to work with PowerMock. And after that all our focus was dedicated to PowerMock API. You learned how to mock static, final, private and native methods. I showed you how you can mock constructors and how to work with spy objects in PowerMock. Hope you enjoyed the lesson. Thanks a lot for your attention, have a great day and see you in the next lesson. Hello dear students, in this lesson we start super important topic. Today we'll learn with you test-driven development. We'll start from understanding what is test-driven development. I will explain what this development technique is about. To help you understand it better, I will explain you the basics and we will talk about TDD cycle. After that, we will be diving into more difficult concepts. We will learn 3 laws of TDD. Many engineers often confuse test-first and test-driven development. Today I will tell you what is the difference between these two concepts. In previous lessons we already learned testing pyramid, but today we will discuss how testing pyramid and TDD is connected. While talking about test-driven development, I will explain you what defect cost increase means and how TDD helps us to decrease cost of each new defect. And at the end of the lesson we will talk about advantages and disadvantages of TDD approach. And to start with, let's understand first what TDD is. TDD stands for test-driven development. This is software development process that relies on the software requirements being converted to test cases before software is fully developed. According to TDD approach, you track all software development through the repeatedly testing software against all test cases. Test-driven development is related to test-first programming concepts of extreme programming. But supporters of TDD put in stress on the difference between test-first approach and test-driven development. A bit later today, after learning what TDD is, we'll compare test-first and TDD approaches. Founder of TDD is considered to be Kent Beck. Now let's learn a little bit more about TDD and understand how it works. In short, the idea is simple. If you're developing system, just write a test first. Just create a test that will verify your API. This will help you to understand how you want your API would look like. Because by writing a test, you already create a client of your code. And after you wrote a test, write just enough code to make this test pass and make it green. Do you think you wrote not enough code and this is not how your API have to look like? That's fine. But probably you mean some other test cases? Just write the next test and start this iteration one more time. While definition of main steps according to TDD cycle is very simple, it leaves a lot of space for own interpretations. Therefore, TDD implementations vary from developer to developer and unfortunately, those variations are not always cosmetic. There are 3 main steps on each iteration of TDD cycle. The first step is called red. Write a test and make it fail. At this step, you don't have any implementation. The next step is called green. Write just enough code to make your test pass. And the next step is refactor. Improve your code without changing its behavior. It's an optional step that you may skip on some iterations, but it can be that you found some optimization, or you just want to remove code duplication. That's what you can do during the refactor step, because you already have a reliable suite of tests that you wrote to verify expected behavior. There are 3 laws of TDD. The first law sounds like this. You may not write production code unless you have written a failing test. This is a simple one. The second law sounds like this. You may not write more of a test than sufficient to fail. This law will help you to clearly separate different test cases and different scenarios to not mix them up. And the third law stands the following. You may not write more code to make the test green. This will help you to avoid writing the code that is not used at all. Moreover, this principle will help you to think through the test cases more thoroughly. Because to write some code, you will ask yourself first, why do I need to write this code? What test case I'm going to cover with it? Many developers that I taught how to use TDD in enterprise applications always ask me, how I have to write the test for the thing that I even don't know how it will look like from the implementation standpoint. Well, I ask in return only one question. How would you write the code and implementation if you can't write the test that contains client code to use your implementation? If you even don't know how to write tests, then how you know what implementation you have to create? Does it make sense? And let's also talk about this from another side. It can be that you don't know where to start. Imagine you receive task and you don't know what are the first things you have to do. But even in case you don't know how this feature will work, you have to know at least what your code has to do. You may not know all the details of implementation, but you have clearly understand the end result. Knowing the expected end result, you have to be able at least to create a test. Agree? And now, the question that TDD followers like to ask during the interview. What is the difference between test-first approach and test-driven development? Because test-first approach is not a new idea at all. What TDD brings to us? I will explain you now. But first, I will ask you a question. Did you know that around 70% of working time is an adding of new feature to already existing ones? And in general, only 30% of your working time in your career you have opportunity to build something completely new from scratch. And you know what? Write code from scratch to make it work, it is not difficult at all. A lot of people can do this nowadays. But write code in the way it will be easy to scale, that's a hard thing to do sometimes. And that is exactly why TDD followers like test-driven development approach. Following TDD approach, implementation of each new feature won't lead you to endless period of bug fixing in old feature. Implementation and adding new functionality will be easy to predict, and it wouldn't take twice as much time to complete new feature because of unpredicted defects. Why? Because TDD ensures clean code design and robust architecture. And even more, TDD allows you to detect errors as soon as it is possible, so that you have time to fix errors on the earlier stages instead of building infrastructure around the defect only to find them later. Kent Beck, in his book TDD by Example, intentionally didn't use test-first development term. The idea was to put a stress on the fact that tests in TDD are not for the purpose of testing itself, but more for the purpose of driving the design. The problem from my point of view is that you can practice test first without doing TDD. You can have the whole design of your system done, but during the implementation you will write your tests first. That is not test-driven development. Although TDD uses test first, it adds something more on top of it. In TDD, your tests should drive the design of your system. TDD was never saying you can't design before you start coding. It merely follows the path of agile practices that you shouldn't spend a lot of time on designing upfront because your design is likely to change as you gain better understanding about your domain. That usually happens during coding as you discover issues with the design. Do I completely agree with this statement? Not completely. TDD is just a tool, and it always depends who will use this tool. Definitely, in case this tool will be used by junior engineer, there is no guarantee that this approach will lead us to good design. Skills of working with TDD is one of the obstacles to start working with TDD. A little bit later in this lesson we'll learn pros and cons of working with TDD. Previously in this course I shared with you concept of testing pyramid. Hope you remember what it is. But just to recap, in short, we use testing pyramid term when referring to group of tests on different test levels and their ratio between each other. The concept of testing pyramid originally was created by Mike Cohn and described in his book Succeeding with Agile. In the perfect world, we would love to completely automate all possible tests on all levels. Definitely, that is not what we can afford, because there are also not functional requirements that are easier sometimes to test manually, rather than spend months to find out how to automate this. By the way, always keep this in mind. In case you will be asked what is worth to automate, what doesn't, you can answer that there is always a matter of cost. In case the costs that would be spent to automate some specific verification will be higher than verified manually through the whole product life cycle, you don't have to automate this. But in perfect world, it is always a dream of any developer to have one button that will help to verify the whole system and make sure that these verifications are all automated. Book and examples might be sometimes misleading, just because not putting enough stress on the fact that TDD approach is not applied only for unit test level of our automated testing pyramid. Usually, it is the easiest thing to explain how to work with TDD on the example of unit tests, but that is not only the place where TDD may be applied. You can also apply TDD approach on other levels, for example, integration, function, and UI levels. Now we are going to learn one more of the arguments that is used by TDD followers. I am going to explain you what defect cost increase is. The chart that you can see on the slide explains how cost of fixing defect is increasing over time passed and based on which stage of development the defect was discovered. On the x-axis you can see SDLC phase. SDLC stands for Software Development Life Cycle. And on the y-axis you can see relative price value of fixing the defect. In case defect was discovered on the stage of requirements gathering, the price will be lower than in case bug will be discovered after deployment of the solution to production, during the maintenance phase. Based on this chart you can make a conclusion about the cost of the defect. The later defect was discovered, the higher cost of fixing it has. But why? That is because fixing defect on prod requires involvement of bigger group of people that includes project manager who will coordinate hotfix on the production environment, QA engineer who will hold regression testing before deploying solution to production after hotfix, developer's time to fix the defect, and so on. And this is not taking into account losses that company gets because of the providing their services. For example, defect in financial applications may cost millions. But is defect cost increase really true nowadays? And if yes, how big increase in cost is? I wish I could answer this question precisely. But because of the software specifics, each product is unique. Each business domain is unique. It is almost impossible to calculate exact cost increase because it depends on millions of factors. But let's try to understand whether this metric is relevant today. Defect cost increase is based on the observations that were discovered in big companies that all of us know in late 60s. That was true for that period of time, since dominant approach in software delivery and the most popular software development lifecycle was waterfall. In case you don't know what waterfall is about, let me briefly explain you. In short, waterfall is a delivery model that clearly separates the stages of the project starting from the requirements gathering, designing, prototyping to actual development, testing, and release. The whole cycle until you get your application released will take from few months up to years. whereas nowadays agile methodologies are commonly used. Different agile methodologies are focused on the delivery model that allows to get feedback from end user as soon as possible and make lead time, that is time elapsed from order to delivery, as short as possible. So in case fixing defect according to waterfall requires code to pass through all stages of SDLC one more time, including updating of tons of documentation, tests, regression testing, architecture review, and hundreds of different approvals, this will take more time and more money rather than in Agile SDLC, where you have short lead time and you can deliver a fix for your defect in the next week or two. And in case you use iterative Agile models, you can deliver the fix by the next iteration. So, in Agile world, defect cost increase metric is not applicable for all domains and all kind of software. Definitely, defect in healthcare or financial application may cost you millions, but defect in some entertainment application wouldn't worth you big amount of money. Also, taking into account your software development lifecycle allows you to fix it in 1 week. While there are supporters and opponents of this theory, one thing is clear for sure. In case you'll discover defect in a month or two, there are high chances that a lot of code and other logic will be built around it, and in turn, this will make fixing of the defect more complicated. Even in case we would ignore defect cost increase, it is obvious that it is better to find the defect on the local environment of a developer before pushing it to the repository. So now you can remember that it is a good idea to write tests as soon as it is possible and even before writing code, to be able to find defects as early as possible. As any other development technique, TDD has its own pros and cons. Let's review advantages first. Test code coverage. By following TDD approach, you ensure a high test code coverage rate. This is good for you as a developer first of all, and also it is good for reporting purposes to share with your customer the level of test code coverage metric, reducing the number of defects in production. That is true. Following TDD approach makes you think about code architecture and about implementation itself, what is needed and what is not. Well-thought architecture significantly decreases probability of having defects. Improving code quality. This is one of the most important reasons to opt for TDD, because TDD helps you to drive architecture of your application, creating tests that is clients of your code. You think on the level of abstraction that will help you to build more reliable architecture that is easy to scale and support. TDD provides you with automated tests for regression testing. If you already worked as a developer, you can imagine the case when project manager comes to you and asks you to perform regression testing or some smoke checks before deploying new release to prod. One day you understand that you are tired to perform checks before each release. And at this moment you decide to create a set of automated tests that will perform regression testing of the whole system. If you are not familiar with the regression testing and can't understand what it is, let me explain. Regression testing is defined as a type of software testing to confirm that a recent program or code change has not adversely affected existing features. Regression testing is nothing but a full or partial selection of already executed test cases which are re-executed to ensure existing functionalities work fine. This testing is done to make sure that new code changes should not have side effects on the existing functionalities. It ensures that the old code still works once the latest code changes are done. And working with TDD, you don't have to be bothered about creating of automated regression test suite. Why? Because you already created it during the implementation of your application. Isn't that cool? Code documentation. Your tests document your code better than any other type of documentation. And what is extremely great about it is that you create live documentation that is never outdated. Since you are running your tests constantly, you also update them constantly. Makes code easier to refactor. Why? Because before each refactoring you have to be sure that you have a reliable suite of tests to make sure that those scenarios still working after you changed code structure. And with TDD, you have automated tests for all test cases. Now, when we learned advantages, let's keep being fair to each other and discuss disadvantages of TDD approach. Let's go over each item from this list. And the first disadvantage is the test code coverage. You might be wondering, why? Because just a few minutes ago we listed it as an advantage of TDD. Let me explain. Many managers tend to focus on metrics like test code coverage. Those metrics tell you nothing about the quality of the tests. If you saw lessons about unit testing and test code coverage, most likely you remember how you can create tests that shows you 100% test code coverage, but actually test nothing. The other thing that could be is that your tests don't test all possible scenarios, or you test all possible scenarios, but you didn't test all possible input arguments from different classes of equivalence. Imagine that you are writing a calculator and you have to cover with test method that performs addition. And imagine that this method takes two integer objects as arguments. How would you define all possible combinations of arguments that you have to test? Just to recap, class of equivalence, that is something we discussed in previous lessons, and I am sure you remember it, but let me quickly recap. Class of equivalence is a software testing technique that divides the input data of a software unit into partitions of equivalent data from which test cases can be derived. In principle, test cases are designed to cover each partition at least once. This technique tries to define test cases that uncover classes of errors, thereby reducing the total number of test cases that must be developed. An advantage of this approach is reduction in the time required for testing software due to lesser number of test cases. So in the particular case, when we need to test addition method in our calculator, there are such classes of equivalence as addition of two positive integers, addition of two negative integers, addition of positive integer with negative integer, addition of negative integer with positive integer, addition of zeros, addition in case first argument is null, addition in case the second argument is null, addition of max integer value with max integer value, addition of min integer value with min integer value. Does it make sense? And by defining classes of equivalence, you can be sure that you outlined all major input arguments for testing your method. Now let's get back to our original slide with disadvantages. So, as you can see, the complete test code coverage can bring you false sense of security in your code. The next disadvantage is test maintenance. Followers of TDD say that writing code with TDD takes in total the same amount of time as coding without TDD, taking into account all potential bug fixes and so on. I partially agree with them, but not completely. At the end of the day, your automated code base is also code that requires support. You have to update it when needed. You have to investigate issues in it when needed. For example, your integration tests may use deprecated driver, and it also takes time for investigation, analysis, and fixing. Your tests, they are the same code as all other source code of your program. Whatever people would say regarding speed of development with TDD, I can say one thing for sure. With TDD, your code base is much bigger, and it is only up to you to decide whether this is good or bad. Obviously, it will depend on how much advantages and benefits you will get in return, but this is something what you have to bear in mind before opting for TDD approach. TDD requires skills. As we discussed earlier, using TDD by not experienced developers will not bring you good architecture and other benefits that you expect to get from using TDD. TDD should be used by all team. This is a tricky one. It is completely useless in case TDD will be used only by few developers in a team. It is a critical question, whether you all follow TDD approach or not use it at all. Because all achievements that you can get from using of TDD applies to each line of code in your application. That's why it is critically important to make sure that all developers in the team follows TDD approach. TDD is a challenge to learn. I used to work as TDD coach on one of my projects and faced with the challenge of accepting TDD by developers who never worked with it. Because it is completely different mindset. You start thinking in a completely different way, and this is maybe complicated. That's why I believe that this can be considered as one of disadvantages of TDD. It is hard to apply TDD knowledge to legacy code base. A lot of the times we are not starting projects from scratch, but helps to add additional features and fix defects in already created code. And this might be complicated to apply TDD approach to already existing codebase. In such case, you have to start from test code coverage of legacy code, refactor it, remove code that is not used, and then proceed working with TDD. That's it. You have to consider all these pros and cons before starting work with TDD. Now you know advantages and disadvantages of using test-driven development, and you are ready to make a decision whether you wanna apply it on your project. TDD is always a matter of trade-offs between speed of development and quality. Now let's recap what we have learned today. In this lesson we learned what TDD is. Now you know how test-driven development cycle looks like and what red-green refactor actually means. During the lesson we reviewed the difference between test-first approach and test-driven development. Hope that after this lesson the answer is clear. We reviewed what defect cost increase is and how TDD may help us to reduce cost of the defect. And at the end of the lesson, we learned advantages and disadvantages of TDD. Thank you all for your attention. See you in the next lesson. Hello dear students. In this lesson we are going to learn what behavior-driven development is, what acceptance test-driven development is, and how to use them. We'll start from the definition of BDD and its history. Very briefly, and just to give you a context. To better understand what BDD is, we'll compare BDD and TDD. I will explain you how to create BDD scenarios and how Gherkin syntax looks like. During the lesson I will explain you how software engineer can apply BDD knowledge on daily basis. We'll review advantages and disadvantages of BDD. And at the end of the lesson I will explain what acceptance test-driven development is and how it is different from BDD and TDD. We have a lot of things to learn today. Let's start. And to start with, let's understand first what BDD is. BDD stands for behavior-driven development. There are a lot of different definitions that describes role and responsibility of BDD. Some of them are very high level and most of them are far from the original meaning. Let me share with you my vision what BDD is. First of all, BDD is a process of requirement gathering and analysis. In the internet you can find a lot of definitions that tells you that BDD is about test automation, that BDD is about integration tests, or even that BDD is the same as TDD. A lot of articles that are written by developers on the internet are completely different from the vision of BDD founders. It is hard to say who was the author of BDD idea originally, but it is worth to mention names of people who were investigating agile delivery and wrote articles about BDD. They are Daniel North, Liz Kerr, and Ken Beck. The second thing to understand about BDD is that it uses special domain-specific language called Gherkin to describe test case that is clear to understand for all parties of development process: developers, testers, and business representatives. BDD ensures that all participants of delivery are on the same page regarding software requirements and expected system behavior. A bit later today, on real example, we will understand what Gherkin is and how it works. The third thing to learn is that BDD emerged from TDD to address TDD disadvantages. The main disadvantages of writing code driven by tests are: how to know if a specification is met? Does the code deliver business value? Overcoming those disadvantages is why BDD was born. If BDD emerged from TDD, then what is the difference between TDD and BDD? Let's answer this question to better understand what behavior-driven development is about. With TDD, we can be sure that all lines of code are covered with tests, and that is really great. We have a lot of tests, all of them are automated, we don't have code that didn't work, that is just perfect. But are we sure that we wrote the correct tests? Or what did we use as a source of requirements to create our test cases? Are we sure that we really covered all cases that our program has to address, or no? And the last question, how we can be sure that we wrote enough of tests to verify our system? BDD helps us to define behavior scenarios that will be used as requirements for our system. What our system has to do when user has enough money during the purchase, how our system should behave when user doesn't have enough money for purchase, what will happen during the purchase in case during the checkout system found out that there are no more such product at the warehouse because of the concurrent purchase. BDD doesn't give us answer what method in our class I should verify. It is not focused on the code itself. BDD helps us to understand what tests we have to write before we start implementation. With BDD we can be sure that we tested correct scenarios. And in this case, expected behavior drives our development. Does it make sense? So instead of focusing on testing some specific acceptance criteria, we are focusing on testing user flows. Those are behavior scenarios. BDD helps us to make specific choices while working with TDD to write specific tests by using desired behavior as a definition for each test case. BDD helps us with the next things. Where to start development process from which scenario, what has to be tested and what hasn't, how to name tests to not forget that I tested such case, what is the precondition for each specific test case. I believe now it is clearer what BDD is. But we still have a lot of questions to answer, and one of the questions that you're probably thinking about at the moment is how BDD helps us to define behavior scenarios. What format we'll use to create specific BDD scenarios. To describe BDD scenario, we use specific syntax called Gherkin. Gherkin is a business readable language which helps you to describe business behavior without going into details of implementation. It is a domain-specific language for defining tests in Cucumber format for specifications. Cucumber is a very popular library that helps to create automated tests that are mapped to human-readable text. This syntax uses plain language to describe use cases and allows users to remove logic details from behavior tests. With the help of simple words, given then you describe use case that your system has to implement. It will be easier for you to understand this in practice. Let's take a simple example that is easy to understand for everyone. Imagine you have to implement login functionality in your application. How would you describe this requirement with Gherkin syntax? Given I am guest user and I am not logged in, when I press login button, then I see login pop up. Here is how a scenario will look like. As you can understand, you can also use AND keyword to combine some conditions. In BDD scenario you have precondition, that is our given part, some action, that is our when part, and results that you wanna verify, that is our then part. And you know what is the best about this scenario? Everyone in your team can understand what you expect from the system. Non-technical people like product owners or business analysts can confirm that this is exact behavior that he expects from the app. Tester can easily understand what he is going to test, and developer can easily understand what he has to implement. That is the goal of BDD, to make sure that everyone understands requirements in the same way. And believe me, with such approach you can describe any functional requirement. You can describe generic scenarios, but this is more advanced techniques of writing BDD scenarios, and we will not stop on them at this moment. Because for development purposes you know more than enough now. Now let's answer the question why we have to use BDD. And what is more interesting is how regular developer can apply BDD knowledge in practice. This technique will help you to come up with a set of tests to be sure that you covered all necessary scenarios. And you can apply this technique while working with TDD. As you can see, TDD and BDD is not the same thing, but can be used together. Also, the roots of using should word at the beginning of the test name are also come from BDD approach. When we name test starting from should word, we wanna tell behavior that should be followed by our application. In our method name, we tell what our program should do. Also, your knowledge of BDD helps you to understand the requirements. Imagine that you come to an interview and really can't understand what interview task is about and what they want from you. In such cases, I always recommend to calm down and ask your interviewer additional questions. You can ask him that you need to know precondition and expected behavior and start describing requirements in BDD format. First of all, this will help you to understand the task better, and also it will show your knowledge of BDD technique. So now you can easily answer a question about how much tests you have to write to be sure that you covered all necessary requirements. Now we have enough knowledge to understand advantages and disadvantages of BDD. Let's start from advantages first. The first advantage is that BDD makes sure that business gets what expected. And this is really important, because we develop software not always just for fun. but to solve some problem and to help people. Very often we communicate with non-technical people, business owners, marketers, who can't understand development process. But BDD is a simple and understandable thing that everyone can understand. That's why using BDD, customer can get the product that behaves exactly in the way customer expected. The second advantage is about helping improve communication in a team. By providing a readable and understandable vocabulary, BDD helps bridge the communication gap between clients, developers, and other stakeholders. A shared language ensures everyone, technical or not, has enough understanding of the status of the project. This creates collaborative environments that helps business and technical teams to create software with business value. The third advantage, BDD is easy to start with. BDD is not about making complex things even more harder to understand. The goal of BDD is to simplify things. As you already know and saw an example, BDD utilizes specific language called Gherkin, which is so easy and readable that even the users can use it to add features or requests. Fourth advantage, the software design follows business value. In fact, BDD puts great importance on the business value and needs. By setting priorities with the client based on the value it provides, developers are able to provide a better result because they have a strong understanding of how the client thinks. By focusing on the value, no useless features are built. And fifth advantage, it is something what logically follows from everything what we have discussed above. Lower costs. By improving the communication inside the team, we improve quality of the code. And by improving quality, you are basically reducing costs of maintenance and minimizing the project's risks. Now let's talk about disadvantages. The first disadvantage is that you can't cover non-functional requirements with BDD. To be specific, you still have to use UI mockups in case you have specific requirements for user interface. If you have some specific security, durability, localization, and internalization accessibility requirements, all this is hard to capture and describe with BDD. So you still have to use either technical nodes to BDD scenarios or additional artifacts to cover non-functional requirements. The second disadvantage is need in communication with stakeholders. While this can be just perfect from BDD standpoint, that is not always the case in reality, because according to BDD process you interact with product owners and business representatives on daily basis. Very often, key stakeholders are very busy with multiple other tasks. And also, technical people and non-technical people are forced to talk to each other and even work together closely to articulate features. Somebody thinks that this is really a disadvantage of BDD approach, that's why I mentioned it here. But in my opinion, it is only a matter of priority and how important the end product for your customer. In case the product you develop is a top priority, your customer will be interested more than you in daily communication to address open questions and blockers. Also, it is worth to mention such disadvantage as documentation maintenance, because creating of tons live scenarios that possibly will be automated requires also support of such documentation, and ensure that there is no any contradiction in it. Also, we shouldn't forget that BDD scenario is not a specification for developers. BDD scenario won't contain details about API, all dependencies, all necessary calls you have to make to extract data you need, authorization and authentication of requests also won't be described in details. So, we have to admit that only BDD is not enough to deliver a specific scope of work from the beginning till the end. And the last disadvantage in our list is to highlight that implementation of a BDD on the already existing project, it is not the best thing you can do. Fitting BDD to an existing project can be a time-consuming and difficult process. Should you invest in creating BDD feature files and scenarios for legacy features, or should you just focus on what's coming next? This would be an important consideration with any specification and testing approach, so, while not a drawback related specifically to BDD, it is worth keeping in mind. And now, when you know TDD and BDD, I want you to understand one more important concept that will help you during the development. I want to explain you what ATDD is. ATDD stands for Acceptance Test Driven Development. Acceptance Test Driven Development is related to TDD, but the main design driver are the acceptance tests. The tests are more oriented on communication with end users. BDD is used to define scenarios for test cases that will be automated. BDD itself tells nothing about testing or automation. BDD just describes approach and how to capture requirements to be sure that delivery team and business team are on the same page. If you want to compare ATDD versus BDD, it is worth to say that in general, they are similar, with only few differences. As we already discussed, in BDD there is no specific requirement to automate tests. The main idea is around collaboration and communication. In test-driven development, test automation is one of the key things because it's very hard to imagine TDD with manual testing. But TDD doesn't put enough stress on how to define correct set of tests. So in case we would combine TDD with BDD, we'll get ATDD. We'll get approach with mandatory test automation, where test scenarios will be defined according to BDD approach. Does it make sense? And do you know what I like the most about ATDD? In case you would follow ATDD process, there are no defects. There are just missed scenarios. In case something doesn't work, the first thing you do, you check whether such scenario is in place and whether you automated it. In case there are no such scenario, this is not a defect. This is just new scenario. That is super simple. Basically, that's all what I planned to share with you in this lesson. Let's recap what we have learned today. In this lesson we learned what BDD is and how BDD appeared. Now you can understand the difference between BDD and TDD. On a real example we saw how a gherkin syntax looks like. I believe now you can imagine how you can create and read BDD scenarios. We learned advantages and disadvantages of BDD. And at the end of the lesson we reviewed what acceptance test-driven development is and how it is connected with TDD and BDD techniques. That's all for this lesson. I believe we learned a lot today. Thanks a lot for your attention and see you in the next lesson. Hello dear students, we have learned a lot about TDD, BDD and ATDD by this moment. But the most interesting thing is to how put gained knowledge on practice. And in this lesson we will be mostly focused on the practical side of TDD and BDD approach. On the simple example I will show you how we can develop application from scratch using acceptance test-driven development. After this lesson you will have enough theoretical and practical knowledge to start using TDD in your everyday development. My goal is to help you understand and feel the rhythm of TDD development. Writing a test is just an exploring the house in the dark. We are walking from one room to another, gradually learning everything about the house. Similar to that, we are writing our application by writing one single test at a time and understanding how application will look like. Today we will implement application for marketing department of any organization. Do you know different online services that provides you with possibility to create personalized emails? For example, you have email template for every employee for special occasion. Each year, each employee receives a mail with his name and number of years he worked in the company, but template is the same. So we have an application that allows to paste personalized information into the email template and send it. Or imagine some template about purchase where we have to paste name of our customer, his order and total price. Can you understand what this application is about? To help you understand what application we are going to implement, on this slide you can find some analogs. You can Google these in case you are interested in this specific example and you have never faced with such applications before. And we will implement this application with TDD approach. We'll apply our knowledge of BDD as we keep progressing with implementation. Where we have to start? What object should we create? That is the wrong question. We shouldn't start from objects. We have to start from tests. When we start from test, it is similar for us telling a story. We have to watch our application from outside and understand what interfaces, classes and methods we are going to use. But before start writing a test, we have to come up with final list of scenarios that we are going to test. To do this, let's decompose our requirements first. We will try to think about expected behavior and apply BDD knowledge. I will translate general requirements to specific set of requirements. The first thing we have to implement is that our email template should have variable placeholders. The second thing we have to implement is that our application should substitute variable placeholders from a template with values provided at runtime. In case application will not have enough values to populate all of the placeholders in the template, system will throw an error. Well, it looks like this should be enough, at least for the beginning and based on our original requirements. What I have to do next? We have complete behavior scenarios now. Let's turn these scenarios into automated tests. One of the key ideas in TDD is keeping things as simple as it is possible. We will not start from implementation of all possible tests. Start small. We'll start from one single test and we'll proceed one by one. Let's start implementation of our first scenario. I'll translate it to BDD language first, and after that we'll implement test. Given, I have an email template that looks like hello first name, and you can see that there is a first name placeholder in it. When I set placeholder value into the template and I call method create email text with name John, then I have hello John. And at the moment I create a test, I ask myself, what API will be comfortable to use? How I would like to interact with the system to get the specific result? This is the moment when I realize that it would be just perfect to have template class that would take some template as an argument in constructor. It seems to be a good idea to separate placeholders somehow, and I decide to use $sign and parentheses. But how I would like to pass values for variables? It looks like I need to set a behavior to my template object. I will declare a set method that can set value for specific placeholder, and I feel like it is a good idea to call create email text method after I set all necessary values to get my final email text. When I wrote this test, it doesn't even compile. I don't have such class as a template, for example, I don't have set method in it, and I don't have create email text method in it. The first I have to do is just to make my compiler happy. I will create a class and all necessary methods that do nothing or just return default values. Now I am in a position to run my test. And it failed as we expected. We are in the red stage of our cycle. At least now we have a concrete measure of failure. That is better than just vaguely know we are failing. We don't have bare requirements at this moment, we have concrete tests that we need to make green. According to TDD approach, we have to implement the easiest version of code it is possible and write as less as we can just to make this test pass. We don't need to find the best ever solution now and think an hour about implementation of our method. We have only one goal, to make our test green. So let's do it. And the easiest way to make this test pass is just to hardcode expected returned value. I know that probably you will not like this solution, but be patient. You will understand everything by the end of this lesson. Just watch lesson till the end. We can fake the result, and gradually we'll refactor this hardcode as we implement another test cases. We are in a green phase right now. We can refactor this code now or refactor it during the next iteration. I would suggest to refactor this code during the next iteration when need for refactoring will be more obvious. Each iteration I will run all tests to make sure that tests that already created not failing. Let's come up with the next scenario. What will happen in case I will set another value to a template? Let's create additional test where I pass another value instead of John. I use name William instead. In case I will run this test, it will be red again. And obviously that is something what we expected, because no matter what happened, I return hard-coded value so far. And now we're in a position when we need to do changes in our code to make new test pass. After thinking a bit about the implementation, I see that I have duplication of values here. Pay attention that I pass name to the test method and also I hardcode it as a return string. Let's get rid of this duplication. It looks like I have to save placeholder value when I pass it to set method. To save this value, let's declare one more field that is called placeholder value and initialize it with values that I pass to the set method. And to be sure that both tests are passed, I need to adjust create email text method. You're not going to like my solution, and I understand that, but it will be time to make this code looks more beautiful a little bit later. As of now, I hardcode only hello world together with comma and space, and after that I concatenate the string literal with my placeholder value. And now I get the result that I expect in both cases, even when I pass different placeholder value. While it is obvious for us that such solution wouldn't work in all cases, I want you to prove me this and specify in which specific cases this solution will not work, so that we can adjust our code accordingly. And to specify this, we have to create new tests. I would even say that it is time for refactoring phase now, but this is not very obvious to my students what we have to refactor here. Do we have at least something to refactor at all? Usually during the refactoring we are removing duplicated chunks of code, and it is not so obvious at the beginning what I have to refactor here. There is no need to refactor, there is need to change implementation. That's what my students usually tell me. If I would say that we need to remove duplication, what it would be? Press a pause for a second and think about it. Let me give you a hint. What if we would talk not exactly about lines of code duplication, but talk about values duplication? Just another one. We remove duplication of one parameter. Is there any other duplication? Can you see how hello world is duplicated? We use it as an argument in our constructor and we hardcode it in our createEmail text method. Can you see this? We can either refactor this code now or just come up with another test case that will help us to adjust our code accordingly. No matter what we will choose, we will get to the point that meets all the requirements. That is the beauty of TDD cycle. And remember, TDD is not about making small steps. TDD is about making teeny tiny steps. Usually for my students it is more clear when I explain the need of change with the help of a new test. So let's just create a new test case. Let's create another test and pass different template. Let's say we're going to say hi instead of hello in the beginning of our message. This test will be red at the beginning. Let's make it green. And to make sure that new test is passed, we have to get rid of the another duplications that we have in our code. Let's introduce one more field in this class and we will set the state during the object initialization. We pass template to our constructor. So now we save the template in the field called template text. We'll use this template text during the creation of email text. And now we can say that we removed value duplication. We have template now. The only thing that we still have to do is to substitute placeholder value in the template and our test will pass. The simplest option to implement this is to use regular expression to substitute placeholder with actual value. This is not lesson about regular expressions, I assume you know what it is. In case you are interested in learning regular expressions and how to work with them in Java, check my Java course. And that is why createEmail text method currently looks like this. I call replaceAll method and substitute placeholder name with actual value. Hope you already see the drawbacks of this solution. Again, I hardcoded and duplicated placeholder value in createEmail text method and in set method. Because this solution doesn't allow me to use different placeholders in the template. What will happen in case I want to add first name and last name? So, let's make things as easy as possible, and we'll just write additional test. In this test, I want to be sure that when I add multiple placeholders and set different values for different placeholders, I get valid email text. Let's say that we need to personalize our email with the first name and the last name. This test case seems to be completely valid and it looks like we really need this test case. Nothing to add here. The only thing that we have to do is to adjust our implementation to make sure that this test is passed. When we have such test case, it becomes obvious for us that we need to store mapping between placeholders' names and placeholders' values. That's why I introduce map field in a template class. Every time I set a value into my template, I add it to my map. And when I create an email text based on the template, I run over each entry in my variables map and substitute them in my result template. Does it make sense? We still have one more requirement to cover. We have to throw an exception in case there are not enough values for all placeholders. We write our test first. In this case, I have two placeholders in my template, and I didn't set any value. I expect that runtime exception with message not enough values for template will be thrown. Let's implement that. There are different ways to implement that. My goal is to opt for the easiest way to make test green and update code later during the refactoring phase in case it would be needed. and the easiest way would be to check whether there is any placeholder left in a template after I replaced all values that I am aware about. In case there is still a placeholder without a value, I throw an exception. That's it. It looks like that's all requirements that we agreed to implement at the beginning of our lesson. Here is how a template class looked at the beginning of our lesson, and here is how it looks now after we went through the multiple iterations of TDD cycle. Can you see the difference? Knowing such libraries as JUnit and some mock libraries like Mockito or EasyMock, you can create even more complex things following TDD approach. I believe that by this moment in our course you have enough information and knowledge about different tools to be able to work with TDD. Anyway, in case you have any questions, you are always welcome to post them in Q&A section of this course. I always will be happy to answer those. I believe we can consider this practical lesson as completed because the goal was achieved and you saw how to apply TDD theory in real life. Have a great day, my friends. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello dear students, in this lesson we'll talk about clean architecture. Hopefully that after this lesson you will understand what clean architecture is and why do we need it. And to understand what clean architecture is, we have to understand basic and core concepts. In this lesson we will give answers on questions what is coupling and what is cohesion. We will talk about different types of coupling and cohesion. I will explain you benefits of clean architecture design to motivate you watch following lessons from this section. On a real example, I am going to show you what is a plugin concept in architecture. And by the end of the lesson you will understand why we need clean architecture. Also, we will talk about advantages and disadvantages of clean architecture. Let's answer first. What can be considered as a clean architecture? There are multiple ways to answer this question. But if you would ask me to answer this question in one sentence, I will answer like this. Clean architecture is a code that has low coupling and high cohesion. Probably this statement produces even more questions, like what is low coupling and high cohesion? Let me answer this. I will start from explaining of what coupling is. Coupling is a degree of interconnection between program modules. The other definition of coupling sounds like this. Coupling refers to the degree of direct knowledge that one element has of another. In other words, how often do changes in class A force related changes in class B? There are two main types of coupling. They are high coupling, or also tight coupling, and low coupling, that sometimes is called loose coupling. High coupling is usually considered as a bad design. Why? Because the code that is written is not easy to scale, test independently, and support. High coupling means that it is almost impossible to make change in one module or single unit like class without updating another class. Also, you can't reuse program modules independently, and it is harder to get the logic of the code and read it. In general, if you have high coupling, two or more classes are often changed together. Low coupling is something completely opposite. This is usually an indicator of a good design and clean architecture. We can say that there is low coupling in our code in case modules in our application are relatively independent. That means they can be improved independently and tested independently. There are different types of coupling that we need to be aware of when we talk about coupling. They are content coupling. This is when one module relies on the content of another module. For example, in case we use data from another module, and when changes in the source code of one module will lead us to changes of code in another module. In a content coupling, one module can modify the data of another module, or control flow is passed from one module to the other module. This is the worst form of coupling and should be avoided. Common coupling. This case describes coupling of two modules when both of them work with the same data shared across the application. For example, with some global variable. The modules have shared data such as global data structures, The changes in global data mean tracking back to all modules which access that data to evaluate the effect of the change. So it has got disadvantages like difficulty in reusing modules, reduced ability to control data accesses, and reduced maintainability. External coupling. When two modules use protocol and format for communication that is set by other module, that is called external coupling. In external coupling, the modules depend on other modules, external to the software being developed or to a particular type of hardware. Control coupling. This type of coupling refers to the case when one module manages other one. If the modules communicate by passing control information, then they are said to be control coupled. It can be bad if parameters indicate completely different behavior, and good if parameters allow factoring and reuse of functionality. For example, imagine sort function that takes comparison function as an argument. Data structured coupling. When modules use the same data structure but different parts of it, that is called data structured coupling. Data coupling. This is when two modules use the same data, let's say with the help of method parameters. If the dependency between the modules is based on the fact that they communicate by passing only data, then the modules are said to be data coupled. In data coupling, the components are independent to each other and communicating through data. Message coupling. When modules talk to each other using only parameters or messages, that is called message coupling. Now, let's answer the question, what is better, low or high coupling? I already gave you a hint that low coupling is usually considered as a good design, but why? In general, tight coupling is bad in most of the time because it reduces flexibility and reusability of code. It makes changes much more difficult, it impedes testability, etc. Loose coupling is a better choice because loosely coupled code will help you when your application needs to change or grow. If you have code design with loosely coupled architecture, only a few parts of the application should be affected when requirements change. On the slide, you can see visualization of two cases with summary. I believe we are clear on what coupling is. Now, let's discuss what cohesion is. Cohesion is a degree of interconnection between elements inside one single module. Cohesion is a measure of the degree to which the elements of the module are functionally related. In other words, cohesion is a measure of the degree to which the elements of the module are functionally related. It is the degree to which all elements directed towards performing a single task are contained in the component. Basically, cohesion is the internal glue that keeps the module together. A good software design will have high cohesion. Another definition of cohesion sounds like this. In object-oriented design, cohesion refers all about how a single class is designed. Cohesion is an object-oriented principle most closely associated with making sure that a class is designed with a single, well-focused purpose. The more focused a class is, the cohesiveness of that class is more. The advantage of high cohesion is that such classes are much easier to maintain and less frequently changed than classes with low cohesion. Another benefit of high cohesion is that classes with a well-focused purpose tend to be more reusable than other classes. But what I would like to mention, cohesion is not about single class. Just wanted to warn you that you can find something like taking cohesion only in scope of the single class. I would still focus your attention on the cohesion inside one module that consists of different classes that are intended to do common work. Let's now discuss different types of cohesion. The next types of cohesion. Functional cohesion. Every essential element for a single computation is contained in a component. A functional cohesion performs the task and functions. It is an ideal situation. Sequential cohesion. In this case, an element outputs some data that becomes the input for other element, that is, data flow between the parts. It occurs naturally in functional programming languages. Communicational cohesion. Two elements operate on the same input data or contribute towards the same output data. For example, update records in the database and send it to the printer. Procedural cohesion. Elements of procedural cohesion ensure the order of execution. Actions are still weakly connected and unlikely to be reusable. Temporal cohesion. The elements are related by their timing involved. A module connected with temporal cohesion when all the tasks must be executed in the same time span. This cohesion contains the code for initializing all the parts of the system. Lots of different activities occur, all at initialization time. Logical cohesion. The elements are logically related and not functionally. For example, imagine a component that reads input from a tape, disk, and network. All the code for these functions in the same component. Operations are related, but the functions are significantly different. Coincidental cohesion. In this case, the elements are not related. The elements have no conceptual relationship other than location in source code. It is accidental and the worst form of cohesion. For example, printing next line and reverse the characters of a string in a single component. So what is the difference between high and low cohesion? While talking about differences between high cohesion and low cohesion, it is worth to mention the next things. High cohesion is when you have a class that does a well-defined job. Low cohesion is when a class does a lot of jobs that don't have much in common. And if talk about cohesion on the level of components, modules, or packages, high cohesion means that in one module you have classes that are related with one single responsibility and designed to solve one specific goal. These classes are also ready to be released together. And low cohesion refers to cases when you put random classes that have nothing in common in one module without any reasoning behind that. High cohesion gives us better maintaining facility, and low cohesion results in monolithic classes that are difficult to maintain and understand. I believe that is it regarding cohesion. Now, when you know what coupling and cohesion is, let's remember the rule of a good design. Code should have low coupling and high cohesion. Now these words make sense to you. And if you would look on all patterns that exist, on all advices that you read in books or internet, all of them are directed on achieving low coupling and high cohesion. And there are different ways and patterns to achieve that. That's what we are going to learn in this course. Let's think now, why else do we need clean architecture? The clean architecture allows us to write code that is independent of frameworks, UI, databases for example. This is the main idea of the clean architecture. We still will use all of this stuff, but the main goal is that our core application logic won't be tied to the specific web framework or the database implementation and could be easily changed anytime without impact on the core application. That is achieved because of the low coupling, as you can already understand. Usually, when we open a project folder and look at its top-level structure, first we see the framework. You can see these folders like controllers, helpers, models, view, etc. Imagine that you have just joined the project. Will this view and this information give you a lot of knowledge what this application is about and what it actually does? I don't think so. Why? Because in this case, approach is way too generic. Almost all projects have models, controllers, and views if we are talking about MVC, Model View Controller pattern. What I would suggest instead? It would be better if when we open the top layer structure of the project, it would scream about what application does. Because architecture is not about tools and frameworks, instead it is about intent. The main concept of clean architecture is that everything that is not a business logic is a plugin and could be easily changed, replaced without any impact on other parts of the system. Let me explain you plugin concept. The business logic describes system functionality, no matter where it will be used, either in web app or a mobile app. We don't know anything about platforms on this stage, frameworks, etc. Business logic is the main part of the system, and it means that it is the least part to be changed. Frameworks, user interface, databases are just plugins. Frameworks, user interface, databases are just plugins, so they could be easily changed anytime, and it won't affect other parts of the application. As we mentioned before, business logic is main part of the system, so it is independent of any other its components. Plugins are dependent on business logic. It means if anything is changed in the business layer, plugins could be changed too. Let's imagine that our application uses some external framework for object relational mapping of data in my relational database in my application. There are different tools for that, but probably one of the most popular ORM in Java is Hibernate. And imagine that one day new ORM system become better or introduce new features that are needed to be supported in your application, and you need to change it. Or imagine that you just need to switch from relational to NoSQL database, and this will require new ORM system. How much code it will take to substitute one ORM with another? In case you have clean architecture in your app with low coupling, it wouldn't take too much efforts to make proper changes without any impact on the rest of application. Let's imagine that we are working on the social network, like Instagram. So when you start development, you could ask yourself, what does this application do? And after thinking a bit, we come up with a list of behaviors that our application should support. Log in, search by a hashtag, show wall, like a post, comment on a post, send a message. And it doesn't matter either we are developing a web app or a mobile app, because we didn't tell anything about specific platform yet. It is just a functionality. Don't focus on the framework you are developing on. It would be better to think about what the application does. We can call each of these items as application use case. So, let's dive deeper into one of them. Let's say we want to send a one-to-one message. First of all, it takes some input data, sender, recipient, message content, date, time. Note that we do not specify types of the fields. Then we describe what does the use case do. The app validates message, then it sends it to the recipient. Finally, it notifies sender that message was sent. If there is some exception during this workflow, sender will see an error message. We need to create entities to support these use cases. What entities are? Entities encapsulate business rules. An entity can be an object with methods. Your entities may be treated as the business objects of the application. They encapsulate the most general and high-level rules. They are the least likely to change when something external changes. For example, you wouldn't expect these objects to be affected by a change to page navigation or security. No operational change to any particular application should affect the entity layer. Let's go back to our social network. We agreed that our application has different use cases. These use cases will use different entities of our application. And it is fine in case one use case will use different entities. And also, it works in different direction. Multiple use cases could use the same entity. It is not restricted. Send a message use case works with message entity and users entities. And as you can see, other use cases sometimes use the same entities. In this case, use cases may be treated as separate classes that have, for example, execute method that performs use case flow and meeting the business goals. But how could we get access to the UI, database, etc.? We should use boundaries. They are represented by interfaces that could be implemented by components of outer layers. We do not specify the delivery mechanism here, but it could be everything, any web protocol or even console. The delivery mechanism is just a plugin that could be removed or replaced with something other. Delivery mechanism may consist of set of interfaces. This is a vivid example of dependency inversion principle in practice. The main idea is to use dependency inversion principle in communication between layers. This means that components of the system do not depend on others directly but through boundaries. Similarly, we can work with the database. We don't access database directly from the business logic, but we use entity gateway for that. This is just an interface that sets contract of interaction between our app and database. It could be implemented and used by any database handling class. Entity Gateway Implementation is a class that implements Entity Gateway, and it can be considered as a part of database plugin that can be easily substituted when it will be needed. In this case, this class is in charge of direct access of database API. Entity Gateway could be represented by data access objects, so-called DAO classes, or with any other pattern. The idea is simple. You can have such entity gateway for each entity separately. This is how exactly you can keep some modules independent to ensure maintainability and scalability of your code. So now, let's recap what benefits you get from clean architecture and what disadvantages you have to accept. Let's start from benefits. Following principles that we learned in this lesson and that we are going to learn further, your code becomes testable. The code of your app is decoupled, so every part could be tested in isolation from other components. You should just mock missing dependencies. Your code is maintainable. Functionality of the app is strictly separated, so if you wanna add new features, they would be implemented in separate files without impact on existing code. Your app is independent of any framework, UI, database, etc. The core part of your app is just pure code. All other modules are just plugins that could be easily changed. But as always, everything in programming comes with a price. And it's always a matter of trade-offs and balance between advantages and disadvantages while following any of suggested approaches. So disadvantages that we need to accept are: sometimes you need to accept that you should write more code than usual. All of this separation of concerns requires to write a lot of different interfaces. However, nowadays IDE can do a lot of job for us in terms of code writing and classes generation when needed. While such structuring simplifies code understanding, sometimes if you are not used to such approach, it will take your time to understand how different modules interact between each other. So one of the disadvantages is the fact that understanding and implementation of clean architecture requires practice and experience. But to be honest, this is not a true disadvantage. That's all for this lesson. Let's recap what we have learned today. In this lesson we learned what coupling is and what cohesion is. Also, we have discussed different types of coupling and cohesion. Now you know what a clean architecture is. I showed you an example plugin concept and how to implement it on the example of social network. And at the end of the lesson, we discussed advantages and disadvantages of clean architecture. Hope you enjoyed this lesson. Thanks a lot for your attention. See you in the next lesson. Hello dear students, in this lesson we'll learn tell, don't ask principle and data structures. We'll start our lesson from understanding of what tell, don't ask principle is. I will show you what this principle is about and how you may apply it on practice. And knowing this principle, it will be important to understand the difference between data structures and objects. That is exactly the reason why I decided to combine these two topics in one lesson. We'll talk through the differences between objects and data structures. We'll start with examples on how exactly objects are different from data structures and how objects and data structures are opposite in the way they deal with data. We'll continue with highlighting in which case we need to use data structures over objects and vice versa. And at the end of the lesson, I'll share with you advices and best practices for getters and setters usage in classes. And as I already mentioned, we'll start from the principle that is called tell, don't ask. Let's analyze a specific example to understand this principle, because it is always easy to understand new things on the examples. Here a class called userAccount. The class has its private attributes and proper getter and setter methods. This class aims to represent a user's bank account and its operations and attributes. Let's focus on the current design of this class. It only maintains attributes and basic getters and setters for them. What you have to do in case you want to increase balance of this user account, you have to get balance field and perform any operations you need, including adding value to it. But do you think that is okay? I mean, forcing your client to interact directly with your fields of your object? The principle tell don't ask tells us that in case user needs to change state of the balance object, we don't have to request this field first. What we have to do then? Instead, we have to tell our object directly what we want to do. In other words, we need to tell user account to increase balance. That's why principle is called tell don't ask. Does it make more sense now? In this case, we have to tell user account object to increase balance. So, all the operations related with this class force it to tell its content to another class, which will in turn manipulate the values of user account. Let's consider another case with this class. Imagine that we need not to add, but withdraw money. What we have to do in this case? In this example, a withdraw operation requires any third class, any class that is going to use our API, to ask the current value of balance attribute in our class user account. It is not a good design. Why? Because we need to inform to another class details about user account's attributes and then let another class update state of user account. This is not what encapsulation principle is about. And by doing this, we allow any external client to update the state of our class without our control of this process. And imagine that across all your program, you perform manipulations like this. In case you need to make update and withdrawal operation, let's say you need to perform some daily limit verification. You need to update this in all places. You don't have one single place to control this process. Even a simple change on withdraw operation behavior across all your app would require an extra effort on refactoring different classes that use this object. Or imagine another case now. Let's suppose that the bank starts to charge 1% on every withdrawal higher than $1,000. All the classes that manipulate withdraw operation should be changed in order to execute this operation. This design is completely against object-oriented approach. I believe that you already understood how to fix this, do you? It would be better if inside our class we would declare behavior that would help our client to perform operation that is needed. That is the sense of object-oriented programming approach, to combine behavior and state in the object and introduce methods that can modify the state of the object. We don't need to have pure data structures that just contain state and modify it outside of the class. In this case, I would add method that is called withdraw, and all logic, behavior, processes will be triggered from this point. And when I use this method in all other classes across my app, I don't need to be bothered to update each class in case logic of withdrawing is changed. Here's one single point where I manage withdraw. And I don't need to ask object about its state. I just tell object what I need to do. That is the key thing in principle tell don't ask. It should be responsibility of user account class and not of another class. In other words, clients of the user account class should tell what operations it should perform and don't ask for its internal state. This approach assures that internal state of user account is managed by itself and we have a clear object-oriented design. One more side effect we have on this design is an anomaly called anemic domain model. It can be defined as an entity that is open to provide its state to every type that calls it instead of performing the operation on itself. This definition created by Martin Fowler describes classes that doesn't contain behavior, making them look like bags for getters and setters. Alex Sharp wrote in his book about Smalltalk the following sentence. Procedural code gets information, then makes decisions. Object-oriented code tells objects to do things. It clearly explains the tell don't ask principle in a broader way, stating that a developer should never forget that object orientation is about message transfer between objects to tell what operations should be done, never about getting information from an object in order to execute some task. The tell don't ask principle tells one simple thing. We have to delegate an action to an object directly instead of asking some data from this object. In essence, that's it. But if it's so obvious, why not everyone follows it? Probably that is because in most of the times it's easy to request some data from a class and only after that call method that is necessary to call. But come on guys, don't do like this. If some data is encapsulated in this class, this exact class should be responsible for managing all the behavior of encapsulated data, instead of requesting data and let other class processes it. In case you would follow this simple advice, your code become much more straightforward and cleaner. Moreover, for clients of your code, it would be much easier to understand what behavior this class have and how to apply this API within the program, rather than constantly remember that in some specific cases we have to call getter method and only after that do what we need. Does it make sense? The correct usage of this principle helps the program to achieve better modularity and to have a clear separation of concerns, amongst other benefits from a good object-oriented design that we are going to discuss in this lesson. And to understand better what benefits we get from using tell-don't-ask principle, let's ask first about what we'll get in case we won't follow this principle. In other words, let's talk about issues that might happen in case we'll ignore this rule. Is data exposing from objects for other classes safe? No. Exposing data from objects for other classes to alter it is a very dangerous practice, because this one class becomes tightly coupled to another class that may not be directly related to the first one. This practice violates also another principle called single responsibility principle. I believe you are familiar with solid principles and know what S principle is about. But just in case, I will quickly recap. The single responsibility principle is a term created by Robert Martin to express the cohesion of a class. He states that a class should have only one reason to change. What other drawbacks and issues may appear in case we will not follow tell-don't-ask principle? Data exposure that we have already talked about normally also brings maintenance complexity when some change should be performed in the internals of the class, forcing you to investigate all the parts that may alter it in order to change it too. Now let's talk about another important topic. In my opinion, knowing of tell-don't-ask principle is related with the things that I'm going to explain you now. We'll learn more about the difference between objects and data structures. If we'll look at an object outside, we'll see it has functions but has no variables. An instance of a class, an object, has no observable state from outside. This is why it can be stated about objects that objects hide their data behind abstractions and expose functions that operate on that data. In object-oriented programming, we even use special term for that. Behavior that modifies state of an object, usually called methods, but not functions. To understand things better, let's look at example. We'll start from object example and after that we'll talk about data structures. Imagine that you have some interface, vehicle. All the classes that implement the interface are supposed to have drive method. For example, there is an electric car and petrol car. The processes inside the car that makes it move are completely different in electric and petrol car. If I add a new class to this hierarchy, let's say now we have motorcycle that implements vehicle interface. And pay attention that after this action, neither of classes were changed. No matter what state motorcycle has, for example all cars have 4 wheels, but motorcycle has only 2 wheels. So, as you can understand, it is not a big difference in case some new class will implement the interface and declare its own state. But what would happen in case the interface is changed? For example, now we have not only drive method, but also we have start engine method. Now, every existing class that implements vehicle interface has to be changed. That is something what we need to take into account when we talk about objects and object-oriented programming. Now, let's talk about data structures. Data structures are completely different things from objects. And you remember the previous example about objects and behavior? Data structure, on the opposite, has variables, but no functions. In other words, data structures describe the state rather than behavior. It can expose variables through public fields. In case you see getters and setters in object, it is not necessarily the proof of the object behavior. It is just the way of accessing and setting the state in the data structure. So, it could be that data structure has private fields with getters and setters. Let's imagine that we have similar example about vehicles. We have electric car and petrol car. How a solution would look like with the data structures. In this case, drive behavior wouldn't be a part of our concrete classes. In this case, this behavior will be handled by different type. For example, if we still want to stick to object-oriented approach, we have to create another class that would manage all movements for all types of vehicles. I can create vehicle service that has move vehicle method and that takes any vehicle as an argument. And inside this method, I will create a logic of vehicle movement relying on the level of abstraction that is set by vehicle interface. Is it looks good? Well, it is. Your program will work and that is amazing. But the power of object-oriented programming exists not for the things like this. We don't leverage the power of polymorphism if we would produce code like this. It is much more easier to override drive method for each type of vehicle rather than be bothered about making generic method for all possible types of vehicles in our service. That's why I would say that while using data structures like this is also possible, and sometimes architecture with data structures might be easier, that is not always the best case in terms of following object-oriented design. And I know that there are frameworks and patterns in different programming languages that actively use data structures. So that is completely fine. I just wanna say that probably having a lot of data structures and layer of different services that modify state of such data structures, probably that is not completely object-oriented approach. By following this style in our architecture, we won't be able to leverage all the power of object-oriented programming. That is all what I'm trying to say. In this case, our concrete classes will stay unaffected in case I need to add additional behavior. In previous example, you saw that when I add additional behavior on the interface level, I need to implement this method in all concrete classes. But in this case, I can easily declare new behavior in my service and my concrete classes will stay untouched. But in this case, when I add new concrete class, let's say motorcycle, I need to adjust methods in my service to make sure that my service will handle and process a new data structure. Now, when you saw different examples, we are in a position to make at least some conclusions. I believe that you can understand that these concepts are opposite in the way how data is handled. This is what is referred to as data-object antisymmetry, and it might seem trivial, but is actually a very important thing. Note that this also shows that an idea that everything is an object is simply not true. Sometimes you don't want everything to be an object, but a simple set data structure with some procedures operating on them is needed. Hope that this makes sense and the difference between data structures and objects is clearer now. I wanna warn you that using hybrid structures might not be a good idea. You might wanna get the benefits of both approaches by mixing them together. I mean objects and data structures. You can try, but believe me, that will end up with a nightmare. For example, the code won't be easy to support and to use, because sometimes you would ask clients of your code to use special services, sometimes object methods, and data manipulation won't be transparent and intuitive for understanding. You will get not clean and hardly readable code. But an important question that we need to answer is what to choose, data structures or objects. We learned that classes hide their data behind abstractions and expose functions that operate on that data. This makes it very easy to add new kinds of objects without changing existing functions. It also makes it difficult to add new functions to existing objects. Generally, when we use classes and objects, we rely a lot on polymorphism. This is what object-oriented programming refers to. On the contrary, data structures expose their data and have no meaningful functions. This makes it easy to add new functions to existing data structures, but at the same time, difficult to add new data structures to existing functions. And this is also a reason why it is better to use data structures when the data they represent is not likely to change. Data structures are often used with methods and switch statements, which is referred to as procedural programming. So, the things that are difficult to do when using object-oriented programming are easy for procedures and vice versa. And it depends on our requirements what approach will work the best for us. That's why there is no single answer what is better. Sometimes we would benefit the flexibility to add new data types, so objects and object-oriented approach is a good choice for this situation. And sometimes the flexibility to add new behaviors would be preferable, and in this case we prefer data types and procedural approach. If you already had an opportunity to create web applications or integrate your application with other systems, you faced with the case that is very convenient to have and use data structures. For example, there is a pattern to use so-called data transfer objects that stores only state and used to reflect the data from the database table. In that case, we can keep the data structures close to application boundaries. The important advice is not mix those together. With hybrids, it's difficult to add both new types or new methods, so using them is a bad design. We are getting to more interesting things. Now in principle, tell don't ask, what do you think? Having getters and setters is a good idea in general? And please don't take me wrong, I am not telling that we don't need to have getters and setters in our class, because a lot of Java frameworks will rely on the fact that they are getters and setters. I am just trying to say that building your logic around using getters and setters is an indicator of bad code design. Why? Per tell don't ask principle, we shouldn't be asking an object for data and action on it. Also, as you remember from single responsibility principle topic, a class should be highly cohesive. That means each method manipulates on a cohesive group of variables, whereas getters and setters manipulate individual variables, so that hinders implementation of single responsibility principle. Overall, be careful with getters and setters. If you just want to expose some data in your class, do not expose implementation details, because it hurts polymorphism opportunities, and also because using getters and setters makes your class looks like a hybrid structure. Instead, expose data in the most abstract form possible. Only the essential details should be displayed to clients of your code. There are different thoughts around using data structures and objects, and I am sure you already have your own opinion. I just share my vision and give you advice that helps me and my developers to come up with better code design. I just quickly recap key points that we learned about data structures and objects, so summary will look like this. Expressing the data in abstract way is preferred to exposing the details of our data. So, usage of getters and setters for objects would be often considered as a bad design. Code using data structures makes it easy to add new functions without changing the existing data structures, but makes adding new data structures complicated. Object-oriented code, on the other hand, makes it easy to add new classes, but hard to add new functions without changing existing classes. Those are opposites. You have to select approach based on the current system's requirements. After you choose an approach, stick to it, don't use hybrids. That's it. Now let's recap what we have learned today. We learned tell don't ask principle. You saw real-life examples of applying this principle. Also, we learned what data structures are. After this lesson, you can understand the difference between objects and data structures, and you know specifics of using getters and setters in classes. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello team, in this lesson we'll talk about law of Demeter. We'll discuss what is law of Demeter, what are goals of this law, exceptions from it, what are pros and cons of following it, and recommendations to follow. By the end of this lesson you will understand how you can apply law of Demeter on practice during programming of your applications. And the first thing we have to do is to learn theory and understand the definition of law of Demeter. And in general, what is law of Demeter about? Law of Demeter is also known as principle of least knowledge and is a set of rules in object-oriented programming which puts some restrictions on interactions between program modules. These restrictions help to achieve loose coupling to simplify modifications and complexity of a program. According to the law of Demeter, each unit should have limited knowledge about other units. Units should be aware only about other modules which are directly relevant, should interact only with modules which are known, and do not interact with strangers. In other words, law of Demeter for functions requires that a method M of an object O may only call the methods of the following kinds of objects: O itself, M's parameters, any objects created or instantiated within M, O's direct component objects, a global variable accessible by O in the scope of M. Does it make sense? To simplify this, each class shouldn't be able to provide client with details of all possible fields of a class. If a client wants this object does something, we just tell object what to do without exposing any additional details, and also without calling methods of non-related objects from the method that we have just called. We, as software engineers, can easily identify violation of law of Demeter in case we see long chain of method invocations. Law of Demeter pursues these goals. Hide information. We don't want that client of our code knows everything about all other types which we aggregate. Control access to another object. Moreover, we don't want to grant right to change state of aggregated objects, and always bear in mind one of the key OOP principles, encapsulation. To minimize coupling within an application. To foster clean code design and make our code more reusable and easy to change, we want to achieve low coupling between our units and modules. Let's take a look at few examples here. The first one. Car, get engine, start. You have a car. You get engine from a car to start engine. If you have reference to a car object and you need to start engine, probably you have to just start engine in the car. And yes, this is so easy. We can even say that law of Demeter is a formal representation of tell don't ask principle. Or another example. You have a car, and at some point of program we think that we can utilize car to get access to the user to pay fine for road rules violation. And you have something like this. Car, get owner, get wallet, pay fine. And an issue not in the chain call itself. Even if we would extract local variables and we'll have something like this, user owner, car get owner, wallet get wallet, wallet pay fine. The issue still exists. It is not very object-oriented approach to use car object to pay fine. It is better to have reference to user object in the method where pay fine supposed to be called. Violation of law of Demeter is a good sign that code must be decomposed and that object-oriented approach is not followed. Law of Demeter, the same as all other laws, has some exceptions. The law is not applicable for data structures. Let's consider the next example. User, get car, get manufacturer. There is no violation of law of Demeter here. We can't apply this law to pure data structures. When we reference to pure data structures, we mean objects that have no behavior, just data. Thus, such law of object-oriented programming as law of Demeter is not applicable to data structures. Another chain calls might be considered as exceptions. Builder creational pattern with chain methods invocations. Car, set doors, set roof type, set engine type, build. Does this method chain violate law of Demeter? No, it is not. It is even not pure exception from law of Demeter, because method chain doesn't violate it at all. During the object construction, each setter returns the reference to the same object. This is not violation of law of Demeter. It is also worth to mention that blind following of law of Demeter will not allow you to implement other patterns. For example, factory method pattern. Product factory, get product, list variants. From one side, the code on the slide can seem like a violation of law of Demeter, but actually it is not. Why? Because the sense of creational patterns to create new objects, but the way how they create objects looks like methods invocation chain with involvement of different types, such as product factory and product. So, in this particular case, the law of Demeter is not violated. The similar situations in your code can happen while implementation of other patterns, but we need to understand the essence of the law of Demeter. It is not about eliminating of methods invocation chain. It is about restricting amount of interactions between non-related units to implement low coupling. Does it make sense? Try to take a look at your code through the essence of the law, but not actual code presentation. To summarize what we have discussed, let's come up with list of pros and cons of applying law of Demeter. Let's start from pros first. Low coupling. We achieved this because units interact only with limited number of other units, the closest ones. Encapsulation. Law of Demeter allows us to use exactly what we need, instead of getting objects out of another and get more information about code structure than we need, and instead of having more opportunities to modify state of other objects than we want. Data localization. By adhering this law, we limit possible options of interaction. Code becomes easy to understand and to navigate in. Class responsibility becomes clearer. The class which takes multiple responsibilities have either long method calls or huge dependency list. In real life, applying of law of Demeter brings us to refactoring of existing units and creation of another units, smaller ones, with clear responsibility. Units become more testable. Low coupling allows us to write unit tests without thinking of stubbing of all necessary dependencies to test units' functionality. And now let's talk about cons. Many new wrapper methods. We need to have more methods to pass information between different objects. It can sound like a valid point, but from another point of view, it can sound like we are not following other design and OP principles. By the time when creation of a lot of wrapper methods will look like a disadvantage, we will understand that probably our object has a lot of duties related with different pieces of application. So this disadvantage should not bother you in case all other object-oriented principles are followed. That's all what I wanted to share with you regarding law of Demeter. Let's recap what we have learned today. In this lesson we learned what law of Demeter is. Also, I explained what the goals of law of Demeter are. We reviewed exceptions from this law. And at the end of the lesson we reviewed pros and cons of law of Demeter. That's all for this lesson. Thanks a lot for your attention, and see you in the next lesson. Hello friends, in this lesson we'll learn different approaches to group your code into multiple packages to keep your architecture clean. In this lesson we'll cover core principles regarding module structuring and code organization. These principles will help you to keep your architecture clean. Also, following these principles you will make your code easy to scale, maintain, and reuse. I'll explain why do we need a good structure and how to create it. We will talk about factors that is worth to consider when we talk about packaging. This topic takes time that probably is more than for one lesson. That's why we'll start learning grouping principles in this lesson and we'll proceed further in the course. In the lesson we'll talk about cohesion principles. Namely, we'll discuss common closure, common reuse, and reuse-release equivalence principles. Let's start. As I already said, in the lesson we'll discuss a group of different principles. Some of them we'll learn in this lesson, and some of them we'll learn in other lessons from this section. But before we start investigating each particular principle, let's define the problem first. While working on a class, there are many design decisions that you're applying. The classes you produce contain what you expect them to contain. You can investigate each class and easily understand what this class was designed for and what it is intended to do. And gradually, as you develop your application, you start group classes. You may want to group them based on different reasons. Some of them are: classes are part of one feature and serve the same idea, or classes do something specific in similar way and it is logically to keep them together, or they are intended to work with the same third-party code. In different programming languages, you are grouping classes in packages, namespaces, components, etc. So let's agree that today we would use such common terms as module or component. That would mean some folder in a file directory which is created to avoid name conflicts and to write a better maintainable code. Hope this will make a terminology the same for different programming languages. And the same way as you are conscious about the way you design your classes, you immediately start asking yourself some questions about the design of the modules you create. Where it is better to put this class, in which module? May I put it in existing module, or it is better to create a new one? Should I split this component, or it is not big enough yet? It is okay if my module will depend on classes from another module? Good module structure and components design will come from answers on such questions as: does my new class belong to this specific module or no? Is it safe to create dependency on this component or no? What is needed to be done to increase the usability of a module? What can I do to create structure which is easy to maintain? Why do you need to worry about good structure and code organization? Good code organization can give you the next benefits. Readability. We never should forget that during software implementation, people create software for people's needs. Not only computers read our code, other people also reading our code. You can save a lot of time for a colleague of yours and money for your company in case code will be understandable. Each engineer should feel where to expect what. Ask yourself, how much time does it take to understand new project or even class which you have never seen before? In some cases, this can take up to 50% of total time reserved for the development. Making code readable, it is one of the key factors of team performance and quality for large software projects with many developers, and everywhere where the source code that was written by one person is going to be modified by another person. Modularity. Modularity is not only about code organization, it is also about actual dependencies between your modules. Code in an application might be separated into modules and can even look like modular, when in fact it is not. Even despite multiple modules, packages, namespaces are created, units in your code may still have complex interdependencies with other parts of your application and can still expose its private details. Today we will learn core principles which will help you to stick to modular approach. Reusability. When software is reusable, it turns into increased productivity and quality along with minimization of risk occurred during implementation of a new project or feature within the same project. Software reusability doesn't depend only on classes you implemented. This property of your software includes all units and entities of your software, including modules. Reusability in software development encourages innovation in traditional development methods. And what is also worth to mention that software reusability decreases project costs proportionally to the amount of code which is reused. How to establish good code structure? What are key points that we should always remember? While establishing a good structure on your project, remember that this activity can bring benefit when it is experience-based first of all. Usually, different business domains like banking, insurance, healthcare, e-commerce are limited with constraints of business use cases. For example, it is highly unlikely that in banking software you would need to implement facet search feature, which is usually used in e-commerce domain. Thus, in some degree based on your experience, you can imagine how end system will look like. This will help you to establish better code structure from the very beginning. Today we will discuss patterns and recommendations to follow, but they mean nothing if you are blindly following them. Each project is a unique endeavor. The result of each project is unique. And code of each project is unique too. Don't be afraid to experiment with things before applying some conventions. Be sure that they are applicable directly to your project. You should not forget that if refactoring or project restructuring doesn't simplify things and make code even harder to understand, the initial goal is not achieved. Ask yourself, can a newcomer quickly grasp this project? All attempts to structure your code according to best practices and patterns should end up with clearer design which is easy to understand. Be consistent while applying rules and patterns. For example, use the same naming everywhere across your project. And remember, the sooner you start thinking about code structure, the less refactoring is needed later. There is no silver bullet for clean design and good structure. As we already discussed, each project is unique. Always there are different factors which impact your deliverables and which are worth to consider while project implementation. To name a few: module cohesion and coupling. Hope you already know what it is. In case these terms are not familiar to you, make sure you watched my lesson about coupling and cohesion. Cohesion and coupling deal with the quality of an object-oriented design. One of the key principles that we all know is that to create maintainable code, we need to follow simple rule: low coupling and high cohesion. When we are talking about low coupling, we want to put stress on separation of unrelated parts of the code as much as we can. And when we refer to high cohesion, we mean keeping related code in single place. What is the main goal of the rule? The aim of design with low coupling and high cohesion is to simplify development process, to simplify code-based maintenance, to simplify addition of new features, make code less fragile. While rule is straightforward in theory, it is not always easy to follow it in real life. Today we'll review principles with you which will help you to adhere this rule. The second factor is probable code-based growth. Since software considered to be deprecated by the time it will be released, we constantly evolve our vision of the product during its implementation. You have to consider potential change factors which might pop up and be prepared for code-based growth as new feature will be added to your project. The next factor is team organization and communication between team members. It is a very important factor for your project structure. Later in this course, we'll discuss Conway's law and we'll analyze how team composition might influence project code structure. Technical factors can also impact your code structure in some way. Also, during the course, I will show you examples to demonstrate how technical limitations might impact our project structure. And at the end of the day, our goal is to make navigation in your project easier and predictable. There is no intention to make your code structure harder to navigate in after applying patterns, which we'll discuss in this course. Let's start from cohesion principles of code organization. But before we start, let's recap definition of cohesion and understand what is modules cohesion. Cohesion refers to the degree to which the elements of a specific component belong together. It is about items which can exist and do one thing well together. So cohesion is about the way how we can group our code that contributes to a single task together. Also, cohesion indicates the degree to which a module has a single, well-focused purpose. There are many benefits which we expect to get from high cohesion. Some of them: maintenance of highly cohesive units is much easier. Highly cohesive items are less frequently changed. Reusability of such modules is higher because they are designed to serve a well-focused purpose. I want you to understand module cohesion as a concept which will help you to compose your components the way they become reusable and easily maintainable. There are three major module cohesion principles which we are going to review today. They are common closure principle, common reuse principle, and reuse-release equivalence. While choosing the classes which should be grouped together, two opposing forces related to software usability and developability must be taken into consideration. It is not an easy task to balance these forces. Usually, this balance is dynamic. Hence, our module structure will evolve as focus of project shifts from developability to reusability. And we start from the common closure principle. This principle states that the classes in a module should be close together against the same kinds of changes. A change that affects a module affects all the classes in that module and no other modules. You can treat common closure principle the same as single responsibility principle, but just related to components. It is obvious that from the maintenance standpoint, changes which might impact other modules in your application is not avoidable, but they should be controlled or at least minimized. The main idea here is in case change has been made in one module, re-releasing or revalidating of other modules that are not dependent on the changed one is not needed. Similarly, the single responsibility principle for classes, common closure principle, states that the classes in the module should not have different reasons to change. If there is need to make a change, or to implement a new feature, it will be better to make changes in one module rather than making changes in multiple different modules. It is natural that the classes that are tightly related will change together. Thus, in case we keep classes that are tightly related together in one module, only one module or a very small number of them are going to be affected when a change happens. And also in this case, all activities targeted to revalidation and re-releasing will be decreased. On this slide you can see that, for example, changes in the interface of billing address type most likely will cause changes in invoice type. It is very low chances that changes in billing address type will cause changes in customer type. It is also worth to mention that this principle is closely associated with the open-close principle. You know that open-close principle states that classes should be closed for modification, but open for extension. But in real life, 100% closure is not attainable. Closure must be strategic. We design our code modules in such a way that they are close to the most common kinds of changes that we have experienced. If we review common closure principle from open-closed principle point of view, we can say that modules should be closed against the same kinds of changes. In specific, this means that in case we are going to change some code in our module, it is most likely that requested change will affect only one module. And contrary-wise, when a change is requested and this change affects one module, most likely that all classes inside that module will be affected. This principle allows us to limit the amount of modules that are affected by any changes to the smallest possible number. Imagine also the case that people, while implementing their features or projects, create a dependency on your module, and most likely that people want to track all new releases of your module to keep their code up to date. After you released new version of your module, clients of your code will update their project, but they will proceed with upgrade only in case they would know that changes you made to the module in the latest release impact the way how module is used in their project, because every such upgrade requires them to perform validation that existing codebase still works as expected with the new version of your module. Being a module maintainer, you should follow the common closure principle to prevent yourself from opening a module for all kinds of unrelated reasons. The next principle which we are going to review is common reuse principle. This principle states that classes in a module are reused together. If you reuse one of the classes in a module, you reuse them all. You need to be aware that there are always two edges that you need to avoid while grouping classes into modules. The first edge is that you can implement a lot of amazing classes, features. These classes might be very useful and super helpful, but if you will release all of these classes as one module, this would mean that clients of your code should put a dependency on the entire module and will be forced to be dependent on classes they don't use. So even if clients of your code use only a few classes from your module, which is a very small part of it, they still need to pull entire module into their project. This is quite a maintenance burden for them. On the other hand, you can't put each single class in a separate module. First of all, this has no any sense, and at the end of the day, you would need to release tons of modules. This increases your own maintenance burden. In this case, your clients now bothered with other issue. They have huge list of dependencies and they need to keep track of changes and new releases of all these modules. This principle tells us which classes should be grouped together. As it states, the classes that tend to be reused together should be in the same module. It is more likely for reusable classes to depend on each other, so classes are rarely reused in separation. The principle states that the classes of a module should be inseparable, which means that if module depends on another one, it should depend on all of its classes, and not on a number of them. In short, classes that are not tightly coupled to each other should not be kept in the same module. It is also needs to be mentioned that common reuse principle puts stress not only on classes which we need to put together in the module, but it also tells us what classes not to put in the module. When in one module you are using class from another one, this doesn't weaken the dependency between modules at all. Modules are still dependent on each other. and now every time used module is released, the using modules must be revalidated and re-released. Usually, modules have physical representations as shared libraries like DLLs or jars. If the used module is released as a jar, then the using code depends on the entire jar. Any modification to that jar, even to one class, will still cause a new version of the jar to be released. This principle might look pretty straightforward and obvious at the first glance. Just put classes that are going to be used together in one module. It is even hard to put completely unrelated classes that are never used together. But things become less obvious when we consider the fact we should not put classes in one module that are not used together. We also need to think about classes that are likely not to be used together in the future. In the example on the slide, you can see that we are sure that we don't want to put string-utils item in one module next to billing address and invoice items. Why? Because we are not sure that every time we will reuse billing address and invoice in other places of our software, we would need string-utils. We are also not sure that string-utils and invoice and billing address always used together. And we don't want to force clients of our component to depend on all changes in string-utils class. That's why it is better to keep string-utils outside of the module, because each update of external library will require regression testing of the whole system. One more important principle related to module cohesion is reuse-release equivalence principle. This principle states that the granule of reuse is the granule of release. This principle also brings us to conclusion that if your units are going to be released together, they should be in the one module. That's why the size of the code that is intended to be reused is the same as size of the release module. This principle is different from common reuse principle. But you might be wondering, what is the difference? The main difference is that the stress in common reuse principle is put on reusing units from the same module together, whereas in reuse-release equivalence principle, the stress is put on reusing of the whole module. When your project becomes more mature and it is time to release your code, you start thinking about what modules should be released first. And the answer to this question impacts the way how you approach your code organization. You need to understand that the code which will be released together will be reused together. The code which will be released together will be maintained together. As your project will grow, the weight of this principle will become more. Because at the end of the day, you are not able to follow all cohesion principles 100%. It is always a matter of the trade-offs and balance between all cohesion principles. And you will understand that sometimes it makes sense to put units together in one module if they are going to be released together and not necessarily will be used in conjunction. The good example of this principle is Java util package in JDK. It contains a lot of units which are often unrelated, such as collections interfaces, classes to work with date, classes to work with application locale, with random number generation, but the goal was to release module which will be commonly reused across different Java applications. We learned a lot in this lesson and we still have a lot of things to learn regarding code grouping and packaging. Namely, we still need to learn coupling principles during the code grouping. But I suggest to cover this in the separate lesson, taking into account we have already learned a lot. Let's recap what we have learned today. After this lesson you understand why we need good structure and why question how to group classes in one module is important. We reviewed factors that will impact good structure. And we reviewed 3 cohesion principles. They are common closure principle, common reuse principle, and reuse-release equivalence principle. I want to put stress on the fact that today we have a very important lesson, and I hope you loved it. We'll proceed learning module structure further in the course. Thanks a lot for your attention. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Hello team, in this lesson we'll proceed learning packaging principles. Namely, we will talk about coupling packaging principles. I will explain you with examples next coupling principles: acyclic dependencies principle, stable dependencies, and stable abstractions principle. Also in this lesson we will talk about other approaches during code structuring that is good to know and apply in practice. I will explain you package by layer and package by feature. After that we will discuss how team structure may impact your code structure, and I will explain you Conway's law. We will review technical factors that may impact code structure. And at the end of the lesson we will talk about tools for code analysis that may help to keep your code clean. So let's try to understand context and background for coupling packaging principles. Understanding these roots will help us to understand the logic that stands behind each of these principles. Our applications usually tend to be large networks of interrelated modules. That's why it is very important to find some patterns and create rules that will govern this interrelationship in object-oriented architecture. The next three principles which we are going to discuss today focus on the interrelationships between modules. We already learned what coupling is in another lesson. In case you missed that lesson, take your time to watch it. But nevertheless, before we start to discuss these principles, let's recap first what coupling is. Coupling is the degree of interdependence between software modules, a measure of how closely connected two modules are, the strengths of the relationships between modules. Coupling considered to be the principle of separation of concerns. What does it mean? This means that one module shouldn't directly affect or modify the state or behavior of another module. Coupling pays attention to the relationship between modules and how closely connected they are. To make you understand coupling better, let's consider the next example: HTML and CSS. Before CSS appeared, HTML was used for both markup and presentation. This ended up with creation of huge files and bloated code that was difficult to maintain and extremely hard to change. With the advent of CSS, two concerns, markup and presentation, have been separated. After that, HTML became in charge of only markup and CSS became used for presentation. This separation made the code cleaner and easier to change. Why loose coupling considered to be good? Because loose coupling lets the code to be more changeable, easier to work with, and more flexible. Modules that rely on another ones and can modify the states of other modules are said to be tightly coupled. Why it might cause the issues? Because high coupling can cause so-called ripple effect, when modification of code from one module also requires code changes to be done in another one. Reusability of code which is tightly coupled is also significantly decreased, because code is harder to separate from each other. So the rule of thumb sounds like this: strive for low coupling and high cohesion. This rule is a reminder for us that we should strive for code that separates tasks and doesn't rely heavily on each other. That is why low coupling generally considered to be a good thing, while high coupling is generally bad. The next principle will help us to achieve architecture with low coupling. As it was stated in agenda, we will focus on three principles: acyclic dependencies principle, stable dependencies principle, and stable abstractions principle. Let's discuss each of these principles one by one. The first coupling principle, which we are going to review today, is acyclic dependencies principle. This principle says, allow no cycles in the component dependency graph. The acyclic dependencies principle is the first of three principles that deals with the relationships between components. How to check that you have cyclic dependency in your app? If you draw the components and the dependencies between them, and you are able to follow a dependency back to a component you have already visited, then it is violation to ADP. But what do we need to strive for? We always need to try to implement directed acyclic graph. So why should you care about cyclic dependencies? Because their existence makes it very hard to split up responsibilities and work on different tasks in parallel, without stepping on each other's toes all the time. To understand these principles better, let's consider the next example. You have a system which consists of the next modules: QA frontend, this module where all automation tests are stored; service interface, the module which exposes an external interface to third parties; utilities, the module with classes that helps us to perform some calculations; Domain, the module which contains actual domain logic. This module depends on the utilities module. Engineers who worked on utilities module realized that QA frontend module has amazing string manipulation utilities that are already implemented, and these engineers added a dependency. Now utilities module depends on QA frontend module. And now you have cyclic dependency. Everything worked fine until one day a colleague of yours updated the way how string utilities worked for the sake of automated tests. Next day you realized that domain module has broken logic and system behaves not as expected. Definitely creating dependency between utilities and QA frontend module should be considered as an alarm. Not only because your production code depends on QA code in this case, but also because of cyclic dependency, which makes code development and support sometimes unpredictable and time-consuming. To foster better architecture design, we need to break cyclic dependency. But how? There are two options how to break it. The first option. We need to apply dependency inversion principle. For example, in this case we could create an abstraction that is required for utilities module. We can put this abstraction in utilities module and inherit it into QA frontend module. This inverts the dependency between utilities and QA frontend module. The second option is to create a new module on which both QA frontend and utilities depend. You can move the classes that they both depend on into that new module. The greatest danger of cyclic dependencies is that problems in one of your dependencies might backfire after they have traveled the entire cycle through the dependency graph. Even when your dependency graph has no cycles, there is still a chance that dependencies of a module will start causing problems at any time in the future. Whenever you upgrade one of your project's dependencies, you hope that your project will still work as it did before. However, there is always the risk that it suddenly starts to fail in unexpected ways. The stable dependencies principle says, depend in the direction of stability. Design cannot be completely static. We evolve our application constantly. We applied common closure principle to create modules that are sensitive to certain kinds of changes. These modules are designed to be volatile and we expect them to change. The rule of thumb here is that modules that we expect to be volatile should not be depended on by a module that is difficult to change. By conforming to the stable dependencies principle, we ensure that modules that are intended to be easy to change are not dependent on by modules that are harder to change than they are. But what is the metric to measure hardness of changes? There are many factors that make software component hard to change. Some of them: its size, complexity, clarity, mission of the component, etc. But I would like to put focus on another metric. The easiest way to make module difficult to change is to make lots of other software modules depend on it. On the diagram you can see pretty stable module. Two unstable modules depend on it. We can say that pretty stable module already has two good reasons not to change. If you expect module to be flexible and volatile, it is not the best idea to make pretty stable module dependent on the flexible one, because the last will become the module which is hard to change. And remember, the stable dependencies principle is not about making all modules stable. It is impossible and at the end of the day is not needed, because in case all modules are stable, that means system is unchangeable. Indeed, we want to design our module structure so that some modules are unstable and some are stable. Stable dependencies principle emphasizes the necessity of the direction of the dependency between the modules, from volatile modules to stable ones. Does it make sense? If this is clear, I suggest to move on. And the last but not the least principle related to modules coupling is stable abstractions principle. This principle states that a component should be as abstract as it is stable. The name of the stable abstractions principle contains two important words: stable and abstract. From the dependency inversion principle, you know that classes should depend on abstractions, not on concrete classes. The similar way we want to couple our components. However, dependency inversion principle deals with classes, and with classes everything is clear. Either class is abstract or it is not. So our stable module should also be abstract so that its stability doesn't prevent it from being extended. On the other hand, unstable module should be concrete since its instability allows the concrete one within it to be easily changed. That means if a module is planned to be stable according to design, it should contain abstract types in it so that it could be extended easily. Stable modules that can be extended do not overly constrain the design. But how to measure abstractness? One of the possible calculations which you can do to identify abstraction of your component is to divide number of abstract entities, abstract classes and interfaces in your component, by number of all classes in it. A value of 0 means that the component contains no abstract classes. A value of 1 means that component contains nothing but abstract entities. So by this moment we have learned 3 cohesion and 3 coupling principles that will help us to group our code. But actually there are other principles exist that will help you to structure your code. Let's review some of them. There are many ways how to organize the classes into modules in a software project. I also want to review with you pros and cons of few popular ways of how to group classes in your app. One of the options for you to structure your code is to group classes in modules by layers. You can think about your application from architectural layer standpoint. For example, you can have UI layer, the network layer, the database layer, services layer, and model layer. Grouping code by layer is typically the default approach, because after all, that's what the books, tutorials, and framework samples tell us to do. Here we are organizing code by grouping things of the same type. Generally, layered architecture considered to be a good thing. Engineers use layers to group their classes by applying separation of concerns principle. In this case, layers are the primary organization mechanism for our code. It comes with such advantages as: it is simple and easy for understanding. You wanna change data access mechanism? Absolutely no problems. Everything is in one place. Testing of each layer in isolation from another layers is simpler. But such approach also has some drawbacks. Usually with such approach, cohesion inside each module is low, and the coupling between items is very high. This sounds like completely opposite of what we wanna achieve. At the same time, there is a community that is agree with separation of concerns of presentation, application, domain, and infrastructure, and agree it makes sense. On the example you can see that each feature has its implementation spread out over multiple directories, over so-called implementation categories. For example, you can see that order feature items like order view, order service, order wrapper are spread out into 3 different components. Each directory contains items that usually are not closely related to each other. In this example, editing of order feature involves code changes in different directories and software modules. Also, deleting a feature cannot be performed as a single operation. You have to attentively analyze each module. Another popular approach to group classes is package by feature approach. We might want to use this approach to reflect feature set. According to this principle, we need to place all items related to a single feature into a single module. Following this approach, we can achieve high cohesion and high modularity at the same time with low coupling between components. Classes that work together are placed next to each other instead of being spread out all over the application. In case you would like to disable or completely remove specific feature, you can just remove directory. But to be able to apply this principle effectively, we need to answer one important question. What is a feature? There is no strict definition of such term as feature, and in real life, feature understanding varies. It could mean one specific use case or the whole set of operations related to a particular business concern. With this approach, we have high cohesion and low coupling at the module level. And above that, we can easily to say what an application does by looking at its module structure. On the other hand, in a typical layered architecture, the cohesion inside a software module is usually low and the coupling between modules is high. Followers of this grouping approach states that it is very rare cases when we change technologies or need to substitute the whole layer completely, whereas new features are constantly added to the software. The package by feature concept doesn't imply that one module can never use items belonging to another one. It would be properly to say that package by feature approach prefers package private as a default scope and only increases the scope of an item to public when needed. Packaging by feature has a lot of pros. Not all of them are listed on this slide. It also worth to mention the next benefits. High modularity. Package by feature has modules with high cohesion, high modularity, and low coupling between modules. Easier code navigation. Software engineers need to do less searching for items since everything related to the change request or to bug fix is placed in the same directory. Better growth potential. When component becomes way too large, it can be refactored and be split into two separate modules in a natural way. In case you adhere package by layer approach, you have comparatively monolithic module structure, because as an application will grow in size, the number of layers will remain the same, but amount of features will be increased. Thus, amount of classes in each module will increase without any bound. But packaging by feature also comes with the price of its drawbacks. Some of them are: unspecified feature size. In my opinion, this is the most critical disadvantage of packaging by feature. First of all, because in real life, separation by features sometimes might look not so obvious as it is expected. If you have login feature or virtual card feature, everything is straight and clear here. But what if you would have service which calculates distance from point A to point B, and you need to perform these calculations in order feature and in track your delivery online feature? You will end up having components which are still needed to be shared, and list of components which can be used in different features. That is something what extremely hard to predict at the beginning and what you don't know. And the module with shared items has a risk to become a huge one. Messiness potential. In a tangled domain where everything is connected to everything, separation of modules into the feature might become artificial. Just remember that there is no silver bullet. You should be aware of different approaches and practices and choose the one which works the best for your specific case and project. Probably, in real life you don't need even to choose one of the two approaches suggested. Most likely it will be the combination of these two approaches, where you will separate your software modules by layers and still will separate it by features inside. There is also another factor that may impact our code structure and that we can't underestimate. On 1968, Melvin Conway submitted an article to the major IT magazine at that time, Datamation. Datamation published his article with the text heading, "How do committees invent?" After that, Fred Brooks, in his famous book The Mythical Man Month, cited words of Conway and called it Conway's Law. The law sounds like this: organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. Even though Conway's law not a scientific law and doesn't have mathematical proof, it was recognized by community as a valid proposition for many environments. Probably you already had a chance to see how this law affects in our projects and other projects where a group of people, distributed teams, combined according to different rules develop software together. Conway's law wasn't intended as a joke, but as a valid sociological observation. It is a consequence of the fact that two software modules A and B can't interact correctly with each other unless the designer and implementer of A module communicates with the designer and implementer of B module. Thus, the interface structure of a software system necessarily will show a congruence with the social structure of the organization that produced it. The initial software architectural design in most cases not the best possible. We are dealing with software development where a lot of things can be extremely hard to predict until the detailed planning and implementation. That's why initial software architecture design may need to change. Thus, effective design depends on how flexible organization is. Nowadays, there is a trend to build cross-functional and multidisciplinary teams. Such teams consist of people with different roles, different domain knowledge, guided by the business capabilities. Cross-functional team can address any new requirement or new business definition from the start to end. This avoids processes overhead and produces different and often more distributed architecture with greater capacity to evolve. The interesting thing to mention here is the connection between Conway's law and single responsibility principle. During the delivery of the software project, we can have multiple key stakeholders. who has the biggest power and the most interest in the goals of the project. And each key stakeholder is empowered to submit either a change request or new business requirement which delivery team should be able to address. So, we can say that each delivery team which is connected with key stakeholder has single responsibility connected with the specific part of the requirements for the whole system. That's why system architecture is designed in the way that each delivery team doesn't impact another one. But in this case, we can treat single responsibility principle on another level of abstraction in comparison when we talk about this principle in scope of one class. So you can see on this simple example we discussed how single responsibility principle and Conway's law both affect our system architecture and code organization. During the grouping items in your application, you also need to take into consideration some technical factors. For example, in Java, if you use Maven build tool from Apache, you are forced to follow some basic conventions where to put source code, where to put web public resources, and where to put resources which you don't want to be accessible from the outside of the server. Some of frameworks work better with a given structure, like Spring MVC for example. You can group all your classes which should process requests under one package, because this framework will scan specific package to instantiate necessary request handlers. There is no harm in these technical factors. At the end of the day, software development process is always a question of trade-offs between many things. You can try to address one potential issue and receive another one. Knowing the theory, you can always analyze specific case impartially and opt for the best option which works specifically for you and specifically for your project at this moment of time. We shouldn't forget that tools and practices which were described in this lesson weren't created to make things even more complex. The goal is one, to simplify solution of most common issues. That's where patterns come from. Always remember that your structure should be easily navigable and should embrace most common scenarios. It also worth to mention that probably one of the proven ways to learn how to architect system so that it would be scalable, maintainable, and elements of the system will be easily reusable is getting more experience. Feel free to find inspiration in open source projects. Experiment with your own projects to find the recipe which will work. And never forget about naming conventions in your code. No matter you're giving name to a variable, a class, an interface, or a module. Clean code design, it is constant process but not one-time activity. Use tools which you have in place to support clean design and to share experience with team members. For example, you can drive clean design on your projects through the code review process or pair programming. Nowadays, we have multiple tools for static code analysis, which might help you to analyze metrics which will foster maintainable architecture of your application. For example, there are next tools. JQ Assistant, tool which can help you to validate dependencies between modules of your project, including detection of common problems like cyclic dependencies. It also enforces naming convention. Such tool can easily be plugged into the build process to automate detection of constraint violations and generate reports about user-defined concepts and metrics. Structureizer. Software like this one has one goal: to allow software developers to easily create software architecture diagrams that reflect the code. Unfortunately, static diagrams, whether drawn on board or with a general-purpose diagramming tool, tend to get out of date quickly and often don't reflect the real structure of the code. That's where software like Structureizer come into play. I believe that you can find a lot of other similar tools. These are just a few that I'd like to specify as a reference. That's all what I have for you for today. Let's recap what we have learned today. In this lesson we learned what coupling principles are, and we talked in details about such principles as cyclic dependencies, stable dependencies, and stable abstractions. We also reviewed with you other principles that can impact your architecture. Now you know how to group your code following package by layer principle and package by feature principle. I explained you Conway's law and how technical factors may impact our code organization. That's it. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students, today we start very important topic. We start learning of so-called growth patterns in object-oriented design. And even before we start learning of growth patterns, we'll try to answer a simple question. Why do we need design patterns? Understanding the context will help you to feel motivation that stands behind each pattern. In this lesson we are going to answer first what growth patterns are and why they are called so. After that, we'll learn what are key points of growth patterns. We are going to review with you creational, structural, and behavioral patterns. I will explain what is the difference between these types of patterns, and I will list main patterns from each group. Also, we'll learn what class and object patterns are. This lesson will help you to understand what we are going to learn in this section, namely what patterns we'll learn. And at the end of the lesson, I will give answers on the most common questions of my students who just started learning design patterns. It looks like we have really a lot of things to learn today. Let's start! And as I said before, let's try to understand first, why do we need design patterns? When we develop software, the way how we think is different. Each of us can come up with different solutions for the same engineering issue. And back that time there was no any standard or general advices of how to design application. Each project had new style, new structure, and each new team member that joined the team brought his own vision on architecture. Understanding of project architecture was a very complex task. All design patterns address these kind of issues and provide us with a set of solutions for most typical problems. And these solutions serve as a platform for all developers. We also can treat patterns as recorded experience of experts in the field. These design patterns are intended to be used in object-oriented programs and allows us to reuse the same patterns across different projects. Now we understand the context, and I believe it is clear for you why we need to follow design patterns during the development. But probably the interesting thing is to understand why these patterns called growth patterns. The name comes from the group of authors of the one great book that was written in 1994. The book was written by Erich Gamma, Richard Helm, Ralph Johnson, and John Vlasidis. You can find this book online if you wish. The book name is Design Patterns, Elements of Reusable Object-Oriented Software. As I said, you can find and download it. But anyway, in this course I will walk you through the most popular patterns that are still relevant even nowadays, and I will explain these patterns in simple words with the help of real-life examples that I prepared for you, and that are true examples from my practice. These authors became known as Gang of Four, and basically patterns from that book is called growth patterns. Even despite patterns are described in the book with examples, there may be different modern variations of such patterns, and I will show you all of them. Gang of Four described 23 patterns that were developed by the common experiences of software developers over a period of time. Nowadays, it is a pretty common practice when a new member joins a development team, then the developer learns about the existing architecture. This allows the developer to actively participate in the development process within a short period of time. What else we need to know about growth patterns before jumping to the details? Let's review key points of growth patterns. The following are key points about design patterns. Each design pattern is a general and reusable solution for repeatable and commonly occurring issues. So the concept tells us that in typical issues you can apply typical solution without reinventing the wheel. And these solutions were proven over a long period of time. As you can understand from this point, there are no reasons to follow pattern just because it is a common practice. We follow pattern just to solve our specific issue. We just used experience that was collected over time. Usually each pattern is a template of our solution that help us to achieve the better architecture design significantly faster. Patterns are generic and are flexible for customization. So, each pattern describes the way how to create objects and classes, and also, the pattern provides us with the description of customization, the solution to achieve goal in the particular context. The growth patterns describe 23 design patterns. Each of these patterns focuses on a particular object-oriented design issue to solve. Each pattern can also describe the consequences and trade-offs of use. All these 23 patterns are grouped in 3 main groups. They are creational patterns, structural, and behavioral patterns. Let's look at the list of patterns from each group. In this course, we are going to learn patterns from the list. On this slide, we don't have goal to hold overview of each pattern. I just want to give you an overview of what we are going to learn with you in this course. You can see names of all 23 patterns that are grouped in 3 groups. So you can see that such patterns as singleton, prototype, factory method, builder, and abstract factory patterns are considered to be creational patterns. What is the main goal of creational patterns? These patterns describe the instantiation process. You make the system independent from how their objects are composed, created, and represented. In software engineering, creational design patterns are design patterns that deal with object creation mechanism, trying to create objects in a manner suitable to the situation. The basic form of object creation could result in design problems or added complexity to the design. Creational design patterns solve this problem by somehow controlling this object creation. Sometimes creational patterns are competitors. There are cases when either prototype or abstract factory could be used profitably. At other times, they are complementary. Abstract factory might store a set of prototypes from which to clone and return product objects. Abstract factory might store a set of prototypes from which to clone and return a group of related objects. Builder can use one of the other patterns to implement which components get built. Abstract factory, builder, and prototype can use singleton in their implementation. Abstract factory classes are often implemented with factory methods, but they can also be implemented using prototype. Builder focuses on constructing a complex object step by step. Often, designs start out using factory method, which is less complicated, more customizable, based on subclasses, and evolve toward abstract factory, prototype, or builder, that is more flexible and more complex solution, as the designer discovers where more flexibility is needed. The next group is a group of structural patterns. They are proxy pattern, flyweight pattern, composite pattern, bridge, facade, decorator, and adapter pattern. This group of patterns focuses on how classes and objects can be composed to form relatively large structures. They generally use inheritance to compose interfaces or implementations. Structural design patterns are design patterns that ease the design by identifying a simple way to realize relationships between entities or defines a manner for creating relationships between objects. What is the difference between structural and creational patterns? Creational patterns are patterns that provide way to create objects while hiding the creational logic. This provides us flexibility for creating objects based on different use cases. Some examples of creational patterns we have discussed already. So based on your use case, you can decide which pattern to use. On the other hand, structural patterns provide us with options how to club classes and objects together to form large structures. Does it make sense? And we have a group of behavioral patterns here on the slide. These are the next patterns: observer, strategy, template method, command, iterator, memento, state, mediator, chain of responsibility, visitor pattern, and interpreter pattern. These patterns put a stress on algorithms and the assignment of responsibilities among objects to ensure efficient communication between them. Behavioral patterns explain how objects interact between each other. These patterns describe how different objects and classes send messages to each other to make things happen, and how the steps of a task are divided among different objects. What is the difference between creational and structural patterns? Creational patterns mostly describe a moment of time, moment of object creation, and structural patterns describe a more or less static structure. Behavioral patterns describe a process or a flow. Behavioral patterns, on the other hand, change the way your classes behave by changing the way they interact with other classes and interfaces, and the way other classes and interfaces interact with them. Now you know the main classification of Go patterns. These are patterns that we are going to learn. But also there is another classification of all patterns that we need to be aware of. The Genhoff form made another classification based on scope, namely whether the pattern primarily focuses on the classes or its objects. Class patterns deal with classes and subclasses. They use inheritance mechanism, which are static and fixed at compile time. Object patterns deal with objects that can change at runtime. So object patterns are dynamic. Pause your video to investigate the current slide. I believe there is no need to name out loud each pattern in each group here. This table will help you to understand what design patterns in which group considered to be either class or object pattern. Now, let me answer the most popular questions from my students, and the first question is related to difference between class and object patterns. Namely, if this is the first time you see these patterns and trying to understand them, the difference between these two groups is not obvious from the first glance. Agree? Answering this question in general way, class patterns focus on static relationship, and object patterns can focus on dynamic relationships. As the name suggests, class patterns focus on classes and their subclasses, and object patterns focus on the object relationships. On this slide, you can see specific difference between class and object patterns. When we are talking about creational patterns, we should understand that class patterns will be based on the inheritance and mechanism that are fixed at compile time. Class patterns can defer creation of object to subclasses, whereas object patterns deal with objects at the runtime and can delegate object creation to another object. As we go through each pattern, you will see this difference on real examples. Structural class patterns focus on composition of classes, whereas structural object patterns focus on different ways of objects composition. Behavioral class patterns describe algorithms and execution flows, and behavioral object patterns describe how different objects can work together and complete a task. Hope this makes more sense now. The next question, that is also one of the popular ones, is whether patterns that we are going to learn are specific to any of the programming language. The short answer is no. The patterns are general and can be reused in different programming languages where object-oriented approach is applied. All patterns are just templates that can be implemented in different programming languages, taking into account specifics of any particular language. The next question is, can implementation of one pattern in my code exclude possibility of applying different patterns? I would answer it this way. In most cases, patterns complement each other. Some other patterns have just subtle differences. And even more, combining different patterns in one application is a common practice nowadays. In case you have any other questions at this moment, do not hesitate to leave your question in comments to this video. Let's recap what we have learned today. In this lesson, we learned why do we need design patterns and what growth patterns are. I explained key points of growth patterns. Now you know what is the difference between creational, structural, and behavioral group of patterns. Also, we learned what class and object patterns are. And I answered to the most common questions of my students about design patterns. That's it for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello dear students, in this lesson we start learning creational patterns. In previous lesson we already performed an overview of creational, structural and behavioral patterns. Now it is time to learn patterns from each group one by one, and we'll start from creational patterns. That's why in this lesson we'll dive into the specifics of each creational pattern. In our plans to review today singleton, prototype, factory method, builder and abstract factory pattern. Especially for this lesson, I prepared code examples that will help you to understand and learn these patterns faster. Let's start. And the first pattern is singleton. We'll review each pattern in the similar format. The first thing that we'll learn for each pattern is its intent and what problem we are going to address with this pattern. Intent of the singleton pattern is to ensure a class has only one instance and provide a global point of access to it. But what problem we'll address in case we'll have only one instance of object in our app? In some cases, we don't need to create a new instance of the class each time we need. Imagine simple example. You have type called order management service. The object of this class can place order, and you really don't need to create multiple objects of the same type, because actually you don't need it. What you need is just a behavior of placing order, and this behavior can be executed by one single object in your application during the runtime. We are going to save a little bit memory in Java heap by not creating new object each new time we need it. We know that Java has automated memory management, and we can find garbage collector in Java too. But in case we'll create millions of such objects that we just use only one time and that's it, we will wake up garbage collector, and this can reduce performance a little bit and temporarily. So in this case, I just wanna be sure that I don't need to make garbage collector work by creating a lot of objects in memory. Now, when we understood the goal of singleton pattern, let's jump to the example and we'll look at the implementation. So here we have order management service class. The first thing that we need to do if we wanted to implement singleton pattern is to declare a private static field of the same type. This field will hold the reference to the single instance of the type. The second thing that we need to do is to create a private constructor. We need to make constructor private so that no one would be able to get access to it and call this constructor outside of this class. This allows us to restrict object instantiation outside of this class. The third thing that we should do, we need to declare a public static function. We'll call it accessor function that will allow end users to access our object when it will be needed. Pay attention that this function should be public, and we will invoke it with the help of the class, taking into account we won't be able to create an instance of a class. Also, I will implement lazy initialization inside this accessor function. What does lazy initialization mean? This means that I initialize object not when program is started, but I initialize the object on request when it is first called. Here in method you can see that I perform check, and if our static field is null, then I initialize object. In both cases I return the reference to the same object all times. To avoid very edge case of creation of two objects from different threads of execution, I also add synchronized keyword to this method to make sure that only one thread of execution will be able to enter this method body simultaneously. And after that you can declare any non-static behavior of this type. So any methods you would like to create, feel free to do it. You will be able to call these methods on this object. I will add one method, place order, just an example here. Basically, that's it. Let me now open demo file and show you how we can use singleton pattern. I'm running this file to explore console output with you. I can create two references and initialize them with order management service object. And when I compare it with equals operator, I get true because in both cases I get the reference to the same object. And you can initialize any field of order management service type in your program like this, and be sure that you have only one object of the current type in the memory. You can see here that taking into account our constructor is private, I can't invoke constructor. And once we get reference to object of our type, we can call any other methods of this object. So here I can call placeOrder method, for example, and we can see in console output that this method was invoked on the object. Hopefully now it is clear for you how to implement singleton pattern. Now let's discuss few things. It is worth to mention that sometimes you can find in the internet that singleton pattern is pure evil, and somebody even treat it as an anti-pattern and telling us that is something what we never should do. I recommend you to be professional and don't fall in the false argument. Let's try to understand why some people hate singleton pattern. First of all, I'd like to say that in case this pattern wouldn't be needed, it would just don't exist. But it exists for a reason. So each pattern comes with pros and cons, and we just should be aware about those rather than stating that this pattern is bad. Each pattern is good for a specific case. The first thing that haters of singleton pattern is mentioning is that this specific implementation violates single responsibility principle. So at this moment, our order management service is responsible for both managing his own life cycle and order management. But how critical it is? I would say that taking into account his first responsibility we have mentioned, managing life cycle, doesn't depend on other units, and it is very little chances that this responsibility become a separate reason to change. And also, when we'll learn frameworks for enterprise Java, for example EJB, that stands for Enterprise Java Beans, or Spring Framework, we will discover that these technologies describe so-called containers that manage lifecycle of all instances in the app. In Spring, default scope of all beans is singleton. In this case, responsibility for managing lifecycle is transferred to Spring, and that is fine. But what to do in case you need singleton and you don't have such container like in Spring or in EJB? So this point is discussable. The second thing why some people hate singleton is about static nature inside its implementation. And you know what? Sometimes people just hating things without getting deeper understanding of what actually wrong and what is the impact. The true impact of static nature inside singleton will impact us in case our class shares some state. So imagine in case our order management service would have some fields, and methods would modify the state of this object. And taking into account we have only one instance of this type, we're constantly changing its state and impacting calculations in other parts of our program. And this is really a true issue. But we shouldn't implement singleton pattern for types that should have some state. Remember, it is very hard to catch defects in case our singleton doesn't have fields and any state. Such types of objects are called stateless. And in case object is stateless, you shouldn't face with any negative consequences of singleton. And the third thing that some people is concerned about is impact during the testing of singleton. But I would say that this is potential impact of some static nature inside this singleton. Because in case you wanna create multiple unit tests and run them one after another, you should come up with a mechanism that resets the state of the object under test, because you won't be able to create another instance during the test like you usually do in unit testing. So, as you can see, the singleton pattern is not so bad as somebody can imagine. And to summarize our talks around singleton pattern, I want to simplify your life, and that's why I made a simple checklist to follow in case you want to implement singleton pattern. Here it is. Define a private static field in the singleton class. Make constructor private. Implement public accessor function. Implement lazy initialization, that is creation on first use, inside the accessor function. Make sure that accessor function is synchronized in case it is going to be used in multi-threading environment. I think that's it about singleton. Let's learn new pattern now. And the next pattern from our list is a prototype pattern. What is the intention of this pattern? Prototype is supposed to simplify project instantiation process by providing us with prototypes to create complex objects faster without new keyword. Because sometimes composing new object can take a lot of lines of code and specific domain knowledge of the system how to construct object. Multiply this by amount of times you create new objects of such type in your system, and you will come up with the idea to create object by cloning prototype. That should be easier. Imagine the real-life example. You have some file on your computer that you want to copy to another directory. You press Ctrl and C to copy file to a clipboard to paste it in another directory later. That is just one of real-life examples that demonstrates when you might need to create new object based on another one. Inside your code, you can clone any object like this to create its copy. Let's look at the demo to understand this pattern better. And to understand example on Java, make sure that you are familiar with cloning objects concept in Java. Because from technical standpoint, implementation of prototype depends on implementation of deep cloning for specific object. Let me show you an example. Imagine that I have archiver interface. This type describes contract for all kind of archivers in my app that I am going to use to archive files. This type declares two methods, archive method itself and clone method. We will implement deep cloning in all implementations of archiver type. I hope that archiver interface looks clear for you. Let's jump to implementations. We have two implementations, zip archiver and rar archiver. Each implements archive method. It is just a stop here for the sake of example, an implementation of clone method. If you know how cloning in Java works, you understand that clone method from object class makes shallow cloning. That means clone only references, but not actually cloning the whole graph of objects that stands behind the references inside the class. I mean its state that is described in fields. So always keep in mind that no matter what programming language you use, you should implement deep cloning of object to provide external interface to clone it, thereby implement prototype pattern. And to easily implement deep cloning, I use out-of-the-box method of serialization utils from Apache Common Slang library. It also requires make my type serializable. In case you are interested in serialization, feel free to check my lesson from Java course about serialization. Now when we have implementation to clone, let's think for a second. How user will interact with our prototypes? How to provide clients of our code with comfortable interface to create objects from our prototypes? There are different ways to address this question. I will show you just one of the possible solutions that I hope will work for you in your specific case. I create Archiver Factory. This is a class that can generate objects of different types that are compatible with Archiver interface. Archiver Factory has prototypes map, and in static initialization block, I just add different objects that will be used as original objects to clone, mapped with some string. Also, the factory introduced public static method called getPrototype that takes string as an argument and returns clone of our prototype based on the requested archiver type. Does it make sense? Pause the video for a second and think about this solution. I believe that this is a very elegant solution of the problem. And when it comes to actually using the prototypes, you can use Archiver Factory like this. Imagine that at a runtime you have requests for different archivers, and you have two strings, zip and rar. You just use Archiver Factory and request archiver from it, to call archive method on received object. Let me execute the program. So, as you can see, during the runtime I get new clones based on my prototypes, and they worked just perfect. Hope that this complete example helps you to understand how prototype pattern is implemented. Let's look through the checklist that you will use when you will implement a prototype pattern. The first item in our list is to add clone method to the hierarchy of our objects. The next thing would be to design a registry that maintains a cache of prototypical objects. That is exactly the moment when we created factory class in our example with original prototypical objects in it, remember? Next, design API that allows to clone object inside the factory and return new object as a result. Use factory API instead of new keyword to instantiate the objects. That's it. Let's move on. The next pattern is a factory method. The idea of factory method is to define an interface to create object, but let subclasses decide what concrete object to choose and what actual class to instantiate. We need factory method in cases when we need to standardize the architectural model for a range of applications. But each application decides what object is to instantiate. And this example is just one of possible examples where factory method is applicable. In real life, you will see that we are going to use factory method also in other patterns, such as AppSec factory. People often use factory method as the standard way to create objects, but it isn't necessary if the class that instantiated never changes, or instantiation takes place in an operation that subclasses can easily override, such as an initialization operation. Let's look at example to understand how it works. And to help you understand this pattern, we'll use previous example with archivers. So here is archiver interface from the previous example. We don't need clone method anymore, since I'm going to show you factory method pattern. We have the same implementation of archiver interface. We have zip and rar archiver. And our archiver factory is different. I have method here getArchiver, and this method returns me different objects of archiver interface based on the string that I passed to it. How exactly it does it? I also wanna say that you will find different variations of such pattern. In some examples you will see that there are multiple if-else blocks here to call constructor to instantiate specific type. In some examples I even saw switch block. That is not the best decision taking into account you are going to have long and unreadable if-else statement in case you will have a lot of different implementations. And also this approach will require you to update the source code. Approach that I suggest here takes less lines of code and easily customizable in case you use some IoT container, like Spring container that will produce new beans for you on a request. In that case, I would be able easily reuse this solution and add new types by adjusting configuration XML file. In my solution, I create a map with archiver type string and functions that generates new object of this specific type. What is this function? This is a constructor. And you know that function that takes nothing but returns something in Java called supplier. If you don't remember that, feel free to check functional programming section of my Java course. And in static initialization block, I map type strings with constructors with the help of method references. Great! And now I use ternary operator to implement getArchiver method. In case I can't find such mapping in map, I return null. In case there is some mapping, I execute this function. And by interface contract, in suppliers we have get method. That's why I called it here. Let's look at demo class now. I just use factory method to instantiate two objects. I run the program. And you can see in console we have different outputs produced by two different objects. Also, to prove you that factory generates new objects each time, I generated one more zip archive and compared it with existing one with equals operator. And you can see in console that the result is false. That means these two references are pointing out to different objects in heap memory. Does it make sense? In case you still have some questions, let me know by asking it in comments to this video. Now let's recap factory pattern and create a checklist for its implementation in the future. The first thing we need to do is to define a hierarchy of objects. As you can see, factory method use inheritance mechanism to provide you with the object of type that you need. The next thing to do is to design the arguments to the factory method. Think about qualities or characteristics that are necessary and sufficient to identify the correct derived class to instantiate. In our specific example, we used only string with archiver name, but actually it can be a set of arguments. Call factory method during the runtime to instantiate the object that you need. Great! We're already done with 3 creational patterns. 2 more patterns from this group left. The next pattern that we are going to learn is builder pattern. Why we might need builder pattern? Imagine that you have complex object to build and you wanna come up with the API that will allow you easily to define what exact version of object you would like to construct. In other words, imagine the case when an application needs to create the elements of a complex aggregate. And the interesting thing about builder is that you can find different variations of the builder pattern that actually solve our original problem, but implemented in different ways. For example, there is a variation of pattern with director class that is responsible for building objects, and also there is a variation of builder pattern that's called chain builder and allows to build new objects step by step. Personally, I believe that the second variation is more popular, but I want to share with you all variations with examples. We'll start from builder pattern implementation with director. Imagine that you need to build a computer, and you have computer class and you know all properties of computer. Let's look at it. So simple computer class that has display, system block, and manipulators. We have computer builder type. Here it is. It has computer property, abstract methods to build each property of a computer, create new computer method, and get computer method that returns the reference to the current computer field. I believe you understood already that we need to create concrete builders that will implement these abstract methods. In our example, we have cheap computer builder and expensive computer builder. The main things that you have to understand here is that these build methods change state of our computer object. Taking into account these are child classes of my abstract computer builder, I have access to computer property inside this class too. Taking into account in our example computer has only string properties, I just set different strings. But in real life, all construction logic of each field will be placed here. Okay, now when we have different computer builders, we need to have a director that knows how to organize work of builders to produce expected result. We have computer director class here. As you can see, it aggregates computer builder inside, and this builder we can pass to the constructor. We have build computer method, where I build computer by delegating work to my builder, and after that I can provide build computer on a separate request. I'm talking about getComputer method. This architecture allows me to substitute builder on the fly and build new computer based on the other builder, or build series of the same computers without passing the same data multiple times either to constructor of computer class or to setters. Does it make sense so far? Press a pause for a minute to understand how these classes are connected. And by the way, you will find references to the source code of all examples in attachments to this lesson. It is just a regular Git repository, so you can basically just pull repository on your local computer and investigate the source code. Let's continue. Here is the client of our code, and here you can see how builder pattern will work. I create director, and based on the current needs, I can set different builder. After that, I build computer and retrieve computer from director. That's it. So much preparations were done to achieve this simplicity in building complex objects and being able to change building logic on the fly. And here you can see that I set new builder, expensive computer builder this time, and built new computer and printing it again to console. Let me run this program. And in console output you can see that we managed to build different computers, cheap and expensive one. Is it clear? Hope that this version of builder pattern is clear. Let's review another version of builder pattern, chain builder. The idea here is simple. We have a class that has builder inside it that knows how to build the object. Each method of the builder returns the reference to builder object to call next method in chain-like style. Taking into account builder is an inner class, it has access to all fields from author class. Here is static new builder method that creates builder based on the account object. Here is the inner class builder. It has private constructor so that nobody from the outside could create a builder object. And after that we have setters methods that initialize the state of our account object, and each time setters returns the reference to the current object, the current builder. This trick allows us to build chain by calling the next methods on our builder. And we have special method to terminate chain of invocations. This is build method. Build method returns us the reference to already built and constructed object. Let's look at the client code to understand how it works. I call new builder method, and after that I build chain of setters that I need. And this chain is terminated with build method. That's how I get my account object. This architecture allows me to build objects step by step and initialize only those properties of my future object that I need. Hope this example makes things clearer. Let's now come up with checklist to implement canonical builder and chain builder pattern. To implement builder pattern with director, we have to declare builder interface, create multiple builders, create directors that can work with different builders, in client code instantiate director and concrete implementation of builder to build new objects. To implement builder pattern with chain method calls, we have to create inner builder class inside type that we wanna build. Implement method in type that returns reference to the builder object. Declare setters in builder that returns the reference to this builder object. Implement build method to terminate method chain and return target object. In client code, call method to get reference to builder and build object step by step. Basically, that's it regarding builder pattern. Let's move on. And the last but not the least pattern for today is an abstract factory. We need abstract factory for cases when we need to create a group of interdependent classes. By implementing abstract factory pattern, we define an interface for families of objects without specification of concrete class. To understand this pattern, let me explain you an example. Look at the class diagram that you see on the slide. Imagine that we are working on the desktop application and we need to create pop-up window that is specific for each operating system. I mean, on macOS we have close window button on the top left corner. In Microsoft Windows we have close button on top right corner. We have different styling of scrolls and buttons. That's why we have two abstract factories, for Microsoft Windows and for Mac OS. Each factory can build window that contains only objects that should be used together. So, in this task, when I create window, I need to create set of objects, buttons, scroll, content area, and so on. And I can create scroll for Windows and combine it with macOS buttons. Understand? That's why we can talk about family of objects that can work together with each other. I will pass my abstract factory to GUI builder so that GUI builder can use abstract factory to create all necessary elements for my window. Does it make sense? I can proceed explaining theory, but to be honest, personally for me, this pattern wasn't obvious until I saw a real-life example. So, let's jump to an example. Let's start our demo from abstract factory itself. Here is my abstract widget factory that declares three methods. Method that should create window itself, method that creates scroll, method that creates an array of navigation buttons. Can you recognize what these methods remind you? They look like factory methods, do they? This abstract factory and abstract methods here will be implemented for different families of objects. I have Mac OS widget factory and a MS widget factory. And you can see that in each class I create objects that should work well with each other. For macOS widget I create macOS window, macOS scroll and macOS buttons. For Microsoft Windows I create MS window, MS scroll and MS buttons. Does it make sense? Next, I have GUI builder. I can pass to it any concrete implementation of abstract factory I have, and GUI builder will use this API to build all necessary elements and display them properly. Now let me open my demo file. You can see that I create GUI builder, and after that, based on the user input or app configurations, it doesn't matter, I can take information about operating system from different places. But when I know operating system, I initialize my widget factory and call build window method by passing there my abstract factory. That is how abstract factory pattern helps us to deal with instantiation of family of objects. Now let's come up with a checklist that you need to follow when you want to implement abstract factory pattern. Implement class groups, also called type families. Declare abstract factory interface with factory method per product. Use abstract factory to instantiate group of related objects. Hope that now abstract factory pattern doesn't look like something scary. And before we call it a day, let's understand what is the difference between factory method and abstract factory. I would like to list few differences. They are: factory method focuses on generation of one single object, whereas abstract factory should solve issue of instantiating group of related objects. Factory method can be part of abstract factory, but also factory method can exist independently. When we are talking about factory method, we mean one method that can generate specific object. But when we are talking about abstract factory, we mean a type that may contain many different methods that help us to create group of objects. Factory method relies on inheritance mechanism. It allows subclasses to decide what implementation of specific type to generate. But in abstract factory, the main focus is on generating multiple objects from one family that are not connected within one hierarchy. Hope that visualization on the slide and my explanation helps you to understand the difference. Now let's recap what we have learned today. In this lesson we learned 5 creational Go patterns. After this lesson, I believe you know singleton, prototype, factory method, builder, and abstract factory patterns. That's it. Thanks a lot for your attention, dear students. See you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Hello dear students, we proceed learning of patterns, and in this lesson we are going to learn structural patterns. By this moment you are already familiar with overview of structural patterns, and I hope you had time to learn creational patterns in details. And today we are going to start learning the most popular structural patterns. And our plans to learn today next patterns: proxy, decorator, adapter, and facade. The rest of the structural patterns we'll learn in another lesson. Also, I will try to focus your attention on the differences between these patterns to make sure you clearly separate them. After this lesson, you will know how to create more complex structures with different units. Also, in this lesson, you are going to see a lot of code examples that will help you to understand this topic better. All code examples that you will see in this lesson are attached to this video. Let's start. And the first pattern that we are going to learn today is proxy. The goal of this pattern is the following. We want to protect some object of direct impact. Also, we want to control interactions with the object and trigger necessary behavior if needed. When we will use proxy pattern? For example, when you don't want to create real object because it is big, and you want to postpone instantiation process to the moment when the object will be needed. At the meantime, you can initialize variables with the proxy object to avoid null pointer exception and initialize real object on the first request to proxy. The next case when you want to use proxy pattern is to control interactions with the object. The simplest real-life example is proxy that we use in the internet. Imagine that in your company you have a list of restricted resources. For example, your employer restricted Instagram and Facebook to make sure that nobody spends working time in the social networks. Just an example. How your boss can implement this rule? He will use proxy server. When your browser will send a request to a specific website, it will go through the proxy server that will validate URL in your request with the restricted ones. In case the website you are requesting is banned by your organization rules, you will receive connection error. That's one of the examples of using proxies. Also, you will face with proxies in Spring Framework, especially in aspect-oriented programming. In case you don't know what is aspect-oriented programming, no worries at all. I will explain it now in simple words. Following definition from Wikipedia, aspect-oriented programming, AOP, is a programming paradigm that aims to increase modularity by allowing the separation of cross-cutting concerns. To be honest, even for me this definition is not clear. Let me explain this in my words. Imagine that you have some code already written. Let's say some code that places order in database when customer presses buy button. And now you don't want to adjust this code, but you want to add additional behavior to this event. Now you want also to send email to the administrator that order has been placed and place order in database as usual. You can add so-called advice to the existing code. And you can implement this with proxy. You create wrapper around original object and track requests that were sent to it. And depending on the request, you can add additional behavior. Does it make sense? While this is also an example of proxy pattern, it is hard to demo today in case you have never heard about aspect-oriented programming. We'll learn this in other lessons. And we will have a little bit simpler example. Also, other examples that you might already use: in unit and integration testing in Java, we have Makita and EasyMock library. And even in other programming languages, you have libraries that help us to create test doubles. Do you remember such test double as spy? Let me remind you quickly. Spy is a test double that behaves like a real object beside methods that are stopped beforehand. Such test double in most cases implemented with the help of proxy pattern. The wrapper is created around the original object and each method invocation is controlled. Is it clear? Hope that now you understood in simple words why we need proxy patterns sometimes and what problem it's supposed to solve. Now let's look at code example to understand proxy pattern better. I prepared example of internet proxy. Imagine that we have some interface called internet. This interface declares only one behavior in our example, connect to host, and takes URL as an argument. We have implementation of this interface. I called it default internet. By default, it just prints URL to console. And now I'm going to create a proxy. Proxy should implement the same interface. Here's my proxy internet. As you can see, it also implements the same interface, and it aggregates default internet inside. So it wraps the default internet object. We have list of bound websites here. It can be Facebook and Instagram, for example, just to avoid employees sitting in social networks all day. And when connect to host method is invoked, I verify whether somebody trying to access banned website. If yes, then I throw an exception. If no, then I proceed with internet connection. Does it make sense so far? Press a pause for a minute and look at this proxy one more time and try to understand how I wrapped default internet object here and delegated calls to it. If everything is clear for you now, let's create a checklist to follow in case you wanna implement proxy pattern. So, to implement proxy pattern, we need to follow next steps. Declare interface for wrapper and for original type. Create proxy type that implements current interface. Aggregate objects that you wanna wrap in your proxy type. Implement logic of interaction with the original object. That's it. Regarding some items to consider, some engineers might say that introducing proxy is just about having additional level of abstraction, and they will be right. But remember, we are having this level of abstraction to benefit from it, not just to have it. So analyze your particular case and decide whether proxy is needed in your case. If everything is clear here, let's learn new pattern. Let me present you decorator pattern. Let's try to understand what it is. Decorator pattern allows us to structure objects in such way that allows us to add new features to already existing objects. You can attach new behavior and extend existing one. Decorators are flexible alternative to the inheritance mechanism for extending functionality. Implementation of this pattern allows you to add new features to already constructed objects. And to understand decorator better, always keep in mind input-output package in Java. In case you didn't learn Java yet or forgot the specifics of this package, I will remind you. In IO package in Java, we can create object of input stream. And after we created this object, we can wrap it with buffered input stream decorator. In other words, we are able to add ability to use buffer during the reading, and moreover, if we want, then we can wrap this new object with another one. For example, data input stream that allows us to read date in specific Java data type like short, byte, char, boolean, etc. And we can do this wrapping as many times as we want. That's how decorator works. At the end of the day, it is just not possible to describe all variations of all possible types with different features. Sometimes it is easier to let end user, in our case to engineer, to decide object with which specific features he or she would like to construct. Does it make sense? As I already said, one of the simplest and most popular clear examples of decorator pattern is IO package in JDK. Feel free to investigate how decorator is implemented there, but still, I think it might be not super obvious at the first glance. That's why I would still prefer to explain you this pattern on the simple example. Imagine that we are developing some racing game, let it be Need for Speed video game, and we need to program logic for different type of cars. For example, we are going to have some regular car, it could be any car of those that we see on the streets each day. Also, we'll have features of luxury and sports car. And we will be able to combine these features. For example, we'll create luxury sport or just luxury car. Now pay attention how we'll structure our types here. First of all, we need to define an interface of our car type. Here it is. To simplify this example, let's pretend that we have only one method, drive. And before constructing of complex object by adding new feature to it, we need to have at least some basic object that will be used as a base. That's why the first thing that I did, I created this basic car class that implements car interface. As you can see, there is a default implementation that just prints text to console about the fact that basic car drives. Now I wanna implement car interface in car decorator class. This class will describe logic of adding additional features to car. Here is the car decorator class. Pay attention that decorator implements the same interface. In this particular case, I also aggregate car object inside. I can't create car decorator without another car. And when drive method is invoked, you see that I call drive method on this car. Press a pause for a second to understand this. In this case, I can build a chain of objects that wraps each other and invokes specific variation of the same behavior. And again, in your particular case, this method may be rewritten as you wish, and as it will work for your logic. Now, let me show you classes that describe specific features to be added to the basic car. As I mentioned before, we have sports car and luxury car. Let's start from luxury car first. You can see that it extends car decorator. It takes car as an argument. We override drive method here so that we call parent drive method, the one we have just reviewed in car decorator, to invoke drive method on aggregated car first. And after that, in this method I add additional behavior. In our case, it is just printing additional text to console. But I believe it is clear for you that you can actually describe any other logic here. Also, pay attention that you can't create just luxury car. You can build luxury car only on the basis of some other car. That's why it is necessary to pass this car to constructor. Is it clear? And in sports car we have pretty similar situation. The only difference is just that behavior in drive method is a little bit different. I print another text to reflect the fact that this is sports car driving. But in the real life, you can implement any logic you think is needed here. And one more important thing. With decorator, you are not limited only to overriding some behavior. You are able and welcome to introduce enhanced interface and new behavior by wrapping basic object, and also you can declare additional fields if you need. For example, here in sports car, I can declare additional behavior that is valid for sports cars. Set transmission mode. If you ever draw Porsche or Ferrari, you know that they have different drive modes that tune suspension of your car, exhaust, transmission, and other things. For example, in Porsche 911 you have regular mode, sport, and sport plus. And this method will help us to set the transmission mode in our car. Ideally, it would take enum, but in our simplified example, it takes any string as an argument. And now, the most interesting part is the client part, and see how we can construct objects following this architecture. I have demo class here where I collected everything in one place. Let me run the program first to walk you through the console output. As you can see, I create a basic car first and call drive method. Afterwards, I decided to create a sports car. To create it, I need to create new object of basic car and pass it to constructor of sports car. Here you can see that sports car wraps basic car. And when I call drive method on sports car, you can see that basic car behavior works first, and after that feature of sports car worked. And again, it's only up to you how you will write this logic. You can even didn't call drive method of basic car, but just use some other behavior of basic object. For example, basic car also has 4 wheels. You can just work with those properties. We can initialize variable of specific type, like we did here with sports car. And in this case, you have access to sports car specific behavior, like we described. Set transmission mode. So you can see how with decorator pattern I enhanced existing interface. And having this flexibility, I can create objects with different features and variations. For example, I can create sports and luxury car if I wish. How to do that? The decorator pattern allows us to pass new objects inside the constructor to wrap objects as many times as I need. As you can see here, I just wrapped objects multiple times. And when I call drive method, I can see behavior of basic car, luxury car, and sports car. Can you see this? And in this case, you don't need to apply inheritance mechanism to create all possible combinations of different types. You can just construct during the runtime object with features that you need. Isn't this cool? Now you know how to implement decorator pattern in your application. Let's now check the checklist to follow to implement decorator pattern. The first thing you need to do is to ensure that you have a common context, or so-called core. Like in our case, we have some basic car. Like in IO package, we have some basic input stream type. You should have at least some core component and list of features that you would like to add to it. After that, create a decorator type. The core class and decorator class implements the same common interface with common context. Implement different features that can be added to the common context by extending or implementing decorator type. Implement additional and enhanced functionality in decorator classes. Those are items that we went through during the implementation of decorator pattern in our example. Hope that with the source code it was easier for you to understand this pattern. Now, when we are done with decorator pattern, let's proceed with the next one. And the next pattern is adapter. And as always, let's understand first what problem adapter pattern is supposed to address. Imagine that you already have some type that do exactly what you need, but interface is incompatible with the one you have in your system. It can be because of the different reasons. Some of them are: you are migrating part of your system and some interfaces are not matching each other, or you are dealing with obsolete code and you can't just remove it because it works just fine, or you wanna use some third-party library, but it has different interface that doesn't match needs and agreements within your module. What solution you have to apply to solve this? Just to implement adapter that helps to support existing interface and map it against another interface. Similar to the different types of sockets. When you travel to Great Britain, you need specific adapter. When you travel to United States, you need another adapter. When you travel to Europe or Russia, you need third type of adapter to plug in your device. Does it make sense? Similar to this example, you can implement adapter in your code to adapt one interface to another. In other words, we can say that adapter wraps existing class with a new interface. Code reusage always was a hard thing to follow and to implement. An adapter pattern should help us with this. Hope you already understood what do we need adapter for. And now, let's review code examples to learn this pattern better. Imagine that we have sorter interface that's supposed to sort array of ints across my app, and I use it already in other method declarations in different places across my app. And imagine that I have third-party library that sorts list of integers. And it does its work just perfect and sorts faster than all known algorithms. This is so-called number sorter. Here it is. According to its interface, it takes list of integers but not array of ints. Here you can imagine any types that you might have in your system. The main thing to understand here is that you have some specific interface and method signature. In our case, this is sorter interface. And you use it across your app. You already have methods that accepts only such type. It can be different variations of the same issue. And now imagine that you need to sort array of ints, but you have new algorithm in the third-party library that is significantly faster and you wanna use it in your application, but also you don't wanna break anything else in your program, what has been already written before. And probably I even oversimplified this example, but this is just to make it clear for all my students who see adapter pattern first time in their lives. Definitely you can create a list from array and vice versa, and that's it. But point is in the fact that you don't want to do this all the times, and also you don't want to fix all places where you will use this. And moreover, such case may happen with types that is not easy to convert between each other, as array of ints and list of integers. But again, this is just simple example. So what we have to do? The easiest thing would be to find the way how to adapt the existing sorter interface to number sorter to make it sort array of ints. Agree? Why I need to think how to implement faster and more efficient algorithm of sorting array of ints if I have another class that do approximately the same thing that I need? In this specific case, I need to come up with the adapter. Here's my sort list adapter. Pay attention that it implements my sorter interface. That is basically interface that I already use across my whole app. I aggregate number sorter here inside. And when sort method is called, I convert array of ints to list of integers, pass it to my number sorter, since it already works with list of integers, and when sorting is completed, I convert it back to array of ints to return from the method. Now you can see that actually I have the interface that I need, but I adapted implementation to make it work with third-party library. Can you see this? Let's investigate now client code together. Here we have array of ints, and it is obvious that in case I would use third-party library directly to sort my array, it wouldn't work, because method signature is different. After that, I initialize my sort list adapter, and you can see that I can refer to this object with the reference of type sorter. That is my interface. And I can use my interface that is already used across my program. So I just call sort method and pass array of ints. Inside, it is converted to list of integers, sorted and converted back to array of ints. Does it make more sense now? And again, I would recommend you to pause the video here, make sure you downloaded the source code from attachments to this lesson and review it by yourself. Hopefully my comments make sense and now it is easier for you to understand how adapter pattern works. Now let's create a checklist to implement adapter pattern. Identify the interface that you need to follow. In our case it was sorter interface. Identify types that you need to adapt. In our case it was number sorter. Create adapter that implements target interface and aggregates type that you need to adapt. Wrapper class should have the reference to the adaptee class. In the final step, instantiate adapter in your client code and just use it. That's it. Hopefully now it wouldn't be hard for you to implement adapter pattern from scratch when it will be needed. Now let's learn the last but not the least pattern for today. I'd like to present facade pattern. Why do we need it? Let me explain an example. Imagine that you are implementing some e-commerce application, and you are working with business-to-business model, so-called B2B. Sometimes registration of B2B customer, that is some legal entity, is harder than registration of regular user. For example, there might be cases that you have multiple systems and you want to avoid duplication of records related to the same customer. Or you want to verify data of legal entity in other services before registration. And registration of new customer will take few subsequent calls to different services. What do you think? Will it be comfortable to develop and to support such system having duplicated method invocations across your app? And moreover, making mistake is easier when you have to remember the whole process of registration for B2B customer. How to simplify life of engineers and reduce development efforts and likelihood of mistakes? The proper solution here would be to introduce another level of abstraction here. So-called facade pattern helps us to create unified interface to interact with set of interfaces or subsystem. Facade defines a high-level interface that makes the subsystem easier to use. Also, using facades, it makes easier for new engineers who are joining your team to learn the system faster. So, I believe you already understood that facade will become client interface to the set of other types or subsystem. Probably the only thing that we need to learn now is to how to apply this on practice. And especially for this, I prepared code examples that will help us to understand this pattern faster. Imagine that you are implementing travel booking system. and you need to allow end users to book travel route that includes flight combined with the hotels available at the selected dates. So, as a traveler, I wanna book flights and the hotel available for me at that day. As you can see, I have specific business case that I need to implement. I believe you already see the whole picture in your head. Implementation of this scenario would require declaring set of types like the following ones: flight, hotel, hotel booker, that is type that can book hotel, flight booker, that is type that can book flight for us, travel route. This is exactly the type that combines hotels with flights to create travel route for tourists. And here is our travel facade. In our specific example, it has only few methods, but in real life, it could be more methods here. We have methods for our specific business case. Get list of travel routes that are available and book specific travel route. Here you can see that I aggregate hotel and flight booker to get list of available hotels and flights accordingly and book hotel and flights when user will select the travel route. In the get travel routes method, I can describe logic of processing for flights and hotels and mapping them between each other and creating of travel routes. After that, we return list of travel routes. To not distract your attention on processing logic, I just put comment here and return empty list to avoid compilation error and null pointer runtime exception. Hope you are not losing the focus from main things here. In the book travel route method, I book separately hotel and flight. And now every time I book travel route, I just need to call one method, this one. Let me show you how client code looks like. Now the only thing you need is just to create an instance of travel facade wherever you need to get list of travel routes and book travel. You can see how easily I can get list of travel routes and how easily I can book travel route. Just imagine that every time in all places of your app you would need to instantiate flight booker, hotel booker, describe logic of mapping and creation of travel routes. That is almost impossible. That's how facade may make our lives easier. You have just another level of abstraction and you can interact with the subsystem through the simple interface. You should always remember that your facade shouldn't become a guard object. Guard object is an anti-pattern that describes the case when you have object that can do everything in your app. For example, you have facade that can register user, log him in, create shopping cart for him, check out, and so on. You can't do everything with the one object because this will violate OOP principles and will bring you to the high coupling, which you already know is not perfect too. Basically, that's it regarding facade pattern. Let's create the checklist to implement facade pattern. The first thing we need to start with is to define business cases and business scenarios that are most used in your app. Design a facade interface that describes behavior to interact with the subsystem. Aggregate all necessary types inside the facade to ensure efficient and proper behavior of facade. In client code, get instance of a facade and work with it. Now you can easily implement facade by your own. We learned the most popular structural patterns in this lesson in my opinion. They are proxy, decorator, adapter, and facade. And very often my students ask me, what are specific differences between these patterns, because in some degree they have something in common. But I want you to see clear difference between them. So let's now cover the differences on this slide. Let's recap what does proxy pattern do. Proxy wraps the object to avoid direct interaction with object. Proxy provides the same interface as wrapped object. And how this is different from decorator pattern? Decorator provides enhanced interface, like you saw today in our example when we decorated our car with additional behavior and method. So you can decorate object with additional behavior. Okay? But when I tell this, my students often ask me, and what is the difference between proxy, decorator, and adapter then? Adapter provides different interface to its object and adapts one interface to another. Is that clear? and then how facade pattern is different. Facade also introduces new interface, but adapter introduced new interface that respects a particular interface that it wants to adapt. On the other hand, facade is used when you want to create new interface to make interaction with subsystem easier, and very often by combining behavior of multiple units into complete business flow. Does it make sense? Hope now it is clear for you what is the difference between these patterns. Now, let's recap what we have learned today. In this lesson we learned 4 patterns. They are proxy, decorator, adapter, and facade. Also, we performed comparative analysis of these patterns so that you could clearly understand the difference between them. That's it for this lesson. Thanks a lot for your attention, have a great day, and see you in the next lesson. Hello my friends, in this lesson we proceed learning structural patterns. In previous lesson we already learned proxy, decorator, adapter, and facade pattern. That means we have 3 more patterns from structural section to learn. In this lesson we'll learn bridge, flyweight, and composite. And as always we'll learn these patterns with the help of coding examples that you can find in attachments to this lesson. Nothing to say more about agenda. Let's start. And the first pattern that we are going to review today is a bridge pattern. The main goal of bridge pattern is to decouple an abstraction from its implementation so that the two can vary independently. Let's try to understand what stands behind this statement. Imagine the case when your class and what it is supposed to do varies very often. I mean literally, you should go and change your class every time it changes the behavior. Such cases not very often, but it may happen that you would need to come up with a solution how to address constant changes in behavior. But what if we would separate 2 terms, abstraction and implementation? What if your class would be considered as relatively stable abstraction and you will keep implementation separately? That is exactly what bridge pattern is about. Bridge pattern exists to address challenge of constant behavior changes without impacting the code that was already written. Pretty cool, don't you think so? With bridge pattern we have abstraction and its implementation separated, and that's why they may be improved separately. Without bridge pattern you have all implementations bound to the abstraction at compile time, and this can be changed at the runtime. How the separation of abstraction and implementation is implemented? Very easy. They are separated in different classes. We should implement our abstraction with the possibility to delegate calls to our implementation. In this case, we will be able to pass implementation during the runtime and update our behavior. Does it make sense? If not yet, then let me explain this on example with the details. In this example, we are going to have TV, radio, and remote control. Remote control may control both TV and radio. Unlike all other previous examples, let me start this one from the client code. I am running this demo file to explore console output together with you. We have testDevice method that performs same operations with different remote implementations separately, on TV and radio. I call this method and pass TV there first. We have some basic remote that can only turn our device on. And this is exactly what we did here. We created our basic remote object and passed there our TV object. I invoke power method here and print status to console. Let's see what we have here. We have indication that this is test with the basic remote, and notification that we have pressed power toggle. After that, I call method that all devices in my example have, print status method. And we have status printed here, and we see information about current volume and current channel. Great! What we can do next? Imagine that the next day we needed to improve our behavior and the way we interact with our device and change its state. Now we need to be able to mute the device. And what I have to do? I have options, either to adjust my existing remote control or get benefits from breach pattern and separation of abstraction and implementation. So, I have advanced remote object, and I perform the same operation. Power method is invoked first. An advanced remote type has such behavior as mute. After that, I print device status to console. And what do we have here now? We have the same TV, but this time it is disabled. Why? Because power toggle has been clicked second time, and the state of the TV is changed. This time it is turned off. And we have volume of 0 because we muted our TV. Is that clear? You can see how I improved my remote control without touching my TV at all. We have pretty similar story with the radio. Radio is just another device, correct? And we can apply the same behavior to the radio. At the beginning, you can see the demo of the basic remote object, and afterwards, we mute radio, and you can see we have muted radio that is turned off. And now the most interesting part, how all of this is implemented. Now when you know how everything is working here, let's dive deeper in details. We have device interface and implementation in the form of TV and radio. Each device may perform all actions that are listed in its interface. Hope that there are not questions here. The next interface that we have here is a remote interface. This is an interface that describes all possible actions that remote may do. We have basic remote, like you saw, and implements this interface. And in case we need additional behavior, we have advanced remote that just extends the basic remote. Pay attention to one important thing here. Both basic remote and advanced remote don't have constructor without arguments. All of them takes abstraction as an argument to work with it. So each remote takes some device during the instantiation. You can't create remote without device in this case. And once remote control has device, it changes its status. And by the way, here is mute method in advanced remote. It prints log to console that mute method has been invoked and it changes volume on the device. Does it make sense? In this example, our remote controls serve as an abstraction and our devices as implementation. Remote has the reference to device and remote manages the specific device. You can improve remote controls independently without necessary updating of devices. Can you understand now how all these types are connected between each other? Anyway, in case you have any questions, do not hesitate to write them in Q&A section of this course. And right now, let's create a checklist that we need to follow during the implementation of breach pattern. To implement breach pattern, follow next steps. Define whether you have two hierarchies that can be improved and enhanced independently. If yes, then split them into hierarchies of abstractions and implementations. Think about operations that would be needed to your client. Describe these operations in abstraction class. If you need new operations, create new abstraction class. Design the separation of concerns. What is the abstraction and what is the implementation of behavior? Create concrete classes of your domain type and behavior. Add the reference to the implementation to the class of the abstraction. That is exactly how we allowed to pass device into the constructor to apply additional behavior in our example. Delegate calls to the target object at runtime. These are steps that we passed to implement breach pattern from our example. Hope it makes sense. Let's continue. And the next pattern that we are going to learn is a flyweight. This is a pattern that allows to aggregate bigger number of objects by sharing their state between objects to not store the duplicated state and the same data in each object. To explain it in simple words, imagine the next case. You're developing a video game. Let it be GTA. And you decide to blow up hundreds of cars that drives on the highway. And you're shooting them with a gun, and you know that you already spent thousands of bullets. And now your game crashed and closed. After investigating logs, you understand that there is not enough of RAM on your computer to store information about all bullets and all cars that you blew up. Indeed, why should you store information about similar cars and all bullets if they are the same?
That would allow you to save huge amount of memory. That is exactly the reason why we need to use flyweight sometimes. For example, each element should have different and common qualities. For example, each car would have different color, but colors may be the same for many different objects. That's why there is no need to store each color separately for each car. Moreover, body of some cars also similar. That's why you don't need to store dozens of the same 3D images of the same car. But each car should have different coordinates in your virtual space. That's what will be unique for each car and should be stored. But we already saved a lot of the space, because coordinates don't take as much space in RAM as car body images and colors information. We can call something what is not changed inner state of the object, and some state that is changed outer state. For example, color and body type of the car in our video game is constant for each car and can be considered as inner state. Coordinates of the car in the space is something what is unique and specific for each car and will be different. That is called outer state. And now you can easily understand the main idea of a flyweight pattern. The main idea of a flyweight pattern is to store only inner state and pass outer state as method arguments when needed. Following this approach, we have significantly lower number of objects and we can use the same objects with different outer state to reproduce the state of different objects. In this case, you can reuse the same objects in different contexts. Does it make sense now? And flyweight pattern should give us an answer where to store this outer state. And you can see different implementations in real life. Often this state is stored in some container object, sometimes even in global context. In this particular case, we have to store outer state mapped with the references to the real objects. To simplify interaction, we can even create a factory of a flyweights. For example, some factory method that takes arguments and returns you ready-to-use object. I believe you didn't skip lesson about creational patterns, namely about factory method. Now when you understood what flyweight pattern is, at least on the high level, let me show you an example. Because with real code it will be easier for you to get the details. In our example, we will create forest that consists from 1 million trees. Each tree should be a separate object that contains info about its state. Creating a forest with huge amount of trees will take a lot of space, but also a lot of trees sharing the same state, same color, name. That's where flyweight pattern come into play. We'll separate inner and outer state. We create multiple objects of tree type class that will cache common information. Let me show you this type. Here is tree type class. It has such fields as name, color, and other tree data. And instead of having million objects of tree type, we can reuse our flyweight objects. Let me show you the tree type. You can see that each tree will have unique coordinates. But tree object also will have the reference to some common information that is shared in tree type object. And you can't create tree object without tree type. Pay attention to this constructor. What to do in case we need to get some tree type? For such cases we have tree type factory. In this factory we have a map that stores only one object mapped to unique key. And we use tree name as a key. That's why we have only one object mapped to one tree name. And in static method that allows us to get tree type, we can request tree type. I use multiple arguments to get the tree type that I need. At the beginning, I check whether I already have object associated with such tree name. And if no, then I create one and put in my map. Is it clear? Now let's look at the forest object. In forest object I have method plant a tree. I pass information about the tree that I wanna plant. And the first thing that I do, I wanna get my tree type. After that I create a tree object with the tree type. And after that I add this tree to this list. Can you see this and understand that storing some data in tree type object allows us to share some properties and some state between multiple tree objects? Yes, Tree is a separate object, and yes, it has unique values. But flyweight pattern allowed us to save relatively a lot of memory by sharing some state between different objects. Would you like to look at the client code? Let's do that. This is our demo file. In my example, I have only two types of trees, summer oak and autumn oak. Obviously, these trees will have different colors. I generate coordinates randomly with this method. I will not focus on the logic of the method. After I planted 1 million trees, I set size for my window and make it visible. In parallel, I print statistics to console. In statistics, you may find information about memory usage. And to show you how it works, let me run this program. This is done with old-fashioned Java stack for desktop applications, but it doesn't matter for understanding of flyweight pattern. You see that trees are planted on this screen. Let's now check console output to check the statistics. By my approximate calculations, we saved approximately 30 megabytes on million trees. Hope now you clearly understand how flyweight pattern works and what is needed to be done to implement it. Let's now create checklist to implement this pattern. To implement flyweight pattern, we need to follow next steps. The first thing we need to do is to split state of our object in two groups, inner and outer state. We should clearly understand what state is the same across all objects and may be shared, and what state is unique. Create a type where constant fields will be initialized through the constructor. Make sure that order state may be passed as method arguments. Create factories that will cache shared state and will return already created objects. Client should request object with specific state, but not create it directly. Client should store order state, or generate those and pass those as an argument to a flyweight. That ensures the list of actions I did to implement this example. Hope this will help you. And we have the last but not the least pattern for today. It is called composite. In few words, composite allows us to group objects in tree-like structure and interact with objects as with single one. Applying this pattern makes sense only in cases when all your objects may be structured in tree-like organization. For example, imagine that you have online store and you selling different products and also provide service of packing and products delivery. Some products are wrapped in the box that customer paid for. So each box may contain few products. Box may contain other smaller boxes that contain products too. And imagine that you need to calculate the price of the whole order. The first solution that probably you might think of is to iterate over each box, extract it, and iterate over each product inside and sum all the price. Did I guess? But this task might be challenging. You don't always know how much layers you have on each iteration and structure of the boxes. Composite pattern in this case suggests us to take all boxes and product as a single object and get total price at once. For the client in this case, there is no need to know anything about internal structure. But probably the most interesting thing here is how all this is implemented. I suggest to investigate the code example. I am sure that the real example will bring some clarity in understanding of this pattern. Imagine that we are developing some UI. We have common interface for all shapes in our example. Here is shape interface. This is all behavior that should be implemented by each shape. We have abstract class base shape that implements some methods, and concrete shape implementations extends this abstract class. We have circle, compound shape, dot, and rectangle. Nothing special in these classes beside compound shape class. This type aggregates list of other shapes and works with the group of shapes inside. The object of this type may contain multiple shapes and containers with shapes. Container with shapes implements the same methods as a shape, but instead of direct action, it passes the action to the shapes inside using recursion. After that, container sums the results. Client of our code interact with a specific interface and even don't know whether we have simple shape or group of shapes. We have also image editor class here, but this is only specific for our demo and not specific to the composite pattern. This class helps us to visualize the shapes in the window. Now let's open our demo class and see what we have here. I create image editor to upload the different shapes. And you can see that I uploaded circle here and two compound shapes that consist inside from different shapes. The interesting thing also inside the image editor. All shapes are added in one variable of type compound shape. And if you would look on these methods, and in particular on method of inner class editor canvas, you would notice that there are no any loops here, and we interact with all shapes as with single object. You see? Just calling one method and no loops. And for editor canvas, as a client, it doesn't matter whether there is a group of objects or single object behind the reference. That is exactly the reason why we need to apply composite pattern for. And for the sake of the demo, let me run demo class. And here you can see different shapes and group of shapes. Now let's review the checklist. To implement composite pattern, follow next steps. Make sure that you can apply tree-like structure for your components. Create unified interface that will combine operations on the group of objects and on the single object. Create class of single object. Create class for group of objects that implement the same unified interface. Add operations to add and remove components into the container. That's it. Now you have the interface that allows you to interact with group of objects as with single one. Now you know composite pattern. Let's recap what we have learned today. In this lesson we learned three structural patterns. They are bridge, flyweight, and composite. That's it for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson. Hello team, in this lesson we start learning of growth behavioral patterns. We already performed an overview of behavioral patterns and I hope you remember that there are 11 of them. And definitely we won't have time to make an overview with example for all of them in this lesson, but at least we'll start. We'll start from the most popular behavioral patterns in my opinion. And that's why in this lesson we'll learn with you strategy pattern, command pattern, template method pattern, iterator, and chain of responsibility pattern. You can find code examples in attachments to this lesson. We will go over these examples as we will talk through each pattern. Let's start. And we start from strategy pattern. Let me explain you strategy pattern in simple words. Imagine that you know how something is needed to be done. For example, you know how sorting needs to be done, or you know how filtering needs to be done, or you have information how car engine should be started. Now you can describe the logic in code, correct? So you encapsulated the way how something should be done in one class. That is exactly what strategy pattern is about. And now imagine that you know that you need to sort users, but you can sort by first name and by last name. You know that car engine should be started, but the way how electric engine and petrol engine is started are different. What do you need now? You need an abstraction. So you can create an abstract interface and have multiple implementations that will describe how something should be done. Does it make sense? Strategy pattern recommends us to define a group of similar algorithms that are changing or expanding. For example, group of sorting algorithms, group of filtering algorithms, etc. And with this pattern, you don't need to describe the logic inside the client classes, because you encapsulated behavior in strategy that can be used across your app. This should increase code reusability too. Hope it is clear for you why we need strategy patterns sometimes. Let's look at example to understand the details of implementation. Imagine that we have multiple compression algorithms, and I decide to group all compression algorithms under one single abstraction that is called compression strategy. You can see that compression strategy is a functional interface. What is a functional interface in Java? You can learn from functional programming section of my Java course. You can see that I have only one method here, compress files, that takes list of files. That is abstraction that will unite all algorithms of such type. And I have rar compression strategy class that implements this method, and zip compression strategy that implements this method too. For the sake of the demo, I just print text to console here. Having this kind of abstraction, you can include it and use it in different clients. For example, you may have some kind of class where you wanna use compression strategy, and also you wanna be able to substitute compression algorithm on the fly. Here you can see compression context class. We can declare compression strategy field right now here. To set or change the compression strategy on the fly, we have the setter method here. And the main method of compression context would be createArchive, that takes list of files as an argument and where we can do some preparation actions, actually compress files and perform some actions after that one. And being able changing compression algorithms, you can set any implementation of compression strategy, and it will be used to compress files here. Does it make sense? Another version of strategy pattern usage is passing strategy as method argument. This is pretty convenient thing. Let me show you how to work with this compression context in my demo file. First of all, I create an object of a compression context. And by the way, you can pass compression strategy either via constructor or via setter method. The idea is similar. You pass strategy from outside. Imagine that I have a list of files. And now I call createArchive method of my compression context and pass list of files there. And now let me show you another way of passing strategy to the compression context. In Java, if we have functional interface, that means that we can describe interface with lambda expression, and that's why you can pass lambda to our overloaded method. Here I call createArchive method, pass list of files, and lambda expression of my compression strategy that technically also prints text to console. And now overloaded method is called. Taking into account compression strategy is a functional interface, I also may pass method reference that will meet the requirements of the interface. For example, here is a static method inside my demo class that also takes list of files and prints text to console, imitating compression. If you are not familiar with method references or lambda expressions, check the functional programming section of my Java course. But in this lesson, this example is more to show you how you can use strategy pattern in real life. And I am sure that you already used strategy pattern and even didn't know about that. Do you know comparator interface? That is pure example of strategy pattern. That's why I can call sort method on list object and pass lambda expression there, because comparator is a functional interface too. Is that clear? You can press a pause for a minute and investigate the source code that is attached to this lesson. In case of any questions, you are welcome to write a question in the comments. And once you are sure that everything is clear for you, let's review the checklist of strategy pattern. To implement strategy pattern, follow next steps. Identify a group of algorithms in your app. Create an interface for such group of algorithms. Create concrete classes that implements the interface and concrete algorithms. And you know that in Java language you can also use lambda expressions or method references because most likely your strategy interface will be a functional interface. Use the strategy in client code wherever it is needed. That's it regarding strategy pattern. Let's continue. Now let's review the next pattern. Its name is command pattern. Command pattern describes how we can create an object from a request. And actually, we expect to get a lot of benefits from that. Try to think. What are benefits of having request as an object? You can put requests in a queue. You can make deferred call of a request. You can undo operation if needed and others. Imagine that you developed new keyboard and you create software to make sure that your keyboard works well with computer. And you should write code that will process event of pressing each key. And imagine that you should store the code that process key button press somewhere. And this code should work only when button is clicked. And also, you have something else to consider. Such operations as copy and paste, for example, may be performed with a keyboard and with mouse. With keyboard, for example, when you press Ctrl plus C and Ctrl plus V. And with mouse you can do mouse right click and select either copy or paste. What do you have to do? Have this logic duplicated in two places? Or avoid duplication to put logic of copying and pasting in classes? The solution would be to wrap a request in a single object that is called command. This object will contain information about what is needed to be done, and command object may be aggregated by any other object, no matter whether it is a keyboard or an operating system menu event. This request will be stored in one single object and will be invoked by client when it is needed. Group of related commands may be united under the common abstraction to let client rely on abstraction but not on concrete implementations. If you want to understand this pattern better, let me share with you a real-life analogy. You are at restaurant, and waiter comes to you to check whether you are ready to make an order. You order some food, and after that, waiter goes to the kitchen. There he passes your order and the process of cooking is started. So you encapsulated your command in waiter object, and waiter made your order happen. In this example, your requester, waiter is a command and cook is a receiver. You are not in touch with cook directly and not going to the kitchen. You are sitting in the chair and making an order. Does it make sense? Hope you grasp the idea of command pattern. Let's now watch the code example of this pattern. In our example, we will work with the light and commands to turn on and turn off the light from the remote control. In this real-life case, to program such behavior, it is a good idea to use command pattern. Let's start from the client code and we'll go from there. Imagine that we have remote control. That is a separate class. Let me open it. Here you can see that remote control type aggregates command inside. I can set command with this setter method and I can press the one button on my remote control to execute the behavior that is encapsulated in the command. Let's look at command interface. This is an interface that declares only one method, execute. Okay, now let's get back to our demo file. Now we create light object. This would be receiver object. The object that should expect some impact made by our command. Let me open light class. You can see that its state consists only from one field that reflects whether light is on or off, and two methods that change the state of this field, switch on and switch off. Let's get back to the demo file. Now I create two commands. Command to turn light on and to turn light off. I create object of light on command type and light off command type. Let me open one of these because they are similar. In this case, my command aggregates receiver object. You can see I pass light object to the constructor and initialize state of my command object. This class implements command interface. Thus, it should provide us with execute method implementation. And you can see here, inside execute method, I operate on light object. Basically, that's it. In other command, the only thing that is different is that I call switch off method on the light object and that's it. Now let's look how we work with these commands. We are again in our demo file, and let me run this file to explore console output together with you. At first, I set turn on command to my remote control. Basically, That means when user presses the button on the remote control, the lights on command will be executed, and when I press the button on my remote, light is turned on. After that, I set another command to my remote control, and now when user clicks the same button on the remote control, the light is turned off. That's it. Hope that with the example it becomes clear how we'll use our command pattern in real life. Let's create a checklist. Here are simple items to follow to implement the command pattern. Define the common interface for commands and identify the command enter point. Create implementations of this interface. Each command should store the reference to the receiver object. Also, command should store all necessary arguments to pass to receiver. Add command to the requester object, the one that sends the request. Invoke commands method when needed and pass all necessary arguments to interact with receiver. Hope that this checklist will help you on implementation stage in your project. Let's move on. But before we move to the next pattern, let's compare these two, strategy and the command patterns. Because my students always see a lot of similar things between these two patterns, but still, I want to make sure that you see a clear difference between them. Typically, the command pattern is used to make an object out of what needs to be done. To take an operation and its arguments and wrap them up in an object to be logged, held for undo, sent to remote site, etc. There will tend to be a large number of distinct command objects that pass through a given point in a system over time, and the command objects will hold varying parameters describing the operation requested. The strategy pattern, on the other hand, is used to specify how something should be done, and plugs into a larger object or method to provide a specific algorithm. A strategy for sorting might be a merge sort, might be an insertion sort, or perhaps even something more complex, like only using merge sort if the list is larger than some minimum size. Feel the difference? The differences are in the use cases encountered in practice and the intent behind each pattern. Let's proceed learning behavioral patterns. I suggest us to focus on the template method pattern now. This pattern allows us to define skeleton of the algorithms and let subclasses to decide the implementation of specific steps of this algorithm. Subclasses may provide us with implementation of some steps of the common algorithm without changing the algorithm structure. Imagine that you are dealing with the case of data mining, and in your app you allow end user to upload doc, CSV, and PDF files. And once you found that some steps are common in all cases, you always upload file to some temporary storage, after that you retrieve data from it, after that you parse this data and send to a database. Basically, the algorithm of data processing is the same for different types of documents. The only thing that is different is the way how data is retrieved from the files of different format. That's why it might be a good idea to create a template method that describes each step of this algorithm and that gives implementation to the common steps instead of having this code duplicated, and have specific classes that implements one step in this algorithm. Following this approach, you will reduce code duplication. I also can come up with the analogy from the real life. Imagine that you have a building company that builds houses. In all cases, you have the same steps to follow during house building. You should agree on architecture, prepare a basement, create walls, install doors and windows, and so on and so forth. The algorithm of house building is the same, but each step can be done differently. Different doors may be installed of different sizes, different roof types, and so on. Let's now check the code example of this pattern to understand the details of this pattern. In our example, we plan to create template method for mobile app compilation. Template method is located in cross-compiler class. It is called compile. This algorithm consists of the next steps. Collect all necessary sources for compilation, reserve some RAM, compile sources to target archive, and share compilation status. We have also so-called hook method here. Hooks are special methods that is not mandatory to override or implement, but they give additional opportunity for various algorithms to add some behavior as we go through the main steps of our algorithm. You can put these placeholders methods in any place you think would be logically reasonable for scaling in the future. And some of these steps are common for all compilers, and some of them are not. For example, reserving RAM and printing status is the same step for different compilers, and you can see implementation of this method here in this abstract class. But some other methods are abstract ones, because implementation will depend on the concrete implementation and the specifics of mobile operating system. Pay attention that this is an abstract class so that no one can create an instance of this object. And we have classes that extends this one. We have Android compiler and iPhone compiler classes. Both extends cross-compiler and implements necessary steps that are not implemented in a parent class. Now, let me show you the client code. Here is my demo class. I create iPhone compiler first and call compile method. And after that I create Android compiler and call compiler method. Let me run this code. And in console output you can see that algorithm is the same for both iPhone and Android compilers. And some common steps executed twice. Here you can see how subclasses give implementation to some of the steps in my algorithm, but algorithm is the same in general. One of the obvious drawbacks is that algorithm is hard-coded, and you have to rely on inheritance mechanism during implementation of this pattern. You can't change algorithm or introduce new steps. That's why this is not super flexible, but on the other hand, helps us to avoid code duplication for some groups of operations that have similar algorithm. Let's look at the checklist to implement this pattern. There are a few important items to remember when we implement template method pattern. They are: examine the algorithm and think how to split the algorithm into different steps. Create an abstract class and define template method there. Put each step of the algorithm in the separate method. Describe method invocation sequence in template method. Identify places for hooks in your algorithm. Create concrete classes that implements the required steps in the algorithm. That's all regarding template method. Hope that now you know how to implement template method pattern in your application. Let's proceed with the next pattern. The next pattern is iterator. If you have ever used Java Collections framework, you may already understand what this pattern is about. And all Java engineers may enjoy the implementations of iterator pattern in JDK. But in case you are not a Java developer or will code on another programming language, most likely you would need to implement iterator pattern from scratch by your own. In short, iterator is behavioral pattern that allows us to go over each element of an aggregate object sequentially without exposing its underlying representation. Why this might be needed? Imagine that you have some aggregate object, and no matter whether this is an array or some other container, you don't want to understand the internal structure of the object. The only thing that you need is an interface that will allow you to get each element of this object one by one, because the structure of containers might be different. Some of them vectors-like structured, some of them are tree-like structures. It is not always convenient to understand internal structure. It is better to have the single common interface to iterate over each element. So the idea of the iterator pattern is to put all logic of iteration in the separate class. Iterator would also track progress of the iteration and state of iteration. Let's now look at the code example. And this time I will not create any custom example, and I will perform the demo on the example of JDK. Imagine that we have some container, and it is really don't matter whether I have array-based container, linked-based container, or even hash table-based container. Iterator interface will be the same and will help me to iterate over each element in any container. Here in demo class I created objects of array list. This is a container that is based on the array. I created linked list. This is a container that is based on the linked objects. And I have hash set object. That is container that is based on hash table. Basically, no matter what object I will take, each object can provide me with the iterator. And here you can see that I get iterator for each collection. Let's look at the iterator interface. In this particular case, iterator provides me with method hasNext, next, and remove. I would say that these methods are bare minimum for iterator, because in addition to these ones, it is also possible to implement other methods for navigation. For example, methods for navigating in other direction, like previous, method for verification whether there is a previous element has previous, method to get index of the current position, method to add new element during the iteration of a container, method to substitute last returned element, and in JDK we have list iterator, but it works only for list hierarchy. Anyway, it will be up to you what methods to implement in your iterator. hasNext method tells us whether there is a next element in the sequence. This is super useful method to build condition in loops. Next method returns the reference to the next object in the container, and remove method removes the last returned object. Basically, that's all interface. Implementation of this interface needs to consider storing the state of the iteration to remember what item was returned the last and what next element I should return. And we have single iterator interface for all types of containers. In the case of Java Collections Framework, it is duty of each container to provide client with implementation of iterator interface. Let's now switch to ArrayList class. When I open source code of iterator method, I see that according to method signature it returns iterator type. But what implementation of this interface? Here you can see that new object of iter type is created and returned. What is iter type? This is inner class of ArrayList that implements iterator interface and implements all abstract methods. As you can see, we built our code by relying on abstractions, and iterator interface is one of them. And each container in this case is obligated to provide iterator implementation that knows the structure of this container and how to iterate over each element inside this container. Basically, that's it. You can implement your own iterator if needed, following this example. Now let's create checklist for iterator pattern. Define iterator interface with at least hasNext and next method. Other methods may be added too, as we discussed in our example. In your object that serves as a container, declare a method to return an iterator. Create implementation of iterator interface for collection that you need to iterate over. Client requests iterator and use it for iteration over elements in container. Great! We learned iterator pattern. And now we are going to learn the last but not the least pattern for today. The next pattern that we are going to learn is called chain of responsibility. This is pattern that allows us to process single request by multiple handlers. We build handlers in the chain, and each handler either processes the request or passes the request further to the next link in the chain. There are a few simple examples where chain of responsibility is widely used. In web applications, there is a concept of request filters. Imagine that you are sending a request to the specific page, let's say admin dashboard of your online shop, and there is a sequence of filters your request should go through before it reach endpoint and server would return you the admin dashboard page. For example, the first filter might be the login filter. This filter handles your web request and verifies whether you are already logged in or no. If you are not logged in, your request is not passed through the chain to the next filter, but instead, you are redirected to the login page. The next filter might be authorization and authentication filter. This filter will verify your user in database and will check what role and privileges your user has in the system. If your user has admin role, you will be finally redirected to the admin dashboard page. If no, you will be redirected to error page where you will see notification about not having enough rights to access this page. And these filters are built into the single chain and your request passes through each of them, because each filter has the reference to the next one. And one more important thing, hope you already understood this from my example, that it is not necessary to pass the request through the whole chain. It could be that some element in the chain decide to stop processing. Hope that high-level overview of this pattern is clear. Now let's jump to the code example. In this example, we'll create with you software for ATM. We'll build with you chain of multiple dispensers that will help end users to get the cash from the ATM. Let's go one by one. We have an interface of dispense chain. Let me show it. It has two methods. setNextLink that takes object of the same type as an argument, and actually dispense method that dispense some currency. What is currency? This is another type wrapper that contains information about cash units in one node. Next, we have implementations of dispense chain interface. We have $50 dispenser, $20 dispenser, and $10 dispenser. They are almost similar besides the value of the node that they are working with. And to be honest, this may be rewritten with one single class, but for the sake of the demo and for visibility purposes, I decided to keep all these classes to make sure you understood chain of responsibility pattern. Let's now look at the dispense method of any of these classes. We get amount from the currency object, and if it is equal or more than the value of the current dispenser, then we perform next logic. We get a number of nodes that we need to give our end user, and if there is some remainder, I pass this request further with the new currency object with the value of remainder. Pay attention that each dispenser has reference to another dispenser in the chain. This first if condition verifies whether this dispenser is allowed to process this request. If not, in our particular case, I pass the request further to the next dispenser. Is that clear? Let's now look at the client code in our demo class. In my demo class, I have field of type dispense chain. That would be my whole chain with all links in it. In constructor of the demo class, I create instances of all dispensers and connecting them in one chain using setNextLink method. So here we can see that $50 dispenser is the first link, $20 dispenser going next, and $10 dispenser is the last dispenser in the chain. Now, when I have my chain constructed, let me run this program and explore main method with you. The first thing that I do in main method, I create the object of this type that contains dispense chain. After that, I create infinite loop and I ask user to input amount that he or she wants to get from the ATM. Let's imagine I want to dispense $120 and I see that ATM already calculated how much notes it will give me. It will give me two $50 notes and one $20 note. Now let me request $80. This time ATM will give me one $50 note, one $20 note, and one $10 note. Can you understand how it works? When I call dispense method here, I start the request processing by my method chain. One important thing that we didn't talk yet. You should always bear in mind the logic of chain processing to understand what is the condition of completion. In our particular case, I have verification on client side here. It is not allowed to request dispense amount that is not multiple of 10. And I have $10 dispenser in my chain. That means request will go till the last link in chain for sure. because one of the risks that you may face with during implementation of chain of responsibility pattern is that your chain will leave your request unprocessed, just because conditions in each link were not met and none of the items in your chain processed the request. So be very careful by thinking about your condition of completion in your chain of responsibility. I hope that with this example it is clear how chain of responsibility works. Now let's review checklist to implement chain of responsibility pattern. Create interface of event handler and declare a method of event handling. Make sure that each implementation of the chain interface may contain the reference to the next link in the chain. Each chain interface implementation contributes to the event handling. If the request is needed to be passed forward, link object calls the method on the next element in the chain. Client creates chain depending on the business logic and launches chain from the root. That's it regarding chain of responsibility pattern. Now let's recap what we have learned in this lesson. In this lesson we learned 5, in my opinion, the most popular behavioral patterns. They are strategy, command, template method, iterator, and chain of responsibility. Thanks a lot for your attention. Have a great day and see you in the next lesson.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.